I'll grab for you, and I will tell all the same as yesterday.
So
No, actually,
yeah, you should go first. I'm gonna go right to my talk.
yeah. Okay. Good morning, everybody. It's very nice to see a lot of happy faces in this shiny morning. I'm very happy to welcome you to the second day of the Electric Vehicle Battery and Recycling Forum. I hope you enjoyed the first day and had a restful night. Just like yesterday, let me share a few organizational remarks with you. All networking breaks will be held in the hall right outside. Lunch will be served in the room behind a glass door after elevators hall. All the restrooms are on the right at the lunch hall. In case of emergency, please follow the green exit signs and note that the muster point is located outside. Our staff are here to assist you with any concerns or questions. I would like to remind you to fill in the evaluation forms that you have in your folders and hand them to me or my colleagues at the registration desk, as your feedback is very important for us. If you have anything you'd like to discuss with me or our team, feel free to speak to me or my colleagues. And our chairman for today is Dr. Cameron Lippert. That's all for me. Enjoy the conference.
Thank you, Maria. I think yesterday was a very good session. Lots of collaboration, lots of networking, lots of discussions were happening. And that's really the whole point of this event. It's smaller, it's a little more intimate. So go have those discussions, meet new people, exchange ideas. So a big thanks to the lead event group for kind of putting this together and having it run smoothly. If anyone's ever done logistics or event planning, it's not as easy as it looks. And also a big thank you to the speakers. We were on time yesterday. Everybody respected the time clock. So thank you for that. And hopefully we can continue that today. It's going to be a 20-minute speaking session with 5 minutes of Q&A and a little bit of buffer in between. So try to respect the timer. We got a big timer here. When it turns red, that is officially entering the Q&A session. And I have the pleasure of kicking us off with the first presentation. And today, hello, one. And today I'm going to talk about some innovations and how really we need to get new ideas to bring battery recycling up to the forefront and compete at a large commercial scale. So my company, what we do is we kind of develop innovative technologies around circularity. Our whole goal is to turn industrial facilities into sustainability leaders through waste valorization. And we do this through using innovative electrochemistry to be very selective at removing and recovering metals from water streams and pulling them out as high purity metals. So this can close the loop on waste to value and keep all these key critical minerals in the economy. We hear a lot about nickel and cobalt and the big demand they have with the surging EV market. Now, with the rise of LFP, it might not be as important, but one thing we don't really hear about is copper. Right? Copper is absolutely in critical importance to this infrastructure. Not just do the EVs have it, all the circuitries have it, all the charging infrastructure has a lot of it, and all the power generation, solar cells, wind turbines. Copper is critical. We're already at a massive supply gap to meet demands. It's only going to get worse as we go forward, unless we have new sources. And today I'm going to focus on the hydromet process specifically, looking at 2 different pathways. If you look at pathway 1, which is pretty common, of making battery grade salts. Split them all up, make your salts. It's more of a commodity type process. And pathway 2 is going straight to a higher value PCAM, CAM-like product. And we're seeing both of these models happening today with a variety of recyclers across the globe. But I'm talking about in all these processes, purity is important. If you can go into a battery, you have to have the highest of purity. I think everyone here understands why. We don't need to go into it, but it's critical for a variety of reasons. And really looking at sort of different products you can make and what you need to be a sustainable business: purity, yield, and economics. It's very easy to hit 2 of these points. Very, very hard to hit all 3, especially as you scale up. Lab scale, small pilot, bench scale, pretty easy. When you're doing tens of thousands of tons, 100,000 tons a year of black mass, it gets very, very hard. A lot of the thinking I'm hearing from these recyclers is, oh, it's just like the mining industry. It's just a different ore. It's not the same. The scale is not the same. The yield requirements are not the same. And the purity requirements are not the same. So looking at the purity, that is sort of the pinnacle of what is required to be successful in this business. If you don't have purity, you have a technical grade, you have scrap grade, you're not going to make much money. It's all a commodity. So at that point, you better be really massive scale and have very efficient processes. So just pulling some rough numbers from a variety of vendors on their CAM materials and the purities they are seeing, because it's very hard to get this information out of the battery manufacturers. It's kind of their secret sauce. They don't want anybody to know what's actually in there. What you can see is it's very, very small amounts of all these other materials. So this is the kind of purity levels we got to hit from recycled content to validate it with these battery manufacturers. And then looking at sort of the different products you can make. So take these numbers with kind of a grain of salt. They change drastically from day to day based on a variety of markets. But in general, you're seeing pretty significant value changes based on making a tech grade metal salt versus a PCAM type high value product. Now, the key difference though is if you're making more of a commodity chemical, you have other markets you can go into. If you're making a battery grade salt or a PCAM material, you pretty much only have one market to sell into. So these are the questions you need to ask yourself in developing your business plans if you're a recycler. What is the end goal? What is your risk tolerance to future regulations, et cetera, on what product you want to make? Variety what we're seeing is that they want the high value material. If you are not, if you don't have a lot of partners to be vertically integrated, you tend to want to do all yourself. So all these kind of single recycler operations want to make high value material. If you have a lot of partners, you can do metal salt, your partner can do PCAM, you can then both get the value of that. And so I've really done a lot of work talking to recyclers really everywhere outside of China, trying to put together, what is a good model of sort of economics? What kind of scale do you need to hit to have it be viable? And this is sort of a very high level, right, kind of back of the envelope calculation of what I'm seeing. Where if you have the screen line here is going to be sort of the high value PCAM, blue line, metal salts, and then MHP. MHP is pretty easy to do. It scales well, but there's not a lot of margins there. It's pretty low value material. And just a few pinpoints of data I've seen from actual recyclers getting their actual numbers of what they're doing with some of my own interpretation on how it's going to work once they scale to commercial scale, right? The amount of scale factors I'm seeing, people are going from lab scale, bench scale, doing maybe a few kilograms of black mass refining and designing a plant to process 100,000 tons a year based on that data. That's not going to work. Building plants is hard. It takes you got to have a pilot plant. You got to have something in that mid-range, a couple thousand tons a year at least, right? A 10x scale factor, awesome, right? Even 50x, I think is viable for a lot of these processes. But what I was seeing is if you're making battery salts, or you can get this mid-range where it just doesn't work, the process is not efficient enough in that mid-range because it's usually a pseudo batch. You have chemicals, solvent extractions. It gets complicated. It's a commodity chemical, so you need that scale to get the value and to get the efficient process out of it. Whereas if you're making a PCAM or a high value product, it's harder to scale to massive volumes because it's a very complex process. But again, you have a very high value product. You have a lot more room for error in the process to create your product. What we're talking about is purity, right? Purity is the goal. If you don't have purity, it's just commodity. No value there. So there's a whole variety of methods to hit the purity you need. I'm going to mainly focus on copper and manganese. Those tends to be the biggest challenges from these two pathways. And one of the most standard ways is chemicals. You precipitate it with base, which works well, but you get a lot of other stuff out too. Nickel comes out. If you're not very careful, you have to pinpoint exactly the right pH And even then, it's tough. You're going to have yield loss. So you can do sulfide precipitation. You can do it more acidic. You can be very selective for copper and not really touch your other metals. But sulfide chemistry is really nasty. It makes H2S gas at the acidic concentrations. Not fun stuff. No one likes doing it, and it smells really bad. Ion exchange can work pretty well for a lot of these metals, especially copper. But because of the complex matrix we're in, there's a lot of competition. When you have tens of thousands of ppm, say cobalt, and 100 ppm copper, you're going to have competition that you have to basically preload the copper on cobalt first, and then you can get copper. So it's a very challenging and burdensome operation to do. You don't have a lot of insight on your process. So making sure it's working is going to be challenging. I'm not a fan. Don't do it. So really looking at copper here, this is some samples we've gotten from a client where they were trying a variety of chemical methods to get it down to purity, and really just can't do it. They want to get below 1 ppm of copper, and the only time you get close, you have a lot of other yield loss with it. And this is some data I repurposed from a paper from Fraunhofer looking at yield losses. If you're trying to use chemicals to get copper out, you will lose some cobalt, you will lose some nickel. You can just look at the reference here, look it up. It's challenging, right? You need very precise operations, and it gets more challenging as you get larger in scale. And for manganese, the go-to process is Caro's acid. So you can add some oxidizer, make manganese dioxide, precipitate it out. Works very well. However, it's not selective. You're going to lose cobalt by doing this, and that's a high value product. So what we want to do is, can we use electrochemistry to do this? Electrochemistry has been known for a long time in the mining world. Electrowinning is not new, but we don't have the same kinds of streams. Mining has very clean, very high purity type streams, very high concentrations. Most of these black mass leachates, very complex, not conducive. Can't hit the low targets you want. So what we did is we took a different approach, changed the reactor design, used high surface area carbon-based electrodes. So one, they're cheap. Two, we have a lot of area, so mass transfer isn't a thing. You can get down to very, very low concentrations. And it's the same reaction. We're taking copper ions and plating them out on our cathode and making O2 on the other anode. Oh, the key here is we're only flowing water or the black mass leachate through this channel here. You just have residual wetness through that side reaction. So now like 99.9% of the reactions are that copper ions to copper metals. And then we can flip it for the manganese. We're just going to skip some science there. But by modifying the reactor design, you can now go across the entire needs of these various metals. Right, so you can go from high concentrations all the way down to very, very low concentrations with a single technology. And the less technology you can employ, the cheaper, the more cost-effective your operation is going to be. And we do this in a sort of a two-step process. First, we load it up in our cell. Then we do a second loop, which removes it from our cell and creates this high purity metal. Very similar to a lot of membrane-based operations, this clean in place type operation. And where we fit in, at least in the metal salt production, is early on, we can do copper removal. And then after doing all your solvent extractions, you make your cobalt product. So either right before that or right after that, we can target the manganese without losing cobalt. If you're going straight to PCAM, again, earlier we go is copper, cadmium if it happens to be there. And once we hit end of life batteries, I guarantee you're going to start seeing cadmium. And then after you make your sort of NMC mixture, if you want to upscale your product from, say, a 532 to an 811, you either have to add nickel or remove manganese. So what we can do is just remove a little bit of the manganese to get that ratio adjustment to get the product specs you want. So here's some data from one of our clients where they want to do this NMC precipitation, go straight to PCAM. So they want to not touch the nickel, manganese, cobalt, and just get the copper out. So you can see once we turn our cell on, thousands and thousands of ppm of nickel, manganese, cobalt, trace amounts of copper. Once we turn it on, it drops right down to less than 1 ppm. Very selectively, very efficient. And here you can see, how we load up all this copper in our cells. It's very, very dense. So we have very small footprint, very high capacities. Again, same thing for the manganese removal from cobalt. So if you want to make a cobalt product, at the end, you usually have a high concentration of cobalt sulfate. Well, put it through our cell, you can get that trace manganese down to well below purity requirements. Again, looking at other ways to recover yields. If you're doing solvent extractions, you're gonna have crossover. You're gonna have some small amounts of nickel and cobalt in your DEPA, in your manganese impurity circuit. Again, we don't care what the stream is, how complex it is. By our operations, we can target one metal specifically or multiple metals specifically. But on top of that, because we're electrochemical, all these sensors are needed already to get remote monitoring, remote operation, machine learning, state of health, system health, analytics, diagnostics. And so we spent a lot of time developing sort of our background IoT type package to make the operation more efficient, more aware, so operators know what's going on, operators can see exactly what's happening. Right, so based on the voltage, current, just how your battery knows how much phone life you have left, we can tell you exactly how much metals we're pulling out. We can track things like pressure drops across the system, so you know it's working well, and if something is going off, we can tell you before something catastrophic happens. Right, and then this is stuff you will not see for any phys chem process. If you're doing chemicals, how do you know it's working right? You have to either pull grab samples, analyze it, and then adjust your chemistry based on that, or just toss it in and hope for the best. Right, so real-time insight will be key for productivity and efficiency in the operation. And we're showing here is the modularity and how to scale it up. We designed it to be modular so it can go from very small scale to very large scale very easily. Electrochemistry scales up very well. Nice small pilot skids, it's like a water softener type size. But then you look at the skid here on the right, where each one of these little reactors here can process a significant volume of the leachate. And if you want to increase your process, you add on more modules. If you have upstream mishaps, if your flow is dynamic or you get some unknown impurity, it kind of self-adapts and self-adjusts based on the IoT, the machine learning we built in. The electrochemical responses are very, very selective. They're very specific, very sensitive based on the incoming feed stream. So with that, we have plenty of time for questions.
One.
Do we have any questions? Do we need more coffee first?
Yeah, hi. Maybe a first question to start off. Interesting technology. How far has it gone into market?
We have been in the market in the battery stocking space for about 4 years now. We have a set of skids that are currently operating on a 12,500 ton a year black mass refining facility. So fully commercialized, fully in market.
That's over in the US or in Europe?
In the US.
Okay.
Nothing is currently installed in Europe. And we have other systems that are being installed in Taiwan and Asia, but different markets.
And what type of different markets?
Semiconductor, wastewater.
Okay, cool. Thanks.
I'm Sujiva from Mobility Alliance. I'd like to know about the base costing of the smallest operation of this kind of a nature, because that's what revolving in my mind from yesterday and running into because the scale matters.
No, cost is all that matters, right? So we do a lot of value-based pricing, but if it's not cheaper, no one's going to buy it, right? It has to be the most economic option out there. So when you look at the black mass refining, it's a product, right? Making a product, it's revenue making side of business. So there we tend to charge a little more based on that value. Whereas wastewater, it is absolutely race to the bottom. So there it is, almost no CapEx, and the OpEx is pennies per gallon. If you want to give me a specific idea of a stream and facility, I can give you more ideas of that range, but it's all going to be a mass basis. So if you have how much pounds of metal per day are you processing, whether it's highly concentrated and low flow or high flow, low concentration, it's all the same. It's pounds per day being removed. It tells you how many reactors you need. And obviously how many reactors you need gives you your CapEx and OpEx costs. But the sort of fixed cost is going to be electricity, which is in the watt hours, not kilowatt hours per ton of leachate being processed. It's rounding errors. Most of the energy cost is from pumping the solution around.
Arndt Bühler, Daimler Truck. We have heard yesterday that getting permissions takes some time. So you are not using chemicals. Can you say about the time needed before ramping up or installing and permissions, please?
So we're not a recycler, right? We are an equipment provider to the recyclers. So we don't do any permitting, any of that type of stuff, any permissions. So the facility will probably already have that permitting done outside of us, at least in the US. We've had some challenges in Germany where they had some sort of early engineering design was approved, and it was about 2 years to have to just change that process, regardless of what was going in to replace it. So we're looking to replace an ion exchange process, and it took 2 years. That's they don't care what you're doing, just that's the bureaucracy, right? But we have no chemicals. It's all UL CE certified, so it's pretty standard stuff there.
Thank you. This process, you already applied for cell manufacturing or just for recycling? Because it's also, I think, adjustable for cell manufacturing, correct?
Really, we're agnostic. If there's some of these metals in any aqueous stream, whether it's drinking water, processed water, acid, wastewater, we don't care. The battery manufacturing side, we've done a lot of work in lead acid battery manufacturing. The lithium ion is a little more challenging. That water is different. It's usually solid metals, not dissolved in the water. They're the challenge. But for us to process it, it has to be dissolved. Otherwise, you just get a physical filter to recover it.
I think that this can be a good idea to integrate, in fact, in the cell manufacturing facilities.
Yep.
Because the big challenge in cell manufacturing is the impurities, as you know.
Mm-hmm. Yeah, we've done a lot of work where we're purifying stuff going in, mainly in the semicon market where they need really high purity stuff, where you can pull out, done like a few parts per billion of silver in a copper sulfate solution that's being sold to a semicon fab. So we don't care. It's more of, for us, what is the lowest hanging fruit? What's the easiest take to market? What's the highest value we can give? Because there's, for most waste and purity things, there's, dozens of options you can do. And so it literally is a race to the bottom. And all the stuff we do, like these IoT, the services, labor reductions, a lot of facilities just don't care. Right? Production people care.
Yeah, sure.
Operations care.
Yes, we do.
Yeah. Probably have time for one more question. All right. Well, if no more, then we can move on to the next presentation. We have Matteo Martinelli. Yep, the global head of business development automotive at Tesa SE, with over 20 years of management experience across various countries, North America and Europe. Quite the feat. We're looking at developing technologies, products, really all things adhesive for the automotive industry. I think it's the only speaker we have around that topic here. And it's one I rarely hear at a variety of these conferences. It's always so focused on batteries and cars, but yet the adhesives, all those supplemental stuff are going to be absolutely critical. Teo.
Good morning, everyone. Pleasure to be here. Thank you, Cameron, for the introduction. I feel like I'm changing subject quite dramatically here because we are talking about adhesives and in particularly adhesive tapes. And of course, yeah, you can see the title of the presentation, which is Debonding on Demand Solutions. But before getting into the topic, maybe I need to introduce you a little bit about what we do actually for the battery industry in adhesive tapes and why I am here and why battery recycling is actually a very important topic to us. First, this is a simulation where you can see a lot of applications of adhesive tapes for the battery assembly, from the pack to the module down to the cell. All the red parts that you can see in the graph and also the blue parts are actually adhesive tapes that we supply to the battery industry. And of course, you can imagine all adhesive tapes have to do with the bonding of and fixing of components, but also this bonding comes combined with other features like electrical insulation, like thermal management, fire protection, encapsulation, just to name a few. So, of course, also inside the cell, we have some applications where the tape is being used with tapes that are chemically stable, so electrolyte resistant. And those are used for all kinds of processes within the battery manufacturing stream. And why are we here? Well, because actually in our corporate strategy at TESA, we definitely want to become pioneer in driving sustainability. And we do so with quite a few number of challenging targets that we have set for ourselves in our corporate strategy. And as you can see, one of them, the last one actually, is enabling sustainability for our customers. And this is definitely one of the main pillars of what we do to drive sustainability. And you will see how in the adhesive industry, actually always related to the bonding, but when it comes to the possibility of actually making this bonding reversible, that opens a whole world of new solutions. And that's actually the dream that we have for the automotive division, where you have all tape applications, all bonding applications that at a certain point of life of the vehicle can be easily debonded and allowing easily replacement and repair and disassembly for easily recycling. So that's, of course, our dream, our vision. But when it comes to battery industry, of course, debonding becomes a very critical topic. And I think you all understand why. Because actually it has been mentioned, I think, quite a few number of times yesterday in many presentations where the debonding is always very, very tricky, and actually one of the main hurdles in technologies to make disassembly and repair and access to the battery components easy. So this is why TESA is interested in battery recycling and why I am here to talk to you today. So we are basically enabling with the technologies three main functions, three main benefits, which is reworking at the industry side, repair during the life cycle, and of course, after life cycle, the easy recycle. Of course, when I talk here, when I mention repair, I also include what we have mentioned yesterday, refurbish or repurpose. These are the technology approaches that we currently have developed for enabling customers to do so. We have three different technologies that approach the same topic from three different angles. Starting from the left, we have a product where the technology is based on what we call a passivation layer. This is quite a simple approach where you can imagine a double-sided tape where one of the sides is passivated, and it's passivated only for a certain period of time. Usually it is around 5 to 7 days. So that allows any bonding that, for example, the seal of the battery pack where you have the bolts and the screws and everything that is tightening together the lead, but then you have the seal that is not bonding for 1 week, and that allows customers to fully rework the battery for that period of time. After that period of time, the passivation layer is eliminated by applying the pressure, and then it becomes permanent bonding. Then we have a second approach, which is also enabling easily repair and recycle at the end of the life cycle, which is bond and detach, where basically the trigger of debonding is made by stretching the tape. Actually, I think that you all have this technology on your pocket right now, because all of the cell phones, all of the smartphones are having this technology to hold the battery into the housing of the cell phone. And those strips can be then pulled so that the battery can be easily demounted from the housing of the cell phone. This is exactly the same product, but adapted for the automotive requirements. Last but not least, we have the structural debond on demand by Tesa. And what is this doing is actually overcoming the main obstacle or limitation of the bond and detach technology, because the bond and detach can only reach the typical bonding strength of an adhesive tape. So that is still below 2 megapascals. So definitely not into the level of structural bonding, but this one is actually allowing to reach structural bonding performance with up to 10 megapascals of dynamic shear strength. And by triggering with energy, some different methods of energy delivery, you can trigger the debonding mechanism. And I will go through these 3 solutions very quickly. First one, for the box seal, we have here a video that explains the principle. Of course, in the battery industry, you do not only develop products, but also processes to make it scalable and easily integrated into the industrial process. So here you have a robot head that is applying the seal of the battery lead, and then allows a very tight sealing of the battery box. And as I explained earlier, within a few days, you can just simply pull the tape off and pull the tape, the lead. And this is actually in different electric car vehicles that you can buy today. Of course, the reopening of this solution after not days, but after months or years, it becomes still more challenging. This is not fully debonding. So that's why you can still do it. But of course, it requires particular methodologies and definitely requires still a lot of force to pull it off. So that's why we say that this is actually a very good solution for rework, not so much for repair and recycle afterwards. Second technology, bond and detach, is also available in the market and is being sold in different applications. And here you can see the principle of the tape is, as you can see in the video, is just pulling the tape, and by stretching the tape can easily be removed without any kind of residue. And this again is exactly the same technology that you can find in all your smartphones currently. And here we have developed different solutions for different bonding of components in the battery. You have here, for example, bonding of modules, where the tape is just pulled with different mechanisms that you can design in the battery architecture to allow easy debonding. So getting to the last and most interesting one, and also the most challenging one, the structural debond on demand. This is where we can reach up to 10 megapascals, definitely. With actually, we are tailoring the bonding strength according to the application requirements and the technical profile requirements from the OEM. And here the topic is also making sure that after the trigger, the debonding becomes very, very easy and without residues. We are developing different debonding triggers. As you can see, you can trigger the debonding in different ways. And the one that is currently closest to launch this year is the electromagnetic induction debonding. And it's going to be soon available according to an OEM SOP. I will explain you a little bit how does it work. Not too much into the detail, I hope, but yeah, the principle is quite easy to understand. You basically apply the tape as a layer of the structural bonding of different components. So you can imagine here, for example, a battery pack where you can have module, but also cell to pack configuration. You would have structural tape to the top lid and also to the bottom cooling plate. The tape is quite thin, so that's why you still, for big gaps, you still need structural glue for gap filling purposes, but you can apply the tape as a layer into this construction. And then after this construction is made, you would apply the trigger, and that trigger would immediately allow to debond very easily and very clean the components. You can do that also selectively, and that allows you to eventually, for example, have access to only a particular part of the battery architecture. Just to show you that this is not only a concept or an imagination, but also something that is real, I have here brought you a video where you can actually see a mock-up that we have made and that we are developing together with the OEM. Here you can see some cells and simulation of the battery box. And actually what I would like you to observe here is this black part, which is the adhesive tape, the structural tape. The blue is just our normal wrapping tape that we use for electrical insulation of the battery cells. So the black part is actually the structural tape. And here you just simply see the wire, which is a temperature sensor that allows you to read the temperature that the tape is reaching to enable this debonding. Of course, the concept, as explained, is used to induction heating. And here you have the induction heating device that is allowing the cell to be actually debonded. Of course, the temperature is getting higher, and I have to put some protection for IP here, but of course, this is actually one of the elements that we can develop tailored to the needs. But actually, as you can probably already see, that the tape is starting to react to this heat, and that allows the tape to trigger the debonding mechanism. And in the end, in a few seconds, you can see that the cell is fully debonded, and hopefully very soon you will see how the person here in the lab is able to pull the battery cell off. Yeah, that's how the tape works. And again, that's how the structural bonding strength is easily debonded. Of course, as I have explained, sorry, that was too quick. Yeah. You can also trigger the debonding through different other energy mechanisms. This is the experiment that we do with the electrical trigger. And as you can see in this very video example, is a structural tape that is debonding with a simple 12-volt input. So these are the technologies that enable debonding. So that are the technologies that make the bonding reversible, and those are the ones that we are now proposing. So that's all from my side, and I am open to any questions that you might have. Thank you very much.
Thank you, Mateo.
Lucas Brandl, BLC. Thank you for the presentation. It was very interesting. You're using temperature to solve your tape and to detach the cell from the system itself. Do you see any issues with the temperature coming in the cell itself by destroying it, harming the other ones next to it?
Yeah, that's exactly why we are developing different trigger mechanisms, because depending on the final application, you cannot simply apply one or the other. In this case, we are applying this one because it is required to be selective, so that allowing the customer to replace single cells. And that's why I actually blocked the possibility to look at the temperature, but the temperature here is tailored in a way that the cell is not reaching any close to the window of potential risk for the cell. So here we are, the cell is never reaching 60 degrees Celsius.
Okay, so your temperature window should be very small, because I mean, during the typical usage of a battery, it heats up itself. So
exactly. So it has to be, and that's why the trigger is very, very important to be to allow the heat to hit the tape very quickly, and in a way that the tape gets very hot very soon, but not that the heat is not transferred to other components in the bonding.
okay, and then one last question.
Yeah.
If you did the process by heating up the tape is broken, or can you reuse it?
No.
You destroy it and then you.
Yeah. The process is reversible. The bonding is reversible, but the tape is not, definitely.
Okay, thank you.
Yeah.
A question over here.
Thank you for the presentation again. Related to the use of the tapes here, the thermal conductivity of the tape you propose is high or low? It will be interesting to know, because you, as far as I see, you hit the module site, but tomorrow we will not have the modules, and we go to chassis, one of the discussions, and everybody works on that, and we have already successful results. Once it comes to the chassis, how we will manage. We have to hit the chassis, and also the thermal conductivity will count not only for the cell, but also for other components. This is the first question. And secondly, you said that the tape, once it is debonded, so it is not useful for anymore for any other purposes. So it is also recyclable or not, this tape?
Yeah. So in terms of conductivity, the behavior of the tape has actually two different properties. One is because of the very thin design, it allows very good thermal conductivity on the Z-axis. So for example, here I've shown a real application we are developing where the tape is applied to the cooling plate. So it has to allow the heat transfer, because otherwise the cooling plate would not work properly. So that is good, but on the surface direction, the heat transfer is not so good. and that allows the tape to be very selective when it comes to applying the heat to one cell only and not to the neighbor cell. So that is quite how the tape behaves. Of course, we are also in the roadmap of development. We are trying to get into thicker solutions that would not need the glue. And of course, for those solutions, we need then to develop tapes that have the concept of thermal conductivity even further developed. But this, we are not that far yet. Yeah, the tape itself is not particularly recyclable in the, so the tape after the bonding. Yeah.
Right. So how well do the tapes age? Do they degrade over time?
Of course, all these tapes have automotive grade. So all of them are aged according to the standard cycles in the automotive industry. So that's definitely not an issue. Actually, you can, so without getting too much into the technical details, you have to think that we have been developing tapes for more than 100 years. So the bonding part of it, it's exactly the same in the product itself. But of course, the tape has some other ingredients into the formulation that allow the debonding trigger. So that's the tricky part. But in terms of reliable bonding, the tape is actually behaving exactly as it used to be. So from that perspective, it's absolutely safe and appropriate for a lot of automotive applications that we are currently selling to many OEMs.
Do you see this as a viable approach to not just design for recycling, but design for safety, design for manufacturing? Could you hit all three of those with these types of innovations?
Yeah, and that's definitely let's say the challenge piece that is still in development is to make this concept really scalable for disassembly, because actually for tape application, again, we are used to develop a lot of robot applications for a lot of output and reliability in production. But disassembly is a process we are not used to, and I think the industry is not used to. So that's where we are still in the development phase of making this process truly industrialized and reliable, for not only for thinking that an OEM can make the disassembly, but also making the disassembly possible for a service, so it has to be a very solid concept around it, and we are still working on this one, but it's getting close.
I do understand your intention with the debonding. Yesterday we heard that recycling often uses shredding. So if we would shred, are there any chemicals inside which causes impurity then for the following processes, PFAS or something like that?
Of course, the tape itself is an impurity from that perspective, but it's exactly the same as any other tape that you are using today. So for the fact of adding the debonding trigger, again, it's an additional ingredient into the recipe, but it doesn't change the current solution that you have in all batteries.
Thank you. Julianne Adams, I'm the Secretary General of the European Battery Recycling Association. Very interesting presentation. But following on to that question, can you be really specific in your answer? There is or there is no PFAS?
No PFAS.
Okay, and it's a really contentious issue in Europe at the moment. So
yeah, definitely. This is, again, we committed to become pioneers in driving sustainability in our market. And we are PFAS free 100% for already more than 3 years. So no product from Tesa is using PFAS.
Excellent, thank you.
Well, no PFAS or no fluorocarbons?
No PFAS.
So you might have fluorocarbons in there.
I have to check.
Okay.
But no PFAS, for sure, no PFAS.
I don't know how many dozens of fluorocarbon chemicals that are not PFAS or PFAS specifically. All right. Let's thank our speaker again.
Thank you very much.
Up next, we have Jessie Xu from RoMotion, where she's a research analyst. Really working on sort of a global perspective. Her experience comes around looking at China, outside China, full global perspective around battery recycling, and looking at sort of a monthly recycling assessments. And today we're going to hear about a global perspective and some of the challenges associated with it.
Good morning, everyone. Thank you. Okay, it's like so everyone has been listened to many presentations in terms of different perspectives, like from technology and legislation. And today I'm going to share some of our research on like the market overview, and also looking at what the outlook to look at in 2025, which is like the market challenges and the regional disparities in development. First, please allow me to have a brief intro of our company, RoMotion. And RoMotion is a research house based in London, and our research covers 6 key areas in terms of energy transition, including EV batteries, motor systems, and recycling and ESS. And as some of you may know, that we recently acquired by Benchmark Mineral Intelligence, which also allows us, because with the 2 teams merged together, allows us to cover the whole supply chain from mine to grid. Next, I'd like to enter into my topic today. In talking about recycling, first let's take a look at the feedstock scrap growth. So by the end of 2024, from our research, the global black mass available reached over 490,000 tons. 24% annual growth compared with 2023. And this percentage is lower than we expected in the early of the year, mainly due to the weak market demand. And when you look at the regional split, America reached 33% compared with 2023, while Europe's 29%, and China is a little bit lower, 22%. But what is noticeable that China still dominate the contribution to the global feedstock growth. As you can see in the pie chart in the right-hand side. So by the end of 2024, China still account for 65% of the global market share. While even look at the long term, by 2040, we expect that this regional scenario will maintain similar, while the percentage might change a bit due to like different markets growth, such as Europe, North America, that we expect to grow to 21% and 22% respectively. Looking at the feedstock source, currently we can see that the primary scrap source varies by regions. In China, dominated by production scrap, but we also started to see end-of-life EVs, the volume started to growing, mainly due to those old version of EVs coming off the road. And outside China, like North America, Europe, or Asia Pacific, we still can see that end-of-life portable electronics accounts for the second largest of the market share of the feedstock. And when you look at the long term, we expect that end-of-life EV scrappage rate inflection point will reach in post-2030, when the significant volume of end-of-life EVs coming off the road. But also, it varies by regions. Some regions might be a little bit quicker, and some regions might be a little bit slower. It mainly due to this balance between like the production scrap and the end-of-life EV volumes. Next, let's take a look at the pretreatment capacity development. At a global wise, By the end of last year, it reached 2.8 million tons at a global wise, and it's dominated by China again. But if you look at the annual growth, it's 26%, which is like almost half of the annual growth compared with 2023. And it's mainly due to like the project delays and suspensions. If you look at by regional share, well, China is 22% year-on-year growth, and US is 29%. But if you look at Europe, actually, it received a significant growth last year with 89% year-on-year growth, mainly because of several commercialized pretreatment plants entering into operation, such as AE Elemental in Poland and SKTS in Rotterdam. And when you look at 2025, we expect that the capacity growth will continue, but as the market challenges still existing, like potential project delays may moderate the pace. And then when you look at the balance between the feedstock and supply, we can see currently overcapacity existing across all regions, mainly China, but still in Europe, North America, or even Asia Pacific, we see overcapacity in terms of pretreatment development is already existing. And let's zoom in a little bit in the Europe specifically. So in terms of the capacity expansion, it reached 230,000 tons by the end of 2024, led by Poland, Germany, and Hungary. These three countries accounted for over 60% of the European regional market share. And then look at 2025, we expect that the capacity will grow to over 400,000 tons. And Hungary and Germany and Poland are expected to maintain like the leading contribution of the regional market share, and followed by UK, as we can see some plants are expected to enter operation. But however, you look at the refining capacity is a bit different. So currently, as many speakers already mentioned yesterday, so the refining capacity still remains insufficient at the moment, as you can see the chart on the right-hand side. And mainly due to project suspension, is Northvolt in Sweden, BASF just canceled the plant in Spain, and Umicore postponed their plans until post-2032. And in this case, we can see for overcapacity of pretreatment, it will indicate the more serious competition over securing the feedstock. But at the same time, refining capacity remains opportunities if like recyclers can overcome the challenges across legislation, capital raising, and then the technology development. So following the capacity development, I would like to share some recent updates in terms of the legislation and how it will shape the global black mass flow. So the map shows the current black mass geographical flow that we can see due to the undercapacity of refining in the West. We can see black mass are being shipped from the West, Europe, and America to Asia, mainly ending up in South Korea and China due to the overcapacity has been built up there. And as we know that in October last year, Europe released a draft of the European waste category and introducing like the classification of waste bacteria and slags intermediates that after the thermal or mechanical treatment. And black mass is likely to be considered as hazardous waste once the draft approved. But still, we see that the impacts on the black mass shipping will remain limited, at least in the short term, as currently, I just mentioned undercapacity here. And also, the EU shipment regulation at the moment still allows black mass or hazardous waste to be shipped to OECD countries, such as South Korea and Japan. In this case, it is still possible this black mass will be transferred from these countries and then end up in other non-OECD countries. And also, from the industry feedback based on the jobs, more definition on black mass or like the components breakdown need to be further classified. At the same time, we can see China is easing its import ban to allow more black mass to be shipped into the domestic market for further refining. At the end of last year, so the first black mass national standard was released in China. Compared with the draft, we can see it adjusts some requirements. For example, it classified black mass into two categories. One is based on the chemistry of the batteries, and the second is based on the source of the black mass. For example, the chemistry is based on whether it's MCM or it's LFP. And in terms of source, it's based on whether it's from production scrap or it's from end of life. And different requirements set on the elements, components, mass fractions, or like the impurities, it varies based on different categories. And we can see that it will allow more black mass, even lower quality of the black mass, to be shipped back into China for further refining. And it aims to help solve, ease the overcapacity issue in the country. So in this case, we can see, at least in the short term, the global black mass shift geographic road, it won't be changed that much based on the current situation. And last but not least, like yesterday we talked about the LFP recycling, and today I'd like to zoom a little bit more. So looking at the left-hand side, it shows the black mass, LFP black mass available in the market at the moment, and what is expected to grow by 2030. And then as we can see now, in terms of volume of the black mass, expected to grow to over 800,000 tons, although it will still be dominated by China with 70% expected. But we expect that other regions, for example, Europe, we expect that it will grow to around 25% in terms of the regional feedstock market share. And from the feedstock available, when you look at the recycling capacity development, outside China, we start to see more recyclers, like they're paying more attention and then start to develop FP recycling, and they're aiming more on the commercial side. For example, in the US, we see lithium industry just get the funding from the DOE to build a LFP recycling plant in the US. And in Europe, as Ortelium, actually, they just announced the commencement of the LFP recycling in UK, I think it's last month. And in Asia, outside China, mainly led by South Korean and Indian. So for example, the Indian Recycle Low Home, they claim that they already built up a commercial size LFP recycling plant, which is, I think, is around 10,000 tons per year. And also we can see other players such as GLC Recycle is a Southeast Asia player. So they also entering the LFP recycling field. But still, outside China, notable growth will not expected in the coming year, as it will take time, especially if you develop from lab scale to pilot scale, or like from pilot scale to commercial size scale. It will take longer time and it will be more complicated. Yeah, that's my sharing today. I think still have some time, so welcome for questions.
Thank you. Yes, we have plenty of time for questions. Got one right here.
Good morning. Thank you for your very nice presentation. One quick question on LFP recycling technology.
Yeah.
Which one is dominant in China? Is it hydro?
So thank you for the question. Still, as we can see, still hydro is the dominant technology in China. We see like a handful of recyclers, they are doing direct recycling, but frankly speaking, it's not really successful based on what we know at the moment. So still hydro is dominating the market at the moment.
And a reminder, please introduce yourself and your company.
Thank you. Viral Shah from Platts. I had a question about the trade flow of black mass going into China, because as we understand legally, it's not allowed. Maybe a cathode powder or something sort of more refined is allowed. So just wanted to get your understanding of how much actual black mass you're seeing going to China, because from our side, when prices were really high for lithium, we did see a lot of stuff going in and taken in by traders, but now lithium prices are quite low, hearing less of it. So just wanted to hear your thoughts on that. Thanks.
Thank you. I cannot give you a really specific number in terms of volume, but we did see that the number of the black mass was increasing last year, mainly due to like the overcapacity and, as you said, that the depressing commodity price. And for Chinese recycler, because they already built up this commercialized scale, so it's easier for them to like just recycle it. And then because if you consider the cost, it's still relatively lower in China. And as a recycler, they need to keep the plant operation. So they need to buy this black mass to keep operating. Yeah, so hope that answers your question.
I want to be here.
Hi, I'm Sandro from Deloitte. May I ask if you have an idea how high the percentage of the global mass market is that is being lost in total on a global scale to, I don't know, regions where there's no recycling methodologies in place, low regulations like we learned yesterday?
Well, I'd say that like still I cannot give a really specific number, but as you can see currently NMC, because of the value of the metals, I don't think it's like most of them still are being shipped to and recycled. But for LCO, because of like the impurities of the feedstock and then the lower value, and also for Chinese players, we heard that because of the cobalt price in the domestic market is much lower. So when they are searching for black mass, like they are like prefer to MNC instead of LCO. So probably in terms of portable, like LCO, for example, they may lose more, I think.
Hi, I'm Hugo from DHL. You showed that map with the black mass going from North America and Europe to Asia. And I'm curious about how you see the regulation maybe changing the next years and becoming stricter to keep that black mass within North America or within Europe to be refined here and not in Asia. Do you think that's a real possibility? Is it happening soon, or it's just not happening anytime soon?
Well, in North America, we still haven't seen much updates from the legislation side, which means that it allows this black mass to be shipped to overseas. And then in the coming year, we don't expect that will be much more changes. While in Europe, we can see because of the new waste list coming out. But the real issue here is the insufficient refining capacity. And then for recyclers, when they produce a black mass, they need to sell it as a product to make profit. And in this case, and also with this like OECD countries still be allowed to be imported. So we also think that the impacts are likely to be limited, at least in the short term.
Hi, thanks for the presentation. So also depends on the regulation, also on the price. So lithium price forecast, nickel price forecast, cobalt price forecast, that forecast will define if it is profitable or not. So you cannot only control by regulation. So do you think that it will be economical for the price of operations for Europe and USA? The black mass, if it is profitable or not, is the main question. I think the second is the regulation. Because if you put regulation on a non-profitable thing, so you cannot control it. So it also happens in China sometimes for the thing. So what do you think about the price of lithium, nickel, cobalt, and black mass profitability in US prices and Euro prices for the coming 5 years or 10 years?
I think for black mass, when you talk about price, it's linked really tightly compared with the commodity price. So if you look at the lithium, the cobalt, and nickel, while in the long term, excuse me, and at least in the short term, we expect that for 2025 until probably 2027, that the price of commodity probably maintain like similar or like a smaller growth. But I don't think that we can see like it will bump up again as like the high price in 2022. And then if like from the legislation side, the business model, I think it varies by regions. And also when you talk about profit of like the black mass refining, or like, it really based on the elements inside, the metals inside. Well, if like, for example, the black mass is produced from production scrap, which is more purer, and which means that this black mass is more valuable. And if it's from end of life or it's from portable, then if you consider aside just the commodity price is lower. So this also will depends on the black mass components, and also because the average cycle of the technology varies, with the higher recovery rates or like with lower costs in terms of the whole process, it also will have impact on this profitability model, I think.
Just a comment. In fact, maybe it will develop a question also, because here what I noticed, I think we have to emphasize one thing. According to the map, world map you showed us, in automotive industry, one of the big pressure that we have is related to the carbon emissions, not only on the exhaust pipe of the car, but also all manufacturing process and also including recycling process. So we are obliged to avoid intercontinental transports in the future, in the very near future. Today, the discussions of the Automotive Manufacturers Association with the European Commission is related on this, how we will avoid the carbon emission taxes and how we will avoid the penalties that we will pay, we are obliged to pay today. So what is your prediction related or forecast to say related to the excess Chinese capacity to move towards the markets that propose the feedstock? Because it's sure that some of the OECD countries can receive this excess recycling capacities if it moves. Yesterday, it has been requested, in fact, some proposals. We consider, I don't know, countries around the USA or countries around the European Union, like Turkey, like Mexico, that can accept such kind of investment.
Thank you. Yeah, definitely. Because we can see, because black mass is not considered as just like a normal waste or like a normal product anymore, because it's really structured because it has critical materials there. And definitely, like look at America, look at Europe, everyone try to keep it within the market. And definitely looking forward will be with everything like from every single perspective, like legislation, technology, or like this capacity growth. We expect that it will be recycling. Generally, it will be more like a localized market. Thank you.
Right, we have time for maybe one more question. Again, please state your name and the company.
Hello, my name is Maurice van Giezen. I'm director of Cleantron, the battery market leader in the Benelux. When I look at the end of life waste compared to the production waste, I see that the end of life waste is, let's say, less attractive because of lower impurities. The production waste is more valuable. The end of line waste is also more expensive to collect, particularly defect batteries. To transport them is very expensive. When I look at this, is there maybe a chance that there will be two tracks in the business? One is for production waste and one is for end of line waste?
You mean that from our the chart, or just because probably, as you can see here, right here you can see, because we separate
whether
it's from production scrap and end of life EV, ESS. These are all the sources that will be summarized under end of lives. If like,
Yeah,
that answer.
but because of the economic model, end of life scrap is more expensive
Yeah.
to start with, and it has a lower value in the second place. Is there not a tendency in the market that the recyclers will only focus on production waste?
I think because first it's about like the feedstock available at the moment. Still, most of them are like, as you can see, the chart here is like dominated by production scrap. And when we talk about the market, because of the higher value of the feedstock, still, generally speaking, recyclers prefer production scrap at the moment. And also it's easier for them to recycle, honestly. And for end of life, we expect that it will be more, and then, but it will be like post 2030. And at that time, also for recyclers, definitely they want this feedstock because the overcapacity is there. They need this feedstock to keep their plants operating. And it won't be like there's one market that just focus on one type of feedstock. It will be various. It's just based on, for example, the production scrap is like from these like gigafactories. So where the gigafactories concentrated, then maybe more feedstock available there in the market. And for the local recyclers, it's easier for them to get access to this feedstock.
Okay, thank you.
All right, let's thank our speaker again.
Thank you.
Next, we have Jared Zhu. He's a senior consulting project manager at Shanghai Metals Market. We spent the past 5 years focused on strategic consulting, market intelligence, and working with some Fortune 500 companies, mainly focused around the global sustainable energies market. So please come to the stage. And today we're going to hear about more like a global vision. How can we entail a global battery recycling market?
Okay. Hello, everyone. This is Jared from Shanghai Metals Market. We are a price reporter, but also a information provider based in Shanghai, China. And today I'm going to show you a critical look at the global recycling market, especially since we are based in China. And I want to combine some lessons or some experience we have learned from Chinese market and to see how it could be learned from the China market development. So the whole story looks like this, and we are very clear and settled that the future lithium battery recycling market will grow to a relatively high speed, and there are definitely the needs to recycling it. While we still see that different regional markets differs a lot if you compare with China, European and US markets, and their profitability model, their capabilities, their technology could be different. So based on this scenario, based on the development of Chinese market, what can be learned is the second part. Last but not least is our SMM brief introduction and what we can do and what we can offer. So firstly, about the introduction and the general overview of the global recycling market. To look at the global recycling market size. So to introduce the market size, I want to briefly introduce our methodology. So generally, it will be divided. If you look at different chemistry, it includes the ternary, LFP, LCO, LMO, and others. And if you look at from the different type, it generally includes the end of life, the production waste, and last but not least, also stock waste. The stock waste is something people tend to neglect. While we do see that, especially in China, due to the overcapacity, that after battery has been produced, they are stored in the warehouse. And sometimes they cannot sell because of the overcapacity. And after some years, it's aged or it's not any qualified anymore. So it also brings the needs for the recycling. Either it's like repurposing or be recycled. So we include the stock waste into our calculation as well. So, so this is our dimensions when we calculate the global lithium battery recycling market size. So how the market looks like. So few takeaways here. So firstly, we can see that if we divide it by the end of life production and stock, you can see clearly that the end of life will be the driven power for the future growth of the total lithium recycling market from like 25% around to nearly 62% in 2030 to become a major share when we are talking about the global lithium battery recycling market size. And from the right chart, you can also see that the CAGR ratio in the following years of the end-of-life battery actually can reach nearly 50% of CAGR ratio if we compare with the production waste. So to conclude that we do see a future rapid growth of the lithium battery recycling market needs and requirements. While we do see the difference between the different regional market. So this chart is to compare that China market versus European market from the capacity, from the battery value chain maturity, pricing mechanism and technology and their profit model. So we are all very clear regarding the capacity part. So I would just let it go. And I want to emphasize that firstly, it's about the battery value chain maturity. It's about the idea of building the closed loop. As many of the speakers has told yesterday that due to the slowdown of the EVs, and we also from the downstream, from the PCAM, CAM sector, we don't see many capacity ramp up and resulting in a slowing down of the demand for the materials, and that includes the recycled material. So I think this is just a very vivid evidence that's showing that actually comparing with Europe, China's business model is actually build a very close loop. And we have giant like CATL, they have a subsidiary like Brump and Brump Recycling. So by this, they can build the whole value chain. Like CATL will provide the production waste of battery cell to a subsidiary called Brump, and Brump can shredding it, smelting it, make it into PCAM and CAM, and back to CATL value chain. So just one single company can do the closed loop. So that's a huge difference here. And also, if we are talking about the pricing mechanism, take the black mass example, China is different compared with Europe. One is China price the lithium when we do the pricing mechanism. While as far as I know, the for Europeans, lithium is not included when do the pricing. Second is about the benchmark price point. So nowadays, people in China use SMM, cobalt sulfate, nickel sulfate, lithium carbonate price, this kind of sulfate or salty price as its benchmark. But in China, we do use the metal price like refined nickel, refined cobalt in roughly before 2022. While we have been switched to use the SM sulfate price because people find that if you are priced when you buy, and also based on the very fact that in China market, people has to buy the feedstock from the recycling player perspective. So when the recyclers, they buy the feedstock that they price as the metal price, but when we sell, it's priced as a sulfur price. So naturally that will be the arbitrage. So people in China nowadays switch to the sulfur price, while still Europeans are based on the metal price. And also you can see the difference from the technology competence and also about the profit model. Like in China, people buy the battery scrap and processing it and sell, while in the European, we take more as a service, which means in some cases, OEM has to pay for the recyclers in order to get it recycled. So the business model is huge different. Like Europeans can making money by having no feedstock cost, but Chinese as a very competitive market, it has to be very competitive and to lower the cost of the feedstock, of the processing fee in order to competitive enough. So the processing or the technology is quite important in the Chinese market. While we see the difference between China and Europe, and even though within the EU, the difference a lot. So here is from the dimensions of the feasibilities of different countries from the policy subsidy approval time to see the feasibility of doing lithium battery recycling in the Europe. While we also assess from the attractiveness, from the EV volume, EV potential, electricity price to see how the potential of the lithium battery recycling. So let's take some examples. For example, from policy, East Europe, like the Hungary, they tend to have very few restricted rules, but countries like Germany has very clear requirements and procedures if you want to do the recycling business in Germany. And also subsidy, Hungary is more flexible. As long as the investment reach certain value, you can get subsidies. While for countries like Italy, it requires a lot, like the investment entity, regional restrictions, and the amount, this kind of restrictions. And also approval time, like Germany's approval time is relatively much longer if you compare with Hungary. So many Chinese companies, they come to Europe and they learn this kind of lessons a lot. And also if we assess from the attractiveness, it differs a lot as well. Like we have seen like countries like France or like Germany currently have a well-based EV volume now, so it has much attractive for the recycling. While we do see like countries like Hungary, because of many South Koreans, many Chinese to invest, and also many OEMs, EVs to invest, so it has huge potential for the EVs in the future. Last but not least, also the electricity price also differs a lot across the European continent. So since we know that it differs a lot, while I want to recall or to pull it back a little bit to see, to summarize what's happening in China and what can be learned combining different market dynamics because it's so different. So to answer these questions, actually, I'm from the profitability model. So it's a little bit complex math, but I can walk you through this. So it's basically how people price the battery scrap. So, and we set the common ground as the cost of the lithium carbonate cost. So they have two equations. So the whole idea is like to set this as the core, and we have equation 1 and equation 2, and to break down, and we want to see what is the key factors that will influence the profitability. So either we could have the cost by the price multiply the gross profit margin, or either we could have the cost by simply combining the raw material cost and processing cost. And for the raw material cost, we can further break down by the unit consumption to multiply the unit value within the battery scrap. And for the unit consumption, it can be further divided by like the lithium content. Take lithium, this metal as an example, take the lithium content in the carbonate to divide it by the content as the scrap, which is the previous feedstock, and to consider recovery ratio. So we could get the unit consumption. For the unit value, we could calculate it by the benchmark price to multiply the content and to multiply the coefficient or the payable ratio. So we get the value of lithium in the per ton of battery scrap. So we multiply the value and multiply the unit consumption, we get the raw material. So we put the equation left and the right, the equation 1 and equation 2 accordingly. So after doing some math, we can have this kind of conclusion. So this is from the perspective of to look at from the payable ratio, because at the end of the day, the battery scrap price is based on the benchmark to multiply the payable ratio. So let's start from the payable ratio. So if we look at that, we can see some key factors will, at the end of the day, influence the profitability or the key to success for the recyclers. First, we see the recovery rate and also processing cost. In this kind of factors in the formula is very important. So it's give us a takeaway that to improve the product recovery ratio and to optimize the technology efficiency is quite important. Second, we see the price. The price when you buy, for example, lithium carbonate, and the price when you sell the battery scrap, the lithium carbonate price. So it's very important to track the market dynamics because the benchmark salty price could be very fluctuated. Last but not least is the gross margin you expected to earn. And that is much related to the sourcing channel, like whether you have bonded with OEMs or battery companies, so you can secure your sourcing channel and therefore to lower the procured feedstock cost in China, and therefore you can expect a higher profit margin. So that's the whole idea, because in China, when recyclers, they tend to buy the battery scrap, actually they are using this model to back calculate the payable. They're negotiating with the OEMs, with the battery companies. So when they are thinking about what kind of payable they want to negotiate, they have to consider their recovery ratio, their processing cost, the profit margin they would like to have in order to put into this formula and then to have a payable ratio. So to summarize, to look at from the perspective of the recyclers, so to ensure the technology competitiveness, to ensure the close tracking of the market price, and to ensure the sourcing channel, these are the three key factors that will very largely influence the profitability. But we do see different factors. We cannot just put Chinese waste in here, right? So we have to consider different factors. Very firstly is about the trade policy, as mentioned by many speakers. So we do see many changes of different of the trade flow of black mass. And we see from North America to Southeast Asia, from Europe to Southeast Asia. And there are rumors like China will eastern the import policy of the black mass to treat it more as a resource instead of a hazardous waste. So, and also Europeans are talking about either exporting allowed or not. So this kind of dynamics will certainly influence how many scrap is actually available in different markets. So this is what we should keep a close eye at. And second is we should also look at different countries' business model. As I have mentioned, China is building a closed loop. And while for other regions, it is lacking some steps. While it is important to have enough or to try to build a closed loop, as mentioned, if there is no cathode or PCAM producing capacity, there is no driven power to have some local produce like smelting or upstream. So it's very linked. And also due to the very idea of closed loop itself, it is very much preferred to have some local supply chain. While in the Europe, we still see a relatively lacking in commercialization of hydrometallurgy, especially here. And also, when we consider the different market dynamics or the recycling, we should also to look at the premium of the recycled product. This is something actually SMM is doing. We are going to publish the price points of the recycled nickel, recycled cobalt, and a recycled lithium carbonate, which we supposed to have a premium if you compare with mining sector produced product. So this is lessons we learned from the aluminum industry. So we, as a SMM, we also publish some non-ferrous metals price. So for the aluminum, it's very energy consuming. So here is just a simple demo to show that low carbon aluminum actually enjoys nowadays a premium if you compare with originally from a mining sector aluminum. So we do that based on this kind of carbon emission cost model to see how much premium it will have. So at the end of the day, it's the how much carbon it is lowered when you compare with some virgin produced product. So that is ideal that we kind of, when we're talking about the recycling sector, we should to include that into our thinking. So to summarize my presentation above, we clearly see a clear trend of the future growth of the lithium battery recycling and much driven by the end of life battery, but we do see a regional difference. between China and Europe, and even within the Europe, the market dynamics is quite different. While we do want to help you guys to bring the China market insights and to see the lessons we have learned in China, and to summarize the key factors to success in China regarding the recycling business is about technology, about the sourcing channel, and about the market sensitivity of the market price. While we do have to combine with the different market dynamics, including the trade policy, including the premium itself of recycled product, etc. So last but not least, please allow me to introduce my company a little bit. So our company is called Shanghai Metals Market. We were established back to 1999, so we have roughly 25 years of history. And you can tell from the name, we are headquarters in Shanghai, and we are very focused on the metals, non-metals market. And about the whole battery value chain, we have covered from the upstream raw material to the battery and to the battery recycling. And this is our offices. We do have European office based in London. And yes, like I've mentioned, currently in the China market, the value chain is kind of like for the recycling sectors to calculate the recycling price with SM40 price. And this is what we offer. We offer industry data, regular research, events and marketing. We do organize events by ourselves. The unique thing is to bring the Chinese people here to the European. So in this year, we'll be in Barcelona. Last but not least is where I come from the consulting sectors to provide some customized service or intelligence and to combine with the best China market insights. And this is some demo slides. So I guess everybody will get the PowerPoint. So I will just scroll it a little bit. This is just some showing of our previous projects demo slides. So for your reference, you please feel free to reach out if you have any interest in this. Thank you a lot.
Thank you, Jared. Do we have any questions? Going over there. Remember, please state your name and your company.
Thank you. Julianne Adams, the Secretary General of the European Battery Recycling Association. I just want to make it really clear, because you said that you were thinking that Europe are thinking about changing the rules for black mass to make it a product. As far as I'm aware, that is categorically not the case. So I was in a meeting between the European Commission and the Chinese government discussing all the various regulations and the changes in the list of wastes. And the European Commission were 100% adamant that black mass is not a product because it needs further refining. So it's not the end of waste. So the way things stand at the moment, so it took, what, 5 or 6 years to get the last changes, if not longer. So, you know, you're not going to get any immediate change now. So thank you.
I don't have a question, I just have a comment. Chairman of the EBRA, in your presentation, there is no possibility or no opportunities to have hydrometallurgy in Europe. We already have a plant in Finland operating and producing a lot of material with hydrometallurgical processes. So you have to add a little bit to your presentation.
Yeah, it's just a comparison between like European and China. I know some of the plants has already entered the commercialization, but comparatively, it's relatively like at initial stage. But I think it's well goes. Yeah.
G'day, Sean Jones from Altilium. Thank you for your presentation. I thought it was really, really good and really insightful. One thing you were saying around how you could capture the profitability in terms of recycling is that you are very focused on your purchase price of lithium carbonate and what you're actually selling it for. Do you see a deep hedging market for that type of product, so people effectively lock in their profit margin between what they're buying the black mass for and what they're locking in on the other side from the OEM?
Yes, actually the pricing of it is becoming more and more diverse, because in China we have Guangzhou Exchange, which is about the future price. So people tend to include not just the market spot price, but also the future price to do the kind of to securing. So people are talking about to use it like the market future price as well. Talking, yeah.
Hi, thanks for a nice presentation. I want to ask the overcapacity China and overcapacity affects the price of global price for the processing and other things. How long will it continue the overcapacity of China's just doing lots of factories that reduce the price of processing for the global market? So it also affects the profits with the other regions. So it will continue like for 10 years or 5 years. This is my first question. Second question is the price difference between the London market and the SMA market of the metals. Will it continue like that, or it's, for example, sulfate market? For example, China, if you buy a black mass, you pay before the money and then you process and sell it. So it's some time that you process and sell it. So how the business model works, like because you buy in some time and you process this in some time, and then you sell always the price on the day of the SMA. So how it works, because if it fluctuates, so how it just insured? So something like.
Yeah, regarding the latest question, how do they ensure the fluctuations when they buy and sell? And usually, when the recyclers, they will talk with their like smelting companies, because when they purchase them, they will already talk with some of the potential buyers to ensure that they can, by accounting their processing costs and the profit margin, they can still make profit. But currently, or in many cases, people lose money through this process due to the very fact that in the past 2 years, the lithium has been generally downward. So that's very tricky thing. While this is one option, another option is that people simply talking about making processing fee margin. So if the scrap owners, they don't charge the raw material fee to you, and you just responsible for extract the metal from it. So I just give you the processing fee. So it's simple. It's not influenced by the fluctuation of the metal price. Yes. And about the overcapacity, yes, currently the China's lithium battery, especially shredding or the smelting capacity utilization ratio is like 50%, just half of the utilization. And that is due to the very fact that China is not has compulsory regulations to say whether you can or not do the recycling business. So there are so many supply, especially in this sector. So still it's a gray area, but government are making more strict and more clear rules to state who can enter this and who cannot. So in the past, I would say 5 to 10 years, that will be the merger and acquisition of this market. This will be very brutal, actually.
Thanks. All right, thank you, Jared. Up next, we have Viral Shah. He is the managing editor for the low carbon and base metals EMEA at the S&P Global Commodity Insights. Viral has quite a experience and an interest in really recycled everything, right? Ferrous, non-ferrous, anything valuable. He's interested in it. Today, he's going to be talking about really the value chain of black mass and how can we really get those insights. So.
Hi, everyone. Thanks, Cameron. So yeah, I'm going to talk through the black mass and recycled lithium markets. But let's go through. So yeah, we've got a pretty packed agenda. So first I'll go through the underlying battery metals markets that are used to price the various components in the black mass. Then I'll go through some of our black mass price assessments and also our recently launched recycled lithium prices as well. And then some forward-looking stuff, but I know we have covered a lot of that in terms of forecasting. So just as a quick introduction, if you're not familiar with Platts, we're part of S&P Global Commodity Insights, one of 5 divisions of S&P Global, from ratings to Dow Jones indices. And our aim is to provide essential intelligence to clients across all the commodity and financial markets. And Platts is the leading provider of independent information and benchmark pricing for the world's commodity and energy markets. We have more than 100 years of history and 15,000 customers in 190 countries. So we, always aim to bring transparency to these markets. And of course, a lot of our price assessments that we publish are used by global futures exchanges to settle contracts. And here's just a quick summary of some of our assessments I can skip through. And then in terms of our assessments on the battery metals side, we have a full suite of daily frequency assessments for battery materials, from lithium and cobalt and black mass that we're going to discuss today, to nickel, manganese, graphite, and this is all done by our global team. And yeah, let's kick off with some of the wider context. So, of course, China was the largest driver of global plug-in electric vehicle sales in 2024. The total sales surpassed 16.5 million units, and China accounted for about 86% of this. Of course, in Europe, it's still pretty weak, especially in Germany, one of the biggest European markets, after some of the subsidies were removed in the end of 2023. So we saw a 4% decline. But one thing that's going to be very interesting is, of course, we've had the elections in Germany this week, and what the new government and coalition is going to decide in terms of supporting the automotive sector is going to be really important in terms of understanding how much EV sales will be determined by this. Interestingly, with China, some of the market sources that we talk to are suggesting that, there could be sort of a softer than expected increase in 2025 in EV sales, just because there's already quite a high base and there is still underlying weak consumer confidence. But generally, the expectation is there's going to be strong sales. And interestingly, one thing that we're seeing in EV sales generally is that the metals consumption intensity is actually declining. And there's been sort of a growing preference for plug-in electric vehicles, which obviously have smaller batteries than the pure battery electric vehicles. And this is something we've seen in 2024, where the plug-in electric vehicles sales globally accounted for about 37%, up from about 32% in 2023. So that's a trend that, we're expecting to continue. And of course, in the context of recycling, this is going to be very important in terms of future supply. And we also, of course, as has been discussed yesterday, talk about the second life use as well. And here's just a quick map of some of the infographics we've recently published, mapping out key battery recycling players. These are regularly updated. And so, you can take a look at these on our website. And just to get started in terms of the key battery raw materials markets, if we start with the benchmark Chinese market, these are some of our daily assessments. And you can see that it's generally a picture of oversupply and depressed pricing. So prices for lithium carbonate reached a 4-year low at the end of 2024. There was a slight recovery, and prices are pretty stable in 2025 so far, and quite range bound, but of course remain depressed from the huge drop that we've seen from a few years ago. Market participants that we're talking to are still suggesting that the restocking activity for the battery metal salts is kind of only happening on a need-only basis. Currently, I think for carbonate, we're assessing around 75,000 yuan per metric ton. For hydroxide, it's about 69,000. And this sort of difference has been evident in the market since 2023, when LFP showed that it was the clear preference in the Chinese market. And so carbonate, which is more used in LFP, is trading at a premium. One thing that's interesting to note is, with the lithium prices, CATL is expected to restart mining activities at its lepidolite mine in Jiangxi province. That was stopped in September last year because the cost of production was higher than the actual market price. But it seems like they are coming back into the market, and so that will bring more supply. So the expectation is that there isn't really going to be much of a price increase or any support or recovery in 2025. For nickel and cobalt, again, similarly, prices are pretty weak and at historically low levels due to the oversupply pressures. That's something that we expect to continue, and especially for China, where NMC is getting sort of a smaller market share. And just to touch on cobalt as well, this is our European cobalt metal assessment. You can see that prices have weakened quite a bit from around $40 per pound a couple of years ago. We're now at less than a quarter of that, and this is mainly due to huge oversupply. And driving that has been a lot of new Chinese metal producers. The margins to produce cobalt metal are slightly better than producing cobalt sulfate. So you've had a lot of players shifting their production. And because of that, we've had a lot of more Chinese metal brands coming into the market. And that's sort of really created a disparity in prices between material coming from, say, China, Russia, Cuba, compared to some of the sort of Western producers who have higher production costs. And this has caused a huge divergence in the market. And because of this, in September last year, we decided to split our cobalt metal assessment into Rotterdam into three different markets. So we've got mixed use A, which is reflecting China, Chinese, Russian, and Cuban. Mixed use B, which is reflecting kind of the other Western players. And then we've got alloy use as well, which is still quite high. And so you can see we're at multi-year lows, and this is expected to continue. Obviously, there's been huge production of cobalt hydroxide, which is a feedstock for metal from the DRC in 2024. But you've probably seen the news that there's a 4-month export ban from the DRC. The impact is expected to be more on hydroxide. We have seen some offers increase for hydroxide, but effectively, because copper prices are quite high, that production is still expected to continue. So if they're just going to stockpile the cobalt hydroxide and not export it, I think the market is expecting that maybe the impact is going to be, if there is any increase, might be short-lived. And now just quickly looking at our black mass assessments. So we launched in 2023 a global suite of black mass assessments. You can see for XWorks Europe and for DDP China, the main difference here is, as I think Jared mentioned, is that in China, the payables basis is done off the metal salts, and in Europe, it's done off the actual metal, so LME nickel, and then cobalt metal as well. Our specs are slightly tighter for China, especially on the impurity specs. So copper, aluminium, and iron is at 3% combined, whereas it's about 5% combined for Europe. And then similarly, we have US as well assessments and quite similar specs there. And these are all published daily. And we essentially assess the payables, talking to market sources, and then we imply a calculated price in dollars per metric ton. And happy to go into more details into that if you'd like as well. But yeah, starting with the European market, you can kind of see that the payables in the yellow line, in the gray line, have been increasing in 2024. And this is largely just because of the underlying weakness in the LME nickel and then the cobalt metal markets. So for recyclers to remain viable or profitable, they need to increase the payables. And so currently our assessment is around 70%. This is, pretty steadily gone up over the last sort of second half of 2024 and into 2025. And this is something it's going to be quite interesting. We do, as I mentioned in the previous slide, we do assess a lithium payable, but that's been at zero the whole time. I think as many of you are aware, if anyone is extracting lithium, they are adding it onto the nickel and cobalt payables in Europe. And right now with the low salts prices, not many people are extracting lithium, although we do have some people at this conference who are focusing on that in Europe. So that's something to note. And then the yellow line is our calculated inferred price from the payables. I can go into the formula offline.
but the big drop is just because we widened our specifications to lower the minimums, because there is a huge amount of variation in the quality of black mass, as you're all aware. And so that since then, that line has been pretty range bound around the $2,000 mark, occasionally dropping lower. And then, yeah, looking quickly at the US market, there's kind of two main trends there. There's just a lot of tightness in terms of the low impurity, high nickel content black mass. So that material is in demand, but not really around. And then the other thing there is the export demand as well. Similar to Europe, it's really an export trend. It doesn't seem like the domestic market is that strong. There's not many players domestically in the US buying. So a lot of that material is going to South Korea. So that's something also typical. The lithium payables, briefly, there was a period in 2024 where we saw 5 to 10% payables, but that's come down to zero as well amid the low market price for lithium carbonate. And then here you can see our implied calculated prices for Chinese NMC black mass versus Europe and the US. And this is quite interesting. You can see obviously the price gap between China and Europe and the US. Of course, the higher capacity means, and also the restrictions on imports means that the payables are higher in China. The interesting thing, I think, as many of my fellow speakers have spoken about, is that there are some expectations that specific qualities of black mass imports could be possible from July, but it's unclear in terms of how tight these specs are going to be, because across all markets, China has been quite strict in recent years to import waste. So even if the standards are quite strict in terms of what is going to be allowed to be imported, that I think might also be limited in terms of the quality that can go there. So that would be very interesting to see how that proceeds. And yeah, just to quickly touch on our recycled lithium carbonate assessments. Interestingly, I know, in other markets, I think Jared spoke about aluminium, where we're also assessing sort of a low carbon premium for recycled lithium. Actually, the market is trading at a discount to prime origin material. So for domestic China, the spread is quite tight. I think currently we're assessing a discount of about 800 yuan per metric ton. In the seaborne market, so into Korea and Japan, it's about $900 to $1,000. So it's a bit wider. Of course, because of the high capacity and desire for feedstock, the spread is tighter in domestic China, and it's wider in North Asia, just because the market is a bit weak. There's oversupply. People are preferring primary material. Recycled material needs quite strict qualification, might need some upgrading, even if it's considered battery grade in some respect. There's obviously an impurity profile that is different, and every sort of cathode producer requires very specific qualities. So there is sort of a wider discount there. But in the future, of course, we're expecting, the technology to improve, the quality to improve as the supply of, black mass, end-of-life batteries increases. There's probably some room for improvement there. And then obviously with the lower carbon footprint, because obviously there's not going to be any mining involved, there is some expectation there could be like a green premium. So we'll have to see how that develops. And yeah, just quickly to give you an idea of how we get our data. We talk to a wide breadth of people in the markets, and we are really keen on transparency. So every indication we get, of course, is anonymized, but we publish lines of information that we call herds that you can see like this to our subscribers, and they can see them throughout the day. And I think that's really important, because when you're using a price assessment as the basis of your physical contract, you want to understand what goes into that assessment. And so with Platts, you can see every single bit of data the source type, the volume, specification, dates, type of black mass, all of those details. And so we publish these live. So just wanted to share a bit on that, and happy to talk about it after as well. So what's next? I think everyone's basically shown a version of this chart in terms of the production scrap supply growth. So I think I can skip this one. Interestingly, this one is quite interesting. Our colleagues in our mobility division, which is a separate division, have recently done a study in terms of modeling end-of-life availability. And of course, you can see that the numbers are going up quite a bit. But what's especially interesting is the recycled origin material. So they're expecting, of course, China to lead in that sense. But there's going to be a difference between, how many total end-of-life batteries are going to be available, and of course, how many are expected to be recycled. So the chart on the right-hand side in gigawatt hours is showing how much will come from end-of-life vehicles, and in orange, you'll be able to see how much our colleagues from mobility are expecting that to be recycled. So overall, the recycled share of end-of-life batteries is expected to grow globally, I think, to 52% by 2036. And currently, I think for 2025, they're forecasting it's around 39%, if I'm not wrong. So that is something that is quite a big challenge, I think, for us. 52% for recycling is one thing. The remainder of that in 2036, I think, is reflected by second life as well, but also batteries going to landfill, because there's a lot of markets, I think, as we've discussed here, where there isn't any sort of plan for reuse for the aftermarket for recycling, and there's no sort of agreement on who will be dealing with that. So that's something that's really, really interesting. If you have any questions on the modeling for that, I'm happy to put you in touch with our colleagues, because I think it's a very interesting piece of work, and it would be, I think they'd be able to speak a bit better in terms of some of the modeling assumptions that they've made there. And then, finally, just in terms of their forecast, so my mobility colleagues, again, in terms of how recycled origin supply is expected to grow. So by 2032, our colleagues expect that for lithium supply, the market share for recycled, coming from recycled automotive batteries is going to be 17.6%. For nickel, it's going to be 19.3%. And for cobalt, it's going to be 21.7%. So they're expecting some growth there as well. And just to sort of finish up, of course, I've shared all the price assessments that we're publishing, but we also publish daily PDFs. We have a weekly battery metals report with all of the prices, news and coverage analysis that's available in English and Mandarin. And we're doing podcasts, videos, interviews, etc. as well. We also put out a free newsletter every week. So if you'd like to join that, just give me a shout and I can add you to that list. But thank you for your time. And if you have any questions, thank you.
Thank you, Laurel. Do we have any questions from the audience? No one?
Hello, Dorosian Horak from MakeAware. In the presentation of SMM, they mentioned that there will be a premium on the recycled materials, and you mentioned that the lithium recycled is being sold for $1,000 discount. Can you explain why?
So I think it's partially to do with qualification of the recycled origin material. So currently, I think there's a impurity profile, and for some players, for example, in Asia, they are able to get to battery grade, but cathode makers are very strict in terms of the quality of the lithium carbonate that they want. Same with the other battery grade metal salts. that takes, it takes time for them to sort of accept that material. And of course, this is quite new. This market is coming up, so the quality profile is slightly different. Even if the sort of lithium content might be what is expected, maybe the impurity profile is slightly different. So there's a discount there. And then, especially in Europe, I mean, we're not really seeing many players at any sort of commercial scale be able to produce battery grade lithium carbonate. I think we're seeing more industrial and technical grade. So there's obviously some sort of discount there. I mean, in the future, the expectation is there should be some sort of premium, but right now it's clear that they're paying less. Yeah.
We got one over here. Can you clarify that? So is the discount because the uncertainty of the material, or because they have to do their own validation and vetting and qualification of the material?
It's both. It's both. I think it is obviously a new market, and so obviously cathode makers have to be really sure about the quality and the spec. So yeah.
My ears pricked up when you said that CATL will be mining lepidolite. As I understand, that's quite a low yield and will release a lot of fluorine as well.
Very low yield. I think maybe some of our Chinese colleagues can speak a bit more to CATL's strategy, but it seems like they have that kind of upstream supply integration. The lepidolite was being mined at quite a lot at high rates over the last years, and we saw that was a part of the oversupply from the mining side that helped bring prices down. And I think the understanding is CATL want to ensure costs are controlled, and so if there's any kind of expectation that carbonate prices are going to go up, there's probably they want to keep a cap on that and keep their costs controlled. So it will be interesting how at what rate they will return and how much, but because as you said, the quality of lepidolite is quite low, huge tailings, and not great environmental footprint. So yeah, that would be interesting to see.
And Böhler Daimler Truck. So you showed some charts with the highs and lows of the markets and the different prices. Do you see some kind of hedging there, as we see it on the energy market, on stock market?
Yeah, I mean, it's really developing. I think, Jared mentioned the Guangzhou futures in China. We do have LME and CME, but it's the hedging market is still very in its infancy, I think, especially for lithium and cobalt. For nickel, obviously you have the LME, that's pretty established. But there is obviously a difference between the battery chemicals used for, with nickel, so nickel sulfate versus the actually class 1 LME. So there is a big difference there. I think, as we've seen in China, there was a disconnect, and a lot of people are now basing their prices off nickel sulfate rather than off nickel metal. For lithium, again, we're seeing more liquidity on the Guangzhou futures on the CME and LME. I think it's still quite slow. The market's immature. A lot of players aren't sort of joining up. The liquidity is quite low as well. So you kind of see in a lot of immature markets a contango in the futures structure, which assumes you can take advantage and sell forward. But I think there's a lot of room for growth there. So yeah, it's still quite early. Yeah.
Got time for one more question? All right. Well, if you have more questions, you can talk to the networking break. Thank you for all. That concludes this session. We now have a networking break, beverages and snacks over in the lounge. We will reconvene at 11:15.
Just a small reminder, since we're already getting closer to the second part of the second day, just a small reminder about the evaluation form, since it's very important for us. You can fill it out already on the spot while the presentations are still going, or you can fill out them in the end and then provide them to me, or you can even email them to me afterwards. How it's comfortable for you, just it's very important to hear your opinion. Thank you.
Okay, hopefully everybody's refreshed from that break. So we got 2 more talks in a panel before lunch. So up next we have Umut Batmaz, the 3-decade veteran in the automotive industry in general. So if you find time, you should come talk to this guy. You can't beat that just experience and knowledge. And it sounds like we're getting a pretty broad talk around everything automotive. Floor's yours. Top button does the laser. Use the slides forward. Both microphones work.
Thank you. Thank you very much. So we will a little bit talk about the automotive industry because we are talking about recycling, and some of the guys asked why we are here. Are we interested in the recycling? In fact, as you know, automotive industry is concerned from the mining to the recycling of the electric car batteries. That's why, in fact, we are here, and we will discuss all of these things. I would like to speak a little bit about the global automobile market because this will be the direction that will, of course, define the next steps for the recycling industry also, and some details about the change in the automotive industry. I guess that will give you some horizons for the future. And finally, we will conclude with the regulations in 3 main markets of automotive industry. So I'm here, in fact, I'm working for Automobile Dacia. I'm working for Renault Group for 33 years now. I have been in several countries. In the last 5 years, I'm working for the development of the auto ecosystem for electric car batteries in Eastern Europe. That's why, in fact, I have a lot of contact with the actors of the industry. We already heard that the car sales, electric car sales are slowing down. In fact, it's a strategical choice. We have to notice that I'm coming from Romania. In Romania, we had 10,000 euros of subsidies for electric car purchasers until 2023 ending. And we sold a lot of cars, electric cars in Romania. But with the stopping of the incentives, the sales went down. It's related to the, of course, the development of the infrastructure, but also the motivation of the purchasers. And I think that this is something very strategical from the European Commission, because the incentives is to develop the electric car market. But if we don't have the battery industry developed in Europe, so the incentives are not going to the direct aim, we'll say, as forecasted by European Commission. So, sorry, I'm just trying to back, if I may. No, it didn't work. But anyhow, the automotive market is roughly 85 million cars around the world. Again, roughly 20 million in China, 18 million in US, North America, and 70 million in Europe. And also we see that the electrification is going up everywhere around the world, in all markets, even the small markets. We have in a presentation from Sri Lanka yesterday, we saw that there also some kind of electrification ongoing. So if you may help me, because it's not progressing. Yeah, thank you. And we see that even though the market slowed down with the pandemic period, the electric car sales, the electric car, we'll say, share of the market is still raising. And today also it's raising. And it's not raising only in Europe. It's not, electric car is not just a European, we'll say, dream. but it's also shared in China. It has been discussed, but in United States also. Here I share with you some figures with California, from California. You will understand why I'm talking about California when we come to the chapter on regulations. You see that in 2024, so it's almost at the same level of 2023, no slowdown, but the same thing. And the share also is stabilized around 25% in California, electric car sales. But another fact is that last 10 years, automobile industry invested a lot for lithium-ion batteries, especially after 2020 for European car manufacturers, but for China as a strategical decision from 2010s, Chinese companies with the government incentives have been oriented to electric batteries, electric car batteries, lithium-ion batteries. And you see that here we expect again the prices of lithium-ion batteries going down in the next 10 years. You have to keep in mind that for the last 10 years, we divided the lithium-ion batteries prices by 10. So it has been more than 1,000 euros per, US dollars per kilowatt. Today, it's around 100 euros per, 100 US dollars per kilowatt. And in the future, in 2030, we expect it to be around $50 per kilowatt. And we said that automotive industry is interested in lithium-ion batteries. In fact, the electric car is not a new technology. You know, the first electric car has been made by Thomas Alva Edison in the past. So we know the electric technology. At that time, the lithium-ion batteries were not available and the automotive industry was not interested. Today, why we are interested in lithium-ion technology is that first, we have a climate change around the world, which is a, I'll say, preoccupation for everybody. You can find a lot of information on the internet related to that. I have also some other factors pushing us to electric cars, but some other changes will say we have to end the consumer, how will say, consumer litter culture to be changed, because you know, in the middle of Pacific, we have 7 continents, which is the plastic continent. It's a real continent, you know, in terms of size. So the planet cannot afford anymore this kind of consumption. And also, we need the resources of the planet to be better managed, because we know also the resources of the planet are not limitless. And we have today, we are living in a civilization model that has been designed after the Industrial Revolution, so 300 years ago. And it has been designed for a Western Europe civilization. So it has been for almost 200 or 300 million people. And now around the world, we have 8 billion people that want to live in the same condition, in the same consume models, and this cannot be afforded with the actual model. So we have to change the model. And lastly, it has been discussed. We have also some questions yesterday. What will happen with Trump administration? What will happen with the trade wars? What will be the position of Ukraine, etc.? So all of these questions indicates that the system, international system, installed after the Second World War does not function anymore. So we need, in fact, we have a lot of changes in the society. So we have to consume less. We have to avoid to create pollution. We have to respect the diversity. That was not a question, you know, 300 years ago. Consider that. We have to create a healthy work environment. So in the very first stages of industrial revolution, guys were working at 12 years old in the plant. So today it's not proposed, it cannot be accepted. And also we are looking for life balance. So we have to adapt the industry, we have to adapt the goods, and we have to adapt our lifestyles. And this imposes a new social contract. And in fact, today, what's happening around the world is not the automobile industry requesting an electric car. In fact, the society is changing, and society is pushing automotive industry to go on electric cars. So it's not the choice of the automotive industry to go electric, but the society, European Commission, and we will see that regulations around the world are pushing automotive industry to be electric. And some studies we have seen out of studies, and thank everybody for that. One of the studies from McKinsey that show us for in every kind of scenarios after 2035 we will be 100% electric cars sales around the world. Coming back to regulations, here we have that I presented the main lines of the European Commission roadmap for electric cars. You see that some of them already applied, and some of them will be, of course, imposed in the next years. And main concern, in fact, before electrification is the carbon emission. So the carbon emission should be considered in every stage of the activity related to electric cars and batteries. This is the main concern of the European Union. And car manufacturers are requested to work from mining to recycling. That's why, in fact, we are interested in the recycling industry, also the mining industry. For recycling, we consider that recyclers should be profit creating. So today, I don't know all the countries, but in the country I have lived, in Turkey, in Morocco, in India, and so on. So recyclers are not creating profit, but they are getting some incentives from the government, and then the business model works. So in the automotive industry, we consider that each kind of activity is a business unit, and each business unit should create profit. So the innovation should come to recycling or mining also, because here we are recyclers and we are talking about recycling, but do not consider that miners are in a better position. They are in a worse position. They are still working with 17th, 18th centuries techniques to get out the metals or other mines from the from ground. So battery passport, it has been discussed, so I will not come back on the battery passport need and the content. It has been largely discussed, and thank you for these discussions that has been very enriching for us. European Union is it has been said also that European Union has a lot of regulations, and this is making us going slow in some areas. But one point for the automotive industry is that European Union is one of the biggest market and one of the most profitable markets for car manufacturers. Also, that's why Chinese companies would like to come to Europe. If they were happy to sell cars in China, so they will stay there and they will come to other markets. But the European Union is also a leader for the regulations. So European Commission, in fact, defines the rules of the game around the world. Because in the automotive industry, the development of the thermal engine takes a lot of time and also takes a lot of investments. And these investments, amortization, will need long times, 15 to 30 years according to your sales. And this calculation is based on 85 million of cars sold around the world. If you just take 20 million of this equation out of the thermal engine, then for the amortization, you will have more time. Instead of 15 to 30, you will have 20 to 40. And if you have some states of United States out of the equation, it will go up to 50 years to amortize your thermal engine. So this means that European Union is a leader and will define the rules of the game around the world with the regulation. Here we'll see different regions, and I put especially California, because you will see that until now, from the automotive industry, the regulators requested some, respecting or conformity, but for this battery, we'll say, component, the legislator requests some performances from the car makers. So until now, you didn't hear that thermal engine should stand for 150,000 kilometers, or I don't know, 10 years or whatever. So it has been requested just warranty. Okay, we give you the car, you get the thermal engine today, and then diesel or whatever, and then you have the warranty for, according to your contract, 2 years, 5 years, whatever. And if anything happens, we replace. But we don't have any accountability according to the performance of the engine. But the legislators here request battery performance from the automotive manufacturer. So it's a game-changing, we'll say, regulation. And that is true also, not only for Europe, and also United States. You see that United States, in fact, in California, they request much more than the European Union in 2030. China has also similar carbon content regulations for the battery also. But in 2026, we will see that for around the world, United Nations will define the calculation method for battery emissions. We will talk about the social contract and the impact of electric car. The change of the market is not just for the automotive industry, it's also for whole society. This means that we have some jobs that will be created, but some jobs that will be disappearing. You know, the guys making the repair of the exhaust line, I don't know, here, maybe in Amsterdam or maybe in Bucharest. So they will have no cars to be repaired. And the guys that are manufacturing exhaust line will not have any more exhaust line to be manufactured. So yesterday, I think it has been discussed, we need skilled people. New skills should be developed. And for new skills, in fact, we have two populations. First, young generations, and second, elderly generations. For both of them, we have to develop some training programs. So we should not be considering that these skills are available. We need these skills in Europe also. In the company I worked lastly for the development of the battery cells in France, we had in the engineering center, we had 400 engineers, 440 engineers with 42 different nationalities. This is to say, in France or in Europe, we don't have enough skills, so we have to bring these skills to Europe and learn from them and establish our plants. But this is not just for manufacturing. For after sales also, we need these skills. We have to develop such kind of skills. It has been said that the capacity of manufacturing for different refinery, we'll say, different metals and the different components of electric batteries that we will need in the future. In Europe, we will not have enough capacity. In the United States either. So the US and Europe should need to import these components from other countries. So the regulators should also think about that for the importation of, for the imports of these kind of goods. Now I will go a little bit faster. I stated here, in fact, the different aspects of the regulations for the automotive industry in European Union, in US, and in China. In the European Union, you know, the key regulations concerns the battery regulation from 2023, extended producer responsibility, material recovery targets, and carbon footprint declaration, which is a key factor for automotive industry. Related to the compliance and enforcement, we will have strict recycling quotas in European Union, and also the funding for research is also available. For the stakeholders, you know, the most important one for car and battery manufacturers is in Europe. We have to invest in the recycling, and we have to comply the sustainability standards as a car manufacturer. And this implies a higher cost for us, but this will also give us an opportunity to create some innovation. But for innovation, I'm coming back to the skilled people again. So we need a lot of engineering, a lot of engineers in every areas, and this is the main lack of automotive industry today, engineers. Next point for the impact on stakeholders, the battery recyclers, we have fostering business growth, and end users will pay higher cost, but they have a long-term positive effect on the market. For North America, it's in fact market-driven regulations with state-level variability. So from one state to another, it changes. For the key regulations, there's a lack of federal mandate. So states are dealing with their own regulations. The IRA is a key, we'll say, factor, but we don't know what will happen. You know, for life cycle, for instance, lastly, Biden administration gave 450 million euros for their investment, but will it continue with Trump administration? No idea. So we'll see. It's a surprise. The same applies for the Department of Energy incentives. In fact, the life cycle get the incentive from Department of Energy. They have state-level enforcement, industry-led initiatives, and automaker recycling programs are available in US. In US, the car manufacturers face some uncertainty, we already mentioned. For battery recyclers, they have some opportunities for innovation, and the private sector growth is promoted. Finally, for the end users, they have limited recycling options in US. Coming back to Asia, so there is a Chinese dominance and a state-controlled strategy in Asia. For key regulations, we will state the interim measures for the management of power battery recycling that has been put in place in 2018. They have a national mandatory recycling quotas, traceability system is reinforced, and the encouragement of the urban mining, which is not available in other areas. Last slide, so don't worry. The government penalties are available for compliance. The investment in recycling infrastructure is enforced, and lastly, corporate leadership in recycling imposed. For the stakeholders, we'll say, they have some subsidies, but they are facing high compliance obligations accompanied with cost. And for battery recyclers, there's a strong government support. We know that the capacities are developed related to that. And this is the last table. You will see the differences in regulations from each area, but I already stated the main points. What I will say for the technology investment, European Union and China has some government-backed or research or incentives, but in United States, it's just private, we'll say, initiatives. That's all from my side. Thank you for your attention.
We got time for one or two questions.
Hello. Thanks. A lot of information. Globally, it has been observed that the drive miles of private cars are reducing, and even the governments are enforcing strict regulations for public transportation, micromobility likewise. In this context, that having this much of number of kilometers, 250,000 kilometer warranty, 80-year warranty, I mean, are these practical? Because private cars in my country, 80% of the cars spend their 80% of their lifetime while parked, because running is very limited. I mean, in larger countries also, I observe only 20-30% of cars achieving this much of a mileage. So what's the practicality here? Aren't we considering the impact on public transportation in reducing the private mobility?
It's in fact, in the public transport is a different area. I can comment on that, but it's not the peculiar area of this discussion. For public transport also, we have a lot of incentives in government funds in Europe. The idea is to electrify all the public transportation. This is the main concern, and they are consuming a lot of batteries, you have to consider. But it's much more LFP technology than NMC. And for this sector, this will not change any, there will be no change if it is coming from transport, public transport, or car, private car. For the mileage question, you're right, but it's just the average we are talking about. We have many of the people making more kilometers, you know. For instance, myself, I'm making 55, 60,000 kilometers per year, but the average is 15,000. So we have some car users making much more, and the regulators will check upon those making this mileage. Thank you.
All right, let's thank your speaker again. Up next, we have Sean Joseph. He's the co-founder and finance director at Altilium, which is currently the only UK company working to have a totally integrated recycling operation. And Sean comes to us with over 2 decades experience in the banking and finance world. And he's gonna be talking about a subject very dear to me, the struggle journey of a startup, especially a hard tech startup, not a software one. Sean.
Thank you very much. And thank you all for taking the time to listen to our journey. You know, from my perspective, I'm not coming from a technical background in relation to the chemistry and the development of the process flow that we have at Altilium, but I am coming from a business background in relation to how do we make this industry economic? How do we make a business out of recycling? Because I think at the end of the day, and some of the commentaries around, you do need to make it economic for people to want to do it. At the end of the day, we all are feeling good about ourselves to build a business like this. And it certainly, as an investment banker, it gives me great pride to talk about our business and where it is today. But if you expect funding, if you expect to be able to build a hard tech business with significant CapEx, there does need to be a representation of profitability that comes through in the end. So for us, in 2020, we started. 2020 was a period where not a lot of people thought it was a good idea, but we started and we certainly identified the opportunity around the critical metal supply chain. You know, our real strategy is to develop domestic supply chain of critical battery materials from, we call them waste streams. We are also known as urban miners. And so we are committed to recycling, repurposing and reusing waste streams into another battery. We have a patent pending process that can recover 95% of battery metals with 20% lower cost and 74% lower emissions. Because look, at the end of the day, carbon is a big driver for this energy transition, the move from a carbon-based system to a critical metal-based system. And we're certainly seeing that in relation to the support we're getting from OEMs and the commitments they've made around carbon reductions to 2040. We have been lucky enough to get some good partners, and I can give you a scoop that on Monday we'll be announcing another partner joining the group in Mizuho Bank. And so we now have SQM, which is the world's largest miner of lithium, Marubeni Corporation, a large Japanese conglomerate, and Mizuho Bank as our foundation shareholders. We've also been the beneficiaries of government grants, and we'll be forever thankful for the government grants that we've received, £10 million through the APC Faraday Battery Challenge and Innovate UK. And we've now opened our first pilot plant. We've moved from kilogram scale cathode active material production to metric ton scale cathode active material production, and we can produce up to 300 metric tons per annum of cathode active material. We're delivering that to our OEM partners in Nissan and Jaguar Land Rover through our CAM qualification. Oops. So this is us. You know, really our business started here. Our business started on the technical side, on the hydrometallurgy side of the business. So our process started really on the technical of separation of end-of-life scrap into a cathode and indeed an anode product. We've been working on an anode product for about 2.5 years. We've been working with a partner in Talga, and today we've announced a partnership agreement with Talga in relation to production of anode graphite in line with what they'd expect from a virgin mine product. We started on that, but we have quickly realized that you do need to manage upstream processing as well in terms of black mass production due to the quality variability that we were receiving from black mass suppliers. So we have a full circularity solution within the UK. One of the reasons we think the UK is a very exciting market is that it's an island, a bit like the Irish example, but a much bigger island. In the UK, there's 1 million EVs driving around today. It's the largest secondhand car market in Europe. It's the fastest adopter of EVs in Europe, with 1 in 5 new cars on the road being an EV. So we think that's a prime market, but we can also execute an upstream strategy as well as a downstream strategy because of it's not such a big island. So we can go from battery collection all the way through to cathode active material production in the UK, and that's our plan. We are also working on zero carbon collection and transportation solutions. We have a patented cassette system where we can collect end-of-life EV batteries in a shipping container and push them in like a cassette. That will then discharge the battery to be ready for shredding, but also charge the electric vehicle or the truck that will drive the battery to its final place, because we didn't feel that there was much sense in driving around end-of-life EVs to recycle in a diesel car. So that was really the thinking behind that. And, so that's really our battery strategy, end-to-end collection, right through to an eco cathode and eco anode. So we have, 4 plans in terms of development. ACT, luckily enough, is an acronym for Altilium Clean Tech. So we've got Act 1, Act 2, Act 3, and Act 4. Where we are today, we are already in production on our small commercial in Plymouth, and we are in the process of funding for our large-scale recycling facility. We were thinking to do it in Europe, in Medet, Bulgaria. We have an existing 170 million ton JORC copper tailings plant there with a solvent extraction electro-winning plant on it, but we have recently decided to make the decision to do it all in the UK. And the end game for us is to go mega scale recycling in Teesside, which will be able to recycle 150,000 EVs per annum. We are lucky enough to have trusted partnerships right across the value chain. We have strong supply partners, as mentioned. We have JLR and Nissan as both supply and offtake partners. BYD also supply us batteries. We have been using our technical partners quite heavily in Hatch, ABB, and Imperial College. And as I've mentioned before, that we've had shareholders and other stakeholders that have helped us along the way. This is our process. We have got patents pending on this process, but really the high level for us is that we have 95% recovery, 74% reduction in carbon, lower cost, very strong recovery in relation to graphite, and we can do a mixed stream. So we don't necessarily need to do MNC. We can do LFP. We can do consumables within ranges, not one or the other, but we have a process that is quite flexible and that we can, move as the market moves in relation to how we recycle our product. I guess, for us, again, we are, looking at how we reduce carbon. At the end of the day, the question is, how do we compete with China? How do we catch up to China? And my answer to that, there's a couple of answers. One is be lower carbon, and we have done a Minviro analysis where we're 74% lower carbon from a process flow. And as I mentioned, it doesn't make much sense to get an end-of-life EV, put it on a diesel boat, ship it to China, shred it in China, put it on a diesel boat, bring it back if you're looking to have a lower carbon supply chain. And so, for us, it's really around lower carbon, and there's a geopolitical element in that, having control of your own critical metal supply chain, I think is important. So there's 2 things there that I think are an advantage to us and will enable us to provide a reasonable alternative to a China supply chain. So exciting. This is an exciting slide for us. We have a partnership with Jaguar Land Rover. We are in the process of building a battery for an I-PACE car that will mirror the 2036 regulatory requirements. And we are going to test the performance of that battery versus a Virgin Mind battery or traditionally produced battery. And actually what we're seeing is the performance to date is that our process in this battery outperforms a traditionally produced battery. And again, I'm not a chemist, but my simple, and I'm sure my chief technology officer will kick me under the table, but my simple comment on that would be is that we're dealing with at the beginning, a more refined product. We're dealing with a product that's already been refined when we take it out of a battery. So it's a refining of a refined product, whereas a classically put together battery or virgin battery hasn't had that type of refinement. So, we are excited about that, and will be looking to release that at Cenex in September this year in a store with Jaguar Land Rover. I think what are the key challenges? And I'd say it hasn't been an easy road. It's been a real battle, and it's been a real battle around funding. I think if I sort of cut to the chase, I think the story holds together very well. I think the market in UK is a very strong one, quite a accessible and accessible market. But the newness of the industry and the volatility within the market and mineral prices has created a challenge for us. Despite that, obviously, we've been able to attract SQM, Marubeni, and Mizuho as investors, but this is a high capex type of business. If we physically want to have a recycling industry in Europe or in the UK, you physically need to build chemical refining plants. You physically need to be able to pick them up and shred them, and you physically actually have to do hard steel in the ground to make this business work. And so there's a lot of investment shyness around that, I'd say, if you couple that with the volatility. So we feel we're well positioned. We feel that we've got a very strong business case. Our technology is world class. We are the market leader and indeed the only one trying to do this in the UK. But the funding side of it all is something that needs to be addressed, and support from governments as well, I think will need to be addressed as well. If you look at a China industry, a lot of government subsidies have gone into building that ecosystem. When I say a lot, pretty much all, and the ability to operate at losses has enabled them to take this position that they've got today within the automotive industry as well as the battery industry. So, one thing I would impress is that we need to work out how we get the funding to the place that's needed, because if we're going to reach net zero, this infrastructure needs to be built now. I think 2030, 2031, it's going to take, even if we had all the money today to build our site, it's a 4-year build. So, we're in 2025, we're 2029, even if we had the money today, and we're the only ones trying to do it in the UK today. So it gives you an idea that practically, theoretically, it all kind of makes sense, but the money needs to come sooner rather than later is kind of how I would leave you. Thank you, and I'm happy to take any questions.
Thank you, Sean. I really appreciate the realistic timeline on building these plants that no one else seems to realize. Do we have any questions from the audience? I'll start with one. So we've seen a lot of regulations around Europe on either forcing behavior or preventing behavior. Do you see some middle ground where we can start to maybe incentivize solutions versus forcing?
Yeah, I think the answer is it's better to be the carrot than the stick. I do understand that OEMs have got a lot of challenges themselves, so there might need to be a bit of a stick to get them moving in the right direction. But eventually, I think incentives is where we're going to get the real acceleration of adoption of what we're trying to do.
Thanks, Sean. Really interesting. Question I had, you mentioned you guys are looking into battery cell production. Is the idea also going to be that that battery is easily recyclable? You can take that back. Just wondering what the long-term thinking is there.
Yeah, look, it's not, we aren't really going to be a battery cell producer. It really is our partnership with Jaguar Land Rover that will be produced, or their battery manufacturer, which will be AESC. So we are not in the game of battery production, but we do need to get our product into a battery to test its performance. So I think it's a very good idea to have that, easy to dismantle, easier to access. My challenge with that from a business perspective is where does that get prioritized in terms of the challenges that these guys have?
Arndt Böhler, Daimler Truck. So in the past, the UK market was a little bit hard for automotive because of left-hand steering wheels and right-hand. Do you see any opportunities now because the battery is independent where the steering wheel is?
I'm not sure. I think, but I would say that, say Nissan, for example, who has a manufacturing site in the north of England, 70% of their cars are sold in Europe. So I think they're already producing left-hand drive cars. But I'm not sure exactly whether there's an opportunity there.
Hi, a nice presentation. And there is also the Chinese is dominating in recycling, but there are also strong technological company in the US. They also want to come to Europe. So the Europe recyclings and also US from China also. So how do you see it? Because it depends at the end of the day, the process fee and the better technologies will come day to day. So you are dominating UK now, but if somebody, it just depends on how how much money you invested in the first or the process at the end of the day. So for the 10 years later on, every country will have the cycling itself, or depends on we invest in the first country or something like that?
I think for us, it's a combination of both. We don't necessarily have any plans to move into Europe anytime soon. I think it's a blessing in disguise for us to be in the UK. It's a little bit underappreciated right now in relation to an opportunity from a recycling space. Quite frankly, our views are that at recycling, you need to build at scale. Process and efficiency is definitely a key consideration. We're spending most of our money right now on both of those things, but you need to build it. If you can build infrastructure that can recycle end-of-life batteries and scrap, I think you're in a very good position to take a leading market position within the UK. And even within Europe, it's just the scale. Like, I think when I saw the Porsche, presentation that the by 2035, I think there was 2.1 million kilometers of train line that would take all the end-of-life scrap. So that's how big the issue is in relation to end of life. There's so much scrap to be processed and recycled. I think if you can build the infrastructure, you have a very strong opportunity to be successful.
Hi. Have you paid enough attention in your business model with the shift from lithium-ion to LFP based?
Yep, we have. And one thing I would say, and again, I don't want to be sensitive, but lithium-ion is going to last longer, right? And it's only really starting to take a position in the market today. MNC has been the dominant market position. So we're probably talking 14 or 15 years from now when this first wave of these first stage lithium-ion batteries come ready for recycling in terms of at scale. But that said, we are preparing in that we can do a mixed stream in terms of our recycling process. So we can recycle not just MNC, but we can also recycle LFP, and we can recycle consumables as well. And we've been doing a lot of work on graphite, because I think it's difficult to make a lot of profit today anyway out of lithium-ion recycling in the UK unless you're really squeezing the payables, and the graphite's about 40% of the payables in lithium-ion.
Do we have any other questions?
Thank you very much for your time.
So now we're going to move on to the panel, and I'll let our moderator take the lead.
So we have heard now quite a lot about economics and now by an investment banker, a former investment banker, about profitability. So I would kindly ask the 6 panelists, it will be a challenge today, having 6 panelists to join me on stage, please. So it's Sueva, please. And I won't introduce the people because you have seen and heard them already yesterday or today, except Ilya. He's a colleague of, what was his name yesterday? Alberto, who presented End Circle. So please take a seat. Profitability, and mind the edge of the podium, please. Not to. Okay. Profitability is one key, and we have a variety of perspectives here on stage. So I would kindly ask you, each of you, with one core statement, either from your perspective or what you have as a summary from the days. What drives profitability in this segment? And as an outside-in view, Jared, if you would start.
Sure. Comes down to product choice you're making and scale. It's that simple.
Next one.
I think supply chain integration and yeah, scale. I think those are going to be really important, and maybe also knowledge and technology transfer. I think one thing a few people are talking about is when China it got Western investment in, they did like a 50+1% deal, and some market participants we've spoken to are saying maybe Europe needs to do this with the Chinese and Korean players coming into Europe for investment to take that knowledge transfer, that technology transfer, that can help maybe profitability as well.
Okay, thanks. Just go ahead. No order anymore.
Yeah, I think in my perspective, I think what matters most is the capex, the first thing, and the second could be the value of the output. In matching these two things will be very much critical, whatever the scale is.
Yeah, as I said in my presentation, we have a different perspective into the recycling, and definitely to us, the critical topic or the critical element into the equation is the value of the battery itself. So enabling the repair of that, enabling the fact that it can be services, it can be refurbished and repurposed, that increase the value of the battery and increase the value of the second-hand car. So that's the take from our side.
So Dominic Scheider, I will speak later today. Company Rockwell Automation, and I will introduce myself early afternoon. But for me, in digitalization and manufacturing and automation, it's about being customer obsessed. For everyone here, being cost down obsessed means to be data obsessed, yeah, and really think about the value of data and to end the process upstream to downstream. Being the new oil, everyone must think about how he's managing his data, as I said, end to end.
Oh.
Yeah, I fully agree with what everyone said. I would just potentially just add to the capex on the OpEx side as well. It's as you scale up as well, improvements on consumables, on costs, on transportations, and as you said, with customers, like you need to find your USP and be aware of where the market is in terms of commodity prices too and product distinction. Yeah.
Okay, thank you, everyone. Going one step further in detail now and starting with the value chain, where do you see specific technologies or specific development, which was mentioned probably today from or yesterday from any other speaker? And I would start in the value chain in the beginning with Ilya from the mining industry.
Yeah, I mean, we are really like agnostic. We're not only just focused on recycling or mining. It's a refining technology. I believe that having especially depending on your first use case, modularity, so that you can really scale your customer or with the feedstock is one part. And then, you know, you need to have an edge in terms of if you have for example, a decentral approach, and we had here some solutions to, is you can just you know, optimize transportation routes and just have an agile technology as such, where you know the market changes a lot. It's market dynamics, supply and demand, but it is well regulation. So you just need to have be agile enough to adjust, more general.
Okay, thank you. Next, potentially Cameron. You mentioned in your presentation water treatment, and it's also in the beginning, and some additional information or totally something different?
I mean, all hydromet is still water, right? So still water treatment in a sense. But one thing you never hear any of the refineries talk about is the actual end wastewater of the process. The sodium sulfide is going to be an absolute massive issue if even a small percent of refiners come to scale. It will instantly saturate the market with that sodium sulfate. So now it's a massive waste stream. So we really need to start thinking of what other technologies can be introduced to kind of reuse it, recycle it, and put that water back up front and get that closed loop. But process side, waste side, it's still water treatment in the end. Hydrometallurgy is just water treatment. Right.
Okay, thank you. And Dominic, sorry for not introducing you, but in the company name, it says automation. So if you have a specific focus potentially on that, independent of where the value chain is?
I mean, in terms of automation, basically we think about the plant itself or the four walls of the plants. And you talked about value chain, means it starts much broader. And we talked a lot since 2 days about the value of the battery regulations, not just to apply to the regulation, but also to get value out of it. So we definitely think the digital thread will be starting from the design phase, as we said about the eco-design of batteries. And there will be a lot of value to conduct this digital chain to the end of the end, which is the recycling part of the battery pack and cars. But all in all, the value is not just to think about CapEx, as was said before. It's really to think about the total cost of ownership of the equipment. And this is where we think we can contribute, not just by a commodity. We know automation is not very high in the tier of priority. It's maybe tier 2, tier 3, things that are coming by evidence with a lot of equipment. But we think we can help any companies to build more value in the total cost of ownership. So 15, 20 years of value out of the equipment.
Thank you. Matteo, you spoke about the binders, and the binders are between two other materials more often. So would you have any requirements in your other components that they have specific chemicals inside, not inside, aluminum and all the other things? Or where else do you, from a binder perspective, see potential?
I mean, definitely we see many opportunities for technology development to drive sustainability and to improve recyclability of batteries. For sure, we have tackled some of them by just mentioning a few examples on the tape use of debonding technology, but definitely we can think about other ways of creating impact and creating value. And for example, for sure, we are in the field of development for not only PFAS-free, but also solvent-free binders. This is something that we can definitely think about. And also, of course, not too much ready to be talking about that now, but still a very interesting opportunity. And for sure, also talking about future technologies in battery like solid state, we can also think about solvent-free electrolyte, solid electrolyte developments.
Okay, thanks. Sujeva, you mentioned Sri Lanka yesterday and in your questions also. Outside view, what is, from your perspective, driving profitability that the batteries won't come to Sri Lanka in the end anymore because they are recycled or handled anywhere else?
The context is quite different. I mean, adding value, while I'm listening to the colder and the developed world here, where I'm coming from the more warmer climate, where the degradation is much higher. In the European and even in the Chinese context, the temperature, the degradation rates are much lower and the battery life is extending from 10 years to now we are hearing 15 years. But in our perspective, say I'm not talking about my country, but the warmer world, it is a much shorter. I think if the Europa which is much more regularized and much more advanced in its the regulations, pay enough attention to the warmer countries where the degradation is much higher, I think they can you can add very high value to the chain by paying more attention, because the EV popularization has been hampered simply because of the hotter climates, and it's two different worlds here.
Okay, thank you. Viral, to end up this round, low carbon footprint or CO2 emissions is also something. Do you think the targets are strong enough, or do we need some fees, some tariffs, or additional restrictions?
I think it's twofold question. So one is the consumer demand, and the other side, is the regulation. Is there certainty? And I think, our colleagues from, Julian and Johan are, focusing on that, especially in Europe. From the, consumer side, I think there is going to be that demand. We've seen it in other markets that we cover at Platts. So on steel and aluminium, consumers will pay a premium for low carbon materials. So for aluminium, for example, max 4 metric ton CO2 footprint for every metric ton produced. For steel, about 1 metric ton for 1 metric ton. For batteries, again, for the raw materials, it's going to be similar. Obviously, the footprint for nickel, for cobalt is huge. I think even like green nickel is like 20 metric tons of CO2 for 1 metric ton produced. There is going to be a drive from the consumer side for this. We've seen it, in these markets, like from some companies, especially automotive in Europe. They're very keen on making sure their supply chain is more ESG friendly, has a lower carbon footprint. So I think that's one side. And then, the regulation side is going to be interesting. We've already seen CBAM, the proposal to delay to 2027 for some aspects. What's going to happen now with the other sort of recycling targets that we've talked about in EMEA? I think everyone wants certainty, and that's going to be the big challenge. But I think there is, a consumer demand for low carbon. So I think that's definitely something that we have to keep in mind.
Okay, thank you. Now to open the discussion a little bit, and between your panelists, do you hear anything new? Do you want to add, share anything before I would ask specific questions to you? Just feel free if you want to add anything.
Just one comment on the AI, because we have all played with ChatGPT since November 2022. It's just a bit more than 2 years that we play with Gen AI. And we have started to talk about AI yesterday with AVL presentation, and even this morning I've seen that as well. So it's just the early start. So the question yesterday on the panel about what's about 5 years projection, I think AI will be in everything that we are talking about, in the traceability of carbon footprint, the chains and things we don't know how to achieve that today. We will see some solutions from the design to the create, the implementation, and even the process itself. We will see the improvement generated by AI. And I think that should be a topic by itself from the chemistry to the mechanical engineering and digitalization. That will be changing a lot of things. So that's my comment.
Any
comments on that?
Just to add on the other side, AI is going to be huge for demand for BESS systems as well. So just on the other side, that's going to be a big driver, I think.
Okay, thank you. Then starting specific question to you, Matteo. Do you see in collaborations of you as a supplier with other companies or companies in the chain possibilities for profitability?
I think it's not only opportunity for profitability, but it's actually the only way of tackling the challenges that we have ahead of us, because the complexity of those challenges are huge. I think we have been discussing the challenges and none of them is simple enough for one company or even one sector to tackle it by itself. I think it requires huge degree of collaboration, and for sure we are trying to build a very strong ecosystem in the industry where we make sure that all the parties that are somehow touching your product or your service have to be very well integrated to each other. And to make that and to offer that, you can only accomplish by making very strong technical partnership and co-development. Now the topic is to find also interest that is common at the other side. That's definitely the challenge, where you don't see very much a win-win situation, but definitely I think this is the way forward. And in regards to the recycling, where we are definitely looking for higher interest, it is in all these assembly processes and automation, where we see chances ahead of us for a more intense collaboration and partnership.
That's why you showed Liebherr on your slides.
Yeah.
Okay. Thanks. Next question to Viral. We talked about metals quite often. Do you see any chances in bundling capacities in metal recycling? Because batteries is one, but we have copper anywhere else. We have circuit boards anywhere else. So why focusing on recycling just on batteries, not bundling the expertise?
Yeah, I mean, we do already see this. So some of the more sort of traditional recyclers, so say in the European market, you've got players who are dealing with end-of-life vehicles, looking at ferrous scrap, non-ferrous scrap. A lot of those guys have started to invest in batteries and to take the full value. So, you know, the copper, the aluminium, that aspect, I think, is going to start to come. And I think you need that, either that sort of fuller scope of the supply chain and see the possibilities for you know, the materials that everyone wants and the profit you can get. I think you're going to see more of that. And then, you know, even to, you know, here we've got, you know, colleagues at Altilium and TeZero who are looking to extract the graphite. There's a lot of recyclability potential, and I think either you find the right partners or you try and scale up yourself. But even getting the other metals out and sort of you know, trying to get as much value as possible, I think that's going to be a big push. Yeah.
And if I just add on to that a little bit, I don't see other recyclers trying to do everything, right? Because they're not the same. Feedstocks matter. Black mass is not the same as e-waste. Is not the same as, you know, ferrous scrap. Completely different processes. Unless you have just unlimited capital to build multiple chemical plants, it's just not going to happen. I can see, say, like an e-waste recycler just maybe shredding and making black mass, some intermediate product that's low capital intensive and low value, sure. But the final refining, I don't see it.
Please allow me just one statement. It's about the wording. We use recycling, but I think it's not defined what is recycling. Pre-treatment, hydromet, black mass, refining, and all these things. Therefore, yeah, you can combine potentially companies and value streams, but I do agree, yeah, it's hard if you're on specific process step. Dominic, automation, once again, sorry. Automation needs sometimes standardization. And we are really good in having rules in Europe. What do you think? Would that be also a lever for enhancing profitability?
I've talked to a couple of US colleagues about that, and especially in regards of regulation to kind of force the story. Every time there is no regulation, there is nothing happen, you know. And in food and bev or life science, each time there is a regulation, like in FDA, Food and Drugs Administration, or whatever, there are things happening. So if nobody is paying for, nobody will implement anything. So at the end, this is how it goes. And we have the technology, the platform, and the partners, and I will talk about that, to implement these solutions. But digital is just a way to respond to the consumer needs, as I said, customers, or to the country and the regulation that are happening. But at the end, it has to be clear who will pay for it. It can be the consumer if he's ready for that, but it has to be regulated, because otherwise nothing happens.
Is it specific then for each market? Let's say, as we saw today, Europe, US, and
specific China? By industry, by regions, and again, it's not nothing of this is new. It has been implemented already many times in many industries. It's just new for this new industry of battery, but at the end, it's for a lot of other industries, it has been considered many times.
Thank you. Ilya, and we talked about materials impurities. So how relevant is sorting for you by the pre-treatment facilities, for example, or by the ones who provide material to you? Do you accept impurities or unspecified deliveries, or would you then decline the incoming goods?
Yeah, I mean, of course, you have your specifications and you work based on that, and you have, in our case, your core technology. You need still some pre-steps. Of course, you need to adjust. It depends, because customers also, like they have also varying feedstock. So I think it's as also Matteo said, it's you need to work very closely together as an ecosystem. And if you then go to refining as a service, and what the whole idea is, it's also like the whole business case is to reduce then for your downstream partners, impurities. So that's also, of course, your job. But I think the preparation phases are very important, just to know exactly, okay, I've tested all these feedstocks. I know I can do that. That's just to be very prepared. And if you look at the market, is depending on who your customers are, they also, they have different varieties of feedstock. So it's really preparation, and then also react to certain things, and know really what your technology upfront can do, and be very prepared for what the market then brings in.
We heard today that there's overcapacity. So what would you see from a recycle perspective? What is more relevant? Clearly sorted or utilization of your facility? Because both drives profitability at the end.
Yeah, sure. I mean, it's you need to be prepared, because on the capacity is we really like if you look at the big plants that run now at sub 50%, say in South Korea or in other parts of Asia, those are very big plants, right? And that's the nature of hydromet refining, is 40,000, 50,000 tons of input. So we have a different approach, where we start, as in Ohio, with 3,000 tons, and that's a bit where the market is at right now. Then if you look at, we had a lot of presentation about black mass capacities being 60,000 tons maybe in Europe, right? So that's just the nature of the market. And with feedstock is really, I mean, that's what refining does, really, the impurity removal. So it's always a combination. Yeah.
Okay, thanks. Cameron, if I read your vitae correctly, you have also a background in the scientific world, not just startup. So anything from that perspective where you see more needs? We talked about qualification, all this stuff.
When it comes to the scale-up factor, in academic life, we do a lot of carbon capture, where a pilot plant is a 2 megawatt scale type thing. It's like 8 stories on a power plant. If your planned production is 60,000 tons a year, you can't go from 100 tons a year to 60,000 ton a year design. It's just not going to work. I mean, look at Life Cycle, for example. I'm not saying that's what it was, but it was definitely a contributing factor. If you don't know how your inefficiencies scale, you can do things on small scale, like move solids, move powders around. Large scale, if you have tons of this stuff, you can't just walk a bucket from here to there. How are you going to plan for that if you don't have the scale, don't have the pilot to do it? So that I think that is the biggest thing we're missing in this industry, of the intermediate scale pilot plants.
Okay, thank you. So Yeva, in one of your questions, you raised the topic about public transportation compared to passenger cars. Do you see the potential not just for Sri Lanka or anywhere else, that public transportation or green procurement by the authorities could drive a change? They force specific facilities, local content or whatever?
It is still a question doing public transportation profitably, because it runs anyways on the government subsidy in most part of the world. But the government invests on these facilities looking at the reduction for the benefit sake of the environment. The ultimate goal, what we are thinking of recycling as well, to minimize GHG, and also added to that, the movement of the people also getting reduced with the help of the AI, and then again we keep learning to get our things done without a real movement. So I think this will, and also with the shared mobility, like taxis and sort of things, micro mobility, especially here, the cycling and all that. So this will present a huge challenge to the recycling volumes in another 10 years, as I see. Public transportation plays a major role. True that the batteries are getting used there, those batteries are going for recycling, but the usage is much longer. It will have the presence of public transportation will definitely have a huge impact on the profitability of the recycling operations, I believe.
Okay. Another topic or issue could be who owns the money and who get the margins. So what about joint ventures, collaborations between companies, startups collaborating with OEMs or whatever? And I would suggest we start on the left-hand side.
If you start with me, then as we provide equipments for automation, we do not deliver equipments ourselves. So we always have this type of, as you said, partnerships for the labs to the first pilot line, to the pilot line, to the mass scaling. We have engineering, system integrators, EPC, also working with us and the end user. The recipe, the process is not us, it's the user, the genius guys that are creating that, but we need to create an ecosystem of people working together, really understand who start where and who can provide what to finally achieve the grail of the profitable units, right? So it's a long journey. I mean, everything decided in the design phase will have a consequence on the production run in 4, 5, 10, 20 years. Again, I said long run. So yeah, it's always a group of people working together. It's never just one individual, as you said. Everyone brings his expertise to obtain the final result.
Yeah, Dominic, fully agree. I mean, it's an it's an ecosystem, right? And you start maybe 1-on-1, 2, but it's the whole ecosystem and the entire supply chain. I mean, in China they've done it. That's how they did it, and not only locally but like geographically. Because the more you work together in the supply chain, the more you capture of the value and the profitability. And I think as we speak today about profitability, you have base cases, but then as well you have to think about if let's say the ecosystem is not as vertically integrated, for example, you're exposed to a lot of risks, right? Just disruptions. And that can make you break, actually. I mean, those 3, 6, 9 months of a P&L, and that's what you have to be prepared. And even if it doesn't look like it today, whatever you do now will shape the supply chain in 4 years, 2 years, even. So that's why it's really not only on a base case what we expect, but what could happen, and you need to have some probability as well when you calculate P&L that can happen. Yeah.
I think something to add is just when you are considering these partnerships with between startups or like funding startups, there's got to be established knowledge or established partnerships with companies already in the market. I think
the example recently of Northvolt, you know, went really big, but the technology, it kind of went, you know, spread too far, too fast, went for a huge project. And obviously there's been a lot of struggle. I think a lot of the successful startups we've seen are partnering with companies that have a lot of that expertise that can help them scale, and, you know, have trusted partners. And I think that's really important, especially in Europe, where we do have a lot of funding for startups. Bringing in those established players to support them with that knowledge transfer, with the skills, with the technology, I think that's really important.
And second, all that, I think if you're not vertically integrated, like, you're just not going to work. Shredding can make some money. It has tight margins. The end can producers, right? They have options. But if you don't have that vertical integration yourself or have partnerships, good luck.
I think when it comes to funding, the biggest barrier is not having the correct data. I'm just wondering why even AI cannot push the battery passport, because having that kind of a thing will give the world the whole new insight into the problem what we have. So then the funding, all the recycling may not be profitable in the sake of recycling itself as a business, but there will be like public transportation giving added, the government subsidizing public transport because it is giving added value to the whole economy. Likewise, the recycling adds a serious value to the economy, but we are trying to make money out of recycling itself, which is not going to happen. So, but if we can prove the world with the great initiative of this, the long delayed battery passport like a thing, with the support of AI, I think that will pave the way for better funding for the whole recycling business.
From the supplier perspective here, for sure, getting into partnership is the way forward. And as you said, a partnership is not only technical partnership, not only technical development, but it's also eventually having partnership in creating new business models. And definitely we are engaged in some of those examples where innovation is building a new scenario. And for this new scenario, you actually need different technologies to come together. So then that requires, for sure, new business models to be created. And here, one of the challenges is not only where the money goes and who takes what in that, but also in terms of intellectual property. How do you make sure that what you bring in is then protected in a way that can make you sustainable for the future?
Okay, thanks. One open question, and please feel free to answer. We heard startups, we heard potential. Do you see any company or startup in the market who could become a new unicorn, like Google, like Amazon? Do you see anyone?
Not if it's hard tech. There's some out there, but it's only on paper. There's no exits that are doing those unicorns. If you have to build something physical, I just don't see it happening.
Okay. Anyone else?
Just a comment, at least for what I saw in France in the past years, they are not unicorn, but they are the expert in recycling of other things today, and they are observing this recycling market, of course, very carefully with in and out, as we see in Dunkirk today, some projects postponed, cancelled. So it's not future pepite, it's already massive companies, expert in treatments, already on the market that can also pause some investments because they know it's maybe not the right time, but they are large enough to wait. And that's also what I see.
As we don't have a specific Q&A session, or do we? No, just one to the audience. There would be one, Johan.
I don't want to disturb the positive feeling in this discussion, but we have a lot of initiatives and a lot of fundings, but as it stays in a subsidizing business, the business model should run by itself finally. And what we see in the Netherlands, that we have a lot of
projects on projects on projects and continuing projects, but there will never be really economy of scale thing coming out of it. I just want to make a comment that I like all these initiatives and everything that millions and millions are reserved for this kind of things. But finally, for normal companies, things should pay themselves as a business model. And I think there are a lot of discussions going on theoretical things which will not become a business model in the next 5 to 10 years.
I think you will see all the recyclers will be profitable, right? All the TEAs show it's possible. And it gets down to, again, what's the product you're making? What's the scale you're doing it at? What process are you using? If you are a mining company and using that same mining knowledge, probably not going to work. 'Cause it's not the same thing. So you got to get a little innovative on how you're doing your process, perfect it, improve it to get those costs down. But I think I disagree. It is definitely profitable or possible to be profitable, but you got to hit that steady state. We need the feedstock. We need the infrastructure. The first plant built won't be profitable. Second one will be way better. Third one should be even better, right? It's got to go through the normal process of building new technologies, building new plants.
Okay, 5 more minutes left before lunchtime, and topic is profitability, market opportunities. One question to all of you, and we would start with the answers on the right side with Matteo. If you would have to spend your own money in that economy and the ecosystem, own money, not company money, would you do it, and where would you do it? Take some time to think about it.
Maybe answering that question with the microphone is a little bit tricky.
It's recorded.
Yeah, that's why. I can only be consequent on what I say publicly. So for sure, it is a tricky question, and I think basically for two reasons. And one is uncertainty coming from the economic perspective. So much uncertainty gives you a scenario that is very, very, very difficult to predict, especially long term. And I think here it was mentioned also yesterday, when you don't have a clear regulatory framework and stable framework, it is even more complex to make any kind of stable scenario that can make you think, okay, what is the expectation? What is, in the end, is about predicting what is going to happen. And it's so hard that I would probably not bet too much of my money on that.
Thanks, Matteo. Sujiva?
Well, I would invest 50% of the capital on my own money to do a direct recycling business using 100% manual labor. If I have a technology partner to invest and guide on the rest of the 50%.
There's electrochemistry, right? We want to electrify our society, our industry, use electrons for everything. It's highly adaptable. We can modularize it very easily. I think Ilya would probably agree with this, right? It's easily adaptable. Electrochemistry is the key to electrification. Period.
So yeah, as a market analyst, we're not allowed to recommend specific companies, but
personal, private.
Just to say that the long-term fundamentals for demand for the underlying battery metals, lithium, cobalt, nickel, are really strong, based on our colleagues' forecasts. So I'd say there is room for optimism there, without talking about specific companies.
I think I can speak a bit more freely here, but as Cameron said, like right technology, right? I mean, electrification, that just linked as well to demand side. And well, I think being in a market where we are right now is you have to look at the other side, right? And it gives you a lot of clarity on what works, what doesn't work. But if you invest now, is the P&L impact you're gonna feel it if you do things right in 2-3 years. And so that's actually the whole, I understand that 2 years ago, people were maybe in a room a bit more optimistic, but that's exactly the chance you have right now and the opportunity. And with AI, you see critical minerals, they go where they go. And I think it's totally normal. You have some cycles, you have supply demand dynamics. And it's not only, you know, I mean, of course, it's EV here and recycling, but there's so many more applications that you have so many upsides that, yeah, totally, totally actually bullish, because if you invest now, you just want to make sure you benefit then, you know, when the market flips again, the other side.
Last but not least, the only thing we are sure is that we have no visibility. This is our only certitude. We have no visibility. So privately, I would say I'm investing in Rockwell Automation shares because we have developments of platform and solution that are broadly used by multiple industries. And for recyclers as well, it can be beneficial because they do not get things that are out of the blue. You know, it's really proven technology. So that can solve a lot of the problems that I've been hearing since yesterday, including AI, of course, as I said.
Thank you very much. We are perfectly in time before lunchtime. Thanks for joining me on stage. It was a pleasure. And I hope we could, or the panelists could give you some insights and some impressions for talks in the breaks we have, or for collaboration and networking. Thanks.
And just like yesterday, lunch will be across the hall.
top one does a laser pointer. That one, yep, and then the middle one will do the.
Oh, but it doesn't work?
Should work. It's a weird one.
Oh.
So it'll be on all the screens.
Yeah.
All right, you can raise point here. Goes to all screens.
Yeah.
I'll go forward. And
Perfect.
we're gonna walk around fine. There's a
Yeah.
camera recording everything, so just stay on the stage.
Yep, sure. What about the chairs? Should we just do it?
Ignore them. There's a panel.
Yeah.
Later on, so just be careful.
Yeah, all right.
Good afternoon, everyone. We're going to go ahead and get started with the next session. On stage with me, we have Hendrik Spatier from 2Zero. He's the business developer in charge of really growth strategies. It comes from a background of optimization.
Yeah.
Growth strategy and optimization, which is a key aspect of this whole business.
Definitely.
And he's going to talk to us about the lithium gap, specifically lithium products. So the floor is yours.
Thank you. Yeah, first of all, welcome also from my side, Hendrik from 2Zero. Actually, we really want to bring lithium ion battery waste to zero, especially here in Europe. And yeah, today, let me talk with you about what does it need to really close this lithium gap here in Europe. So, and to start with it, actually, I first want to take a look at the recent development. What we have seen in the European market so far is that we experience a lot of turbulences here in Europe, but besides from this, on a global scale, electrification continues at full speed. And as you can see here, according to McKinsey's latest studies, I'm pretty sure everybody of you is super familiar with it already, as we mentioned it a lot. The lithium demand, especially for battery application, remains remarkably strong and almost accounts for 95% of the whole lithium market out there. So as a result, what we see so far, that the global lithium supply is expected to triple, reaching over 3 million tons by 2030. However, what I also want to mention here, even if we consider all potential lithium supply sources, which we now have in the market there, the demand supply gap remains substantial and really challenging to bridge in the future. Okay, in the light of this, especially when we focus on Europe, we see it will face really critical challenges as a net importer of lithium, with roughly 81% of raw lithium and 100% of processed lithium imported to Europe outside from the continent. And a recent fast market study also highlights that we will probably face a projected shortfall of 245 kilotons of lithium carbonate equivalents by 2030, even when factoring all the announced mining projects. So this will also mean still there's super high uncertainties if these will actually take part in the end, but even if we consider all of them in, there will be this huge shortfall. This equivalent, to kind of compare it a little better, I would say, is almost 60% of the entire EU demand by 2030 so far, and would almost sum up to 2.45 billion euros in market value, even if we just take into account the pessimistic price forecasts for lithium at the moment. So therefore, even if Europe develops all its planned refinery projects using this kind of raw lithium input, a 7,000 ton gap remains with still super huge uncertainties ahead. More concerningly, and this is really a thing what I want to state here now, the demand projection focus solely on the market for the electric vehicles and does not even take into account for other industrial application, which still way before the EV popped up, used lithium carbonates in their production as a super necessary product. So, but what can we actually do? What did the EU did to mitigate the risks? As we already talked about it in the last days a couple of times, the European Union has taken decisive regulatory actions, and under the so-called EU Critical Raw Materials Act, lithium has been designated as a critical mineral, which also super ambitious benchmarks. So at least 25% of all lithium must be resourced from recycling sources. Furthermore, the EU battery regulations mandate an 80% lithium recovery rate by 2031, with at least 6% of lithium in new cell production originating from recycled sources. So these measures actually highlight the urgency of building a sustainable and independent lithium supply chain here in Europe. But what is the current status actually? Currently, we see that most battery recycling in Europe only progresses to the black mass stage, what we already heard here, which is then exported overseas, most of the time to China or so, for further refining. And all the recent announced or operating local refining capacities remain therefore extremely limited and are sometimes just still in early development phases. And also, the recent market conditions also have even caused more setbacks in refining facility investments here in Europe, so on a local base. But if Europe really aims to secure resource independency, it must move beyond merely producing the black mass. It must really establish a full-scale lithium refining ecosystem with all the capabilities within European borders. And this is actually where we as ToZero comes into place. We position ourselves as a specialized lithium recycler in the battery value chain. We are probably merely one single step in it, but we firmly believe that collaboration across every step of the whole value chain will be essential to overcome Europe's lithium supply challenges. However, also the reality is that Europe is not yet prepared to establish this kind of holistic, full, complete local supply chain for battery materials and cell production, especially following the recent delays and cancellation of key projects, also gigafactories or so across the whole continent. And in addition, while reintegrating recycled materials into batteries remains the priority, as it accounts for roughly 95% of our market, we must also acknowledge that lithium carbonate was widely used in multiple industries long before the rise of the electric vehicles. So, for an example, in ceramics industry, lithium carbonate acts as a flux, lowering the melting temperature, glaces to enhance the gloss, transparency, and the smoothness. Additionally, the lithium carbonate creates vibrant colors that no other material can actually replicate. So it's really an indispensable product for high quality ceramics production. But not only the ceramics, it's also super essential in building materials. Lithium carbonate plays here a crucial role in cement and concrete applications. It, for an example, controls the setting time, it mitigates alkali-silicate reactions, and also enhances the durability of the cements or the concrete. But what we also see is that it's quite important in lubricants. The lubricant industry uses lithium carbonate as a key precursor in the production of lithium-based greases, with exhibit great thermal stability, also water resistance, and also high load bearing capacities. And the last industry which I want to mention today is actually the glass production. Here, lithium carbonate lowers, for example, melting points, viscosity, thereby reducing energy consumption, improving the workability with this glass. Furthermore, it also enhances durability, controls thermal expansions, and increases transparency. So therefore, it's kind of essential for specialty classes, like what I already mentioned, ceramics, optics, or also other high strength industry classes. But if we go back to the market, actually, we recently saw that due to the overcapacity, lithium prices have stabilized at a rather more low level, leading to a wave of production halts worldwide at all the mining, at all the lithium mines. So while the 2022 lithium price surge was definitely, and I think that actually everybody confirm on it, was beneficial for the whole lithium industry, it was at the same time a major challenge for other industries which were also dependent on lithium. During this peak, actually, roughly 95 to almost 100% of all the lithium just went directly to the battery production or the EV market. And therefore, it turned out that small and medium-sized enterprises really suffered a lot, and they had to watch out for alternative suppliers or substitutional materials to really compensate this kind of lithium carbonate, like in their supply chain. So once again, this is actually one major application point where recycled lithium comes into play, as it presents itself as a crucial alternative supply for these, at the moment, underrepresented industries. At TruZero, we therefore strongly believe that before closing actually the loop for lithium here in Europe, we must first close the supply gap for lithium. And by ensuring that the industries beyond the EVs have also access to lithium, we can support the continuing growth and also do it in a more sustainable manner, as it's right now. So this actually brings me a bit more to our company level, I would say. Here you can see one of our major achievements. Last year in April, we actually reached a major milestone by completing our first ever commercial delivery of recycled lithium in Europe. Our customer, as you see at the blog, what they manufactured afterwards, successfully utilized our lithium to create stunning colors. So it's really a demonstrating thing for our potential of recycled lithium also in these industries beyond the EVs or only the battery production. And actually, after we achieved this goal, our next goal is to establish our first of a kind, also so-called folk recycling facility by the end of this year, with a processing capacity all the way up to 2,000 tons of black mass per year. By around 23, we even have more ambitious goals. We aim to scale our global battery recycling operations to produce around 4,800 metric tons of recycled lithium carbonate equivalents on an annual base with a stable recovery rate of above 80%. And yeah, one last note before I will end my presentation here. I'm pretty sure, or more of, or at least the majority of you have already heard via LinkedIn or some other things, our last huge release. We actually managed to recover graphite on an industrial scale, and this was even successfully tested for the first time in a battery test. So I would say stay tuned also for graphite, and let's see where it takes us. And yeah, thanks a lot.
Thank you, Hendrik. We have time for questions. And I'll start it. So you're pulling out the lithium kind of selectively at the first step. What happens to the rest of the black mass?
So is this also working? Hello? Okay, no worries. So yeah, at the moment, actually, we take out the lithium. Also, as we just recently announced that we also now take care of the graphite. Well, it depends. We are not sure how we want to do it. First the graphite, then the lithium. Well, let's see what will be more efficient in the future. But so far, we take the lithium out, we take the graphite out, and then return this kind of more filtered, more refined black mass to our other partners. Because as what we see so far is, for us as TruZero, it's at the moment doesn't make sense to also focus on nickel and cobalt or so, especially on the stage, as a pyrolysis method and so are super well developed so far. And at the same time, we would also compete with a lot of more other competitors in this kind of very well established market.
Do we have any other questions? Go on over here. And please state your name and your company.
Hi, this is Jessie from Promotion. Sorry. And as a TruZero, we know that it's still at a relatively startup status at the moment, and it's based in Germany. And I'm curious, like from that very small scale, and now you are growing, and then is any challenges in terms of the getting permission and then or funding from German government?
I would say, let me answer it in two parts. I would say when it comes to the funding or so, at the moment, what we experience, we just had our huge seed round end of last year. This was way oversubscribed. So therefore, I would say we are not currently suffering in terms of funding, but especially when it comes to all the regulatories, also for our operations. Also, what we see here in Germany is that also this is even for us as a early stage startup, which should be actually more or less one of the agilest players in the market. It's really challenging sometimes to navigate through all these processes.
Thank you.
Any more questions? Okay, let's please thank our speaker again.
Thank you.
And up next, we have Hugo Cavalcante. We got harder ones. That's pretty up there. So he comes to us from DHL, where he is the Innovation and Product Development Director. Spent over 15 years at DHL, operating over a variety of roles, and now is focused on the EV battery market. And he's going to talk to us today about logistics within the battery recycling sector.
Perfect. Hello? Hello? Yes? Okay, good. Good afternoon. So, yes, I'm here to talk to you about logistics, of course, coming from DHL, and especially about how we believe that collaboration between different players in the industry, and especially logistics providers, but also OEMs, also the recyclers, how we believe that collaboration can lead to a more efficient and very important, compliant, also safe and compliant logistics for EV batteries in Europe. So what I'm going to cover today is, first, I want to give you just a quick intro to DHL EV logistics. I think people tend to associate DHL with small parcels, e-commerce, things like that. But we are also very active in B2B and in automotive industry for many years. And together with our customers from the automotive industry, we've been going into this transition caused by electrification, where batteries, of course, are the main game changer. Right? Then after the quick intro, I want to share a bit of the key challenges that we have identified so far when it comes more specifically to EV battery recycling logistics. And then finally, not to talk only about challenges, but also bring some solutions. I'll propose some solutions to those challenges that I will share here. And I'll be very happy to also hear from you afterwards if you have other challenges or other solutions for those problems. But let me start first with a quick intro to DHL EV logistics. We have been developing logistics capabilities for the EV sector across the full value chain, as you can see in the picture, starting from inbound to manufacturing, then going into manufacturing logistics, then aftermarket and circularity, which is our focus here today, but also going into charging infrastructure as well. We have gathered quite some credentials in the EV sector. For example, we are the official and founding logistics partner for Formula E. We have quite some certifications as well, some awards in the sector. And we have existing business with different OEMs in different parts of the globe, both transporting, but also storing batteries. And those can be new batteries, can be defective batteries, and also waste batteries, which is our focus today. All right, so let me now go more specific into EV battery recycling. It's been, I think, around 4 years that we are more actively working in this industry, and it's been a learning journey as well for us. A lot of discussions with different OEMs, with recyclers, with repair companies as well. And conscious of time, I have selected just 3 main challenges to discuss with you today. And then we can look into the proposed solutions. But these are the challenges. So First of all, one that I think has been mentioned here and there is the fact that the demand is low. We are in a period of deceleration, let's put it this way, for the EV market as a whole, and that has an impact as well on the recycling. But also in general, the number of batteries being produced, and especially the number of batteries reaching end of life today, is of course still very low compared to what it can be in the future. So the challenge here is how to deal with this big variation in volume, in demand, and build a solution that is both efficient enough to deal with the limited number of batteries today that need to be recycled, but also be prepared for when the demand grows, and it's expected to grow exponentially, as we all know. The second one is that not only the volume is going to change dramatically, but also the profile and where this battery is coming from. Again, something that has been mentioned already, the transition from production scrap to end-of-life batteries, which has a huge implication for logistics. And then finally, the regulation. And I was just talking over lunch. It's maybe to this audience, it's more or less clear what the regulation is, but we see in discussions with OEMs, there's still a lot of doubts. There are a lot of uncertainties, sometimes leading to creative solutions, which can be a good thing. I'm all pro innovation and creativity, but there is a risk of safety and compliance, and that's something that cannot be compromised. So I'm just going to go now through through each of those, and then bring already some proposed solutions. The first one, the demand. Right? So how to cope with this variation? We all know the situation today, and we all know that it's expected to change a lot in the coming years. And I believe there are two main things that we need to take into account. The first one is not approach battery recycling as something completely isolated, and that's a message mainly to OEMs. We see still a very silo-based thinking and organization, and you have people in OEMs that are completely dedicated to what we call the spares flow, so the aftermarket flow, the storage and distribution of new batteries. And then you have a different team, different part of the organization looking at the batteries that need to be collected and repaired. And you have a third group of people that are looking at the batteries that need to be recycled. And of course, there are differences between those three flows, and that's why specialization is important. I get that. But there are also a lot of synergies that today are not being fully utilized, especially when it comes to logistics. Keeping it in very practical terms, you can use the same logistics network or part of it. You can use some of the same resources or some of the same digital solutions to manage all those different flows. And by doing that, you have an organization that is robust enough and is strong enough to manage where the volume is today, which is more on the spare part, the aftermarket, and the repair, but also start getting prepared for the recycling volume that is to come. And the other thing is flexibility and agility. Right? If there is no need for a regional solution, then why not start local? If it can be managed in a more or less manual way, that can be a starting point before going digital. And we can also start with more ad hoc processes before going into a fully standardized, well-oiled machine. But the message I want to bring here is not that, do things manually and do it ad hoc. It's more the opposite. You can start like that, but you need to have the end goal in mind. because if you don't, then things can quickly run out of control. You lose visibility, and then again, you can have quite some risks in terms of safety and compliance. Going into the second challenge, that's the transition from production scrap to end of life. We have already seen similar graphs to this one today. I think we're all familiar with this. Also the inflection point, which might be pushed a bit forward. Let's see. But most people believe around 2030, that's when we'll see the volume of end-of-life batteries increase higher than the number of production scrap batteries. And as I said, this has a huge implication for logistics because it's way simpler to have a daily collection at a production plant or a weekly collection at a production plant and bring those batteries to a recycler. Then when we reach the end of life volume where we're going to have batteries coming from literally thousands of locations, from dealerships, from workshops, from all sorts of different locations all over Europe, coordinating those collections and bringing them to the recyclers in an efficient way is a massive challenge. And it's a challenge that we are already facing today and then finding solutions for it today. And it will become even more important in 5 years from now. And what is the proposed solution for this one? Well, that's where collaboration comes in. So we've been building a network of partners, specialized providers in different European countries, and putting together all these different capabilities and all these different strengths into a European comprehensive network, right? So you have the first step, the LTL collections, LTL less than truckload. Then those batteries come to a consolidation point. Of course, consolidation point following all the regulation in terms of safety, with specialized storage for waste batteries. And then from those consolidation points, we bring the batteries to the recycling facilities, wherever they are located. And this type of network, it can be scaled and it can be adapted, right? So the exercise that we often do with OEMs is to identify where they expect those batteries to come from, when also, and then start building a starting point, a starting network that will then evolve over the years with more collection points, more consolidation points, up to the point where we might have a milk run, for example, running from one dealership or one workshop to another, but we're not there yet. So it's all about sizing and adapting the solution for the demand that is there today, but then also thinking of how can we scale and support the industry need in the coming years. And finally, the regulation. And here, I'm not going to go into detail. I think there were sessions already about that. But most of the discussions we have are, first of all, about when can we classify a battery as a product, or when can it be classified as waste. That's the first distinction that has a big impact on logistics. And then the second one is, if it's waste, what is the condition of that waste battery? Is it undamaged? Is it damaged but not critical? Or is it critically damaged? And then finally, where is this battery going? Is it going to cross borders, or is it going to stay in the same country? And then I think many of you are familiar with the regulations there. If it's crossing border, then you need to go into a notification process. And that's also where that logistics network that I was talking about facilitates this movement. But we do see still a lot of questions, a lot of doubts about those items. And I think the solution there is threefold. I think first of all, we need to combine knowledge with experience. It's one thing to know what is written in the regulation, and it's another thing to see what is happening in reality and learning from the facts. The second thing is safety first. So as I said, I'm all pro innovation. I have innovation in my job title, but we cannot compromise on safety. We cannot compromise on compliance. And at the end of the day, it's about the environment. It's about people's lives. It's about the reputation of our organizations as well. So that's one item that in DHL we take quite a strong stand. And that's not something we can compromise on. And finally, collaboration. I think understanding the regulations and understanding also where the gray areas are should not be treated as a competitive advantage or as something that we want to hide. I think we need to be open and transparent in the market, in the industry, and talk to one another and exchange this information, because the more clear the processes are and the safer it is, the best for everybody. Finally, I just wanted to share a bit about our approach to EV battery circularity. So we have solutions for what we call the spares segment, so storage and distribution of new batteries. We also have solutions for the collection of batteries that need to be repaired or need to be recycled. And that's European. Everything there is covering the whole Europe. Some of it globally, but my focus today is Europe. And then finally, to coordinate all those movements, we have our command center. So that's a group of specialized people that understand the regulation, understand the processes, and they are there to both managing the day-to-day. So for example, providing support in different languages so that dealerships can call them, they can help to schedule the pickup of a battery. But they also not only manage the day-to-day, they also improve the process and they improve the network. So as I said, this is a business that is evolving, that is changing, and the network needs to evolve together with the business. And finally, the digital part, it's only going to become more and more critical in the coming years. Visibility control is extremely important, especially when you're talking about hazardous goods and hazardous waste. So having a system that can connect all the dots and can provide visibility to all the parties involved is very critical. That's it. So you can find me on LinkedIn. You have my email there. I'm very happy to continue the discussion after that. And I wanted to also invite you. We have a EVTV series on YouTube. So if you're interested in some content EV related, it can be also a bit entertaining. Thank you.
May please state your name and your company.
Yes, Dominic Scheider, Rockwell Automation. I see in your presentation that the EV command center is mainly human-based. It's not AI-driven. I guess your vans, your trucks are also localized, geolocalized. So you consider that AI will also bring some value in the smart move for all this agile ecosystem?
Yes, I think we do have technologies and AI-based technologies that can be already used today. For example, simple things like helping with translation, right? As I mentioned, the command center support different languages, but if you have very low number of batteries to be picked up in, I don't want to mention a specific country, but whatever country out there, then you might not have someone that can speak that language. It doesn't make sense to hire someone just to support that one language. And that's something AI, for example, can support. But I think in the coming years, there will be more and more opportunities for automation. We have AI technology for example, taking pictures of an item that's more in the technology industry, and then based on that picture, already get a first assessment of the condition of that item. I don't think we are there yet with EV batteries, but that's something that could be supported in the future.
When you transport electric vehicles, there's no surcharge or additional classification as dangerous cargo or whatever. But when you transport the batteries, you double the cost saying dangerous cargo. Why this discrimination?
Yeah, that's a regulation question indeed. And we have seen cases of OEMs moving a whole car not to go to the trouble of moving an individual battery. But that's not a sustainable solution, I think, moving forward. If the battery is classified as waste, it's hazardous waste, and that comes with specific regulation, which is there for a reason, right? And that reason is safety and compliance. So we need to follow that.
But the BSL convention has not classified EV batteries as hazardous waste.
Well, but it's still SDG and it's waste, and then you need to have, for example, a driver that is trained, and you need to have a carrier that is that has the permit to transport that waste. So all of that is part of the regulation, and that comes with a cost.
But that regulation or classification should not come from the carrier, I believe. I mean, it should come from the body in classifying whether it's hazardous or not.
Yes, definitely. So the logistics provider is only following the rules, right? Not determining the rules.
May I know whose rule is that? Because from the global on cross-border transportation, who is responsible for EV battery cross-border transportation is BSL convention and their guidance. But nowhere in their guidance it says EV batteries as classified as hazardous waste.
Well, you have both global but also European regulation, right? And there are restrictions for cross-border movements, for example, as we were discussing before. So yeah, but we can go through it later on.
We're gonna have Julianne chime in.
Thank you. Julianne, everybody knows by now, hopefully in the room, that I'm from the European Battery Recycling Association. So to answer that question, to help you, is that there are two different classifications. So lithium batteries are classed as dangerous waste. Today, as we stand, they're not hazardous waste, but they will be very shortly. But the Basel Convention and also the Dangerous Carriage of Goods Acts, of which is international, so you have by road, by marine method shipping, and by rail and by air, classifies lithium batteries as dangerous. So that's why, for example, you're not allowed to take your laptop and put it in a bag in the hold anymore on an aeroplane, or ship batteries by aeroplane. So DHL, exactly what you've just said, Hugo, that you're doing the right thing at the moment because you're classifying them as dangerous goods, which means that you need a correctly qualified driver. There is a website, Ibra was one of the founder members, and it's www.batteriestransport.org. And you can log on to that. You can look at an online up-to-date legal text in, I think, at least English and Spanish. There are plans for other ones, which sets out all of the ADR and marine rules. So it gives you the packaging requirements and the rules for different things. So it's www.batteriestransport.org, which I think you'll find very useful. But very shortly, I think this week, the European Commission are going to reclassify batteries, lithium batteries, and all battery chemistries as hazardous. That'll take 18 months then to be implemented, in which case it creates a whole lot more of different documents and requirements. But at the moment, they're dangerous, which they are, but they're not hazardous, which in my opinion they always were, but never mind. But they are going to be classified as both in the next 2 years as a minimum. Hope that helps. But I would recommend you look at that. You can, it's a flick book, and if you turn the sound off, you don't get the annoying page turn things. But it's there. As Zebra members, you can download it. Just saying.
Thank you.
If we have one more quick question, we can fit that in.
Thanks. I'm Viti Anik from Coventry University. So you mentioned a lot about learning, and it's all hazardous, and now we've heard it's going to be even worse. How big is the challenge in terms of the whole workforce to train them, to gain the skills to handle the hazardous chemicals? Because I guess 20 years ago we would not be thinking about that, and it would be just purely logistics. Now you have to deal with chemicals, high voltage, hazardous voltage, all sorts of other things. So how big is that challenge for you as a supplier in terms of skilling people? Thank you.
Yeah, that is quite a challenge. But I think that's also the advantage that a logistics provider can bring to the industry by, to a certain extent, also concentrating that knowledge, right, within different providers, of course. But that can simplify things for the OEMs, for example, or for the recyclers, right? So as long as there are providers out there that are doing those services, and they are doing that in a compliant way, and following the regulations, and supporting the OEM, supporting the recyclers to understand the rules. I think that helps to bring also a level of certainty. And also that's something, as I mentioned, we're working with a network of partners as well, of local providers. And that's something that we both ask them to comply with, but also help them to comply. Because in some cases we see the provider is almost there, but they have a specific certification, for example, missing. And then we can help them to achieve and to acquire that certification so that we can work together.
Thank you, Hugo. Yeah, transportation of these dangerous goods and haz waste is no joke. So last year, the new TSMC plant being built in Arizona had 2 explosions from transporting hazardous waste incorrectly, and one resulted in the death. So taking safety seriously is much appreciated. So next up, we have Dominic Scheider from Rockwell Automation, where he serves as the industry market manager in transportation, and another expert with over 3 decades of experience in the automotive industry. I think really your roles over the years that have been quite vast, but now focused on developing executive level partnerships and kind of cross-market collaborations. And so let's hear about automation in the recycling sector.
Hi, everyone. Thank you, Lead Event, for having me today. So let's go deeper into the dark side of the industry. And when we talk about graphite, it's all about dark. So we are already touching here, as you said, strong partnerships. And as I was talking during the panel this morning, it's about also data-driven. It's not just automation, it's also digitalization. I have no slides on Rockwell Automation, but we are a global company, very well known for the PLCs and the brands of Allen Bradley since more than a century, and we are in every industries globally, serving 80 countries. So some of you might be very familiar with what I will present. Some of you will say, I've never heard that. It's not something that even I can understand. So let's see where we are in this, with an agenda which is about, as I said this morning, thinking TCO, not just CapEx equipment, but total cost of ownership, and how can we apply best practice that we have applied for different industries in the past. We talk about some partnerships and what we do with Circular, and that's quite interesting, or what we do ourselves with Calypso entity for an efficient recycling end-to-end, and some references, of course. How do we succeed in the recycling launch of a lower cost TCO? I mean, it's if I want to set the scene, I will start with this slide just to explain a little bit what is discrete and versus process automation. Discrete is everything that you have when you build an automotive, for example. It's a sequential of actions and events, things you can count on a belt, on a conveyor. You have robotics. So this is something that you can stop easily without any too much consequences. Versus the process automation, which is a continuous process typically, where you cannot really afford to stop the production because it will be having a consequence on the batch. It's about valves, tubes, mixings. And in this case, it's better to never stop the process. If it's about liquid metals, you don't want the line to be stopped, right? So typically, you have different type of programming and automation to serve the discrete or the process automation. And you have as well in the middle, the food and bev, life science, which is perfectly hybrid. If you produce a yogurt, you have the big tanks and batch to produce from the milk, and then you will put that in a packaging, in a pallet, so it become discrete. So that's just to set the scene. And when we talk about automation, especially on machines, you have, just to a little bit explain, a brain, a PLC, which is the brain of the machine, which is controlling and connected to all the electronic assets, the sensors, the screens on the machines, the motion control, the gantries, and everything like that. So this is what we have done for the last 20, 30 years. It was quite basics architectures to drive machines. But more and more on top of that is coming a different set of connections need to be established with manufacturing execution systems to smart networks, VLANs on top of the machines to build this as a line or as a plant. And on top of the top will come Internet of Things platform. As I said this morning, if you want to get access to your data, you need to structure that in platforms that are IoT platforms. And even on top of that, a more distributed visualization. When you see these operators, maintenance, they don't like to be just in front of the machine. They want to get the insights where they are. Or even if they have no machines at all, if you talk about a manual dismantling of battery pack, maybe you want the augmented reality that we do with Vuforia Scholg to be guiding the operator paperless according to the safety rules, to the conditions of the batteries. So with or without a machine, there is multiple things that are changing now in the architecture of machines in a discrete environment. And we are here to provide the support to the machine builders, to the solution provider. We are not building machine ourselves. So this is historically from conventional automation to a more smart concept of machines. And as you understand from me now, AI is becoming everywhere at edge level. What does that mean? The drives that are, for example, controlling the motors, they are smart by themselves. They can be predictive on the failures because they know their state of health as well. And they are in independence able to detect further default. So there are AI becoming at every level of these components now. And when you talk about process architecture, it's a bit more distributed. You have thousands of input, output. This is what we have done in mining industry for decades, now coming in the recycling industry, more or less the same. But the way of programming and visualization of the equipment is really different. As I said, we need the networks to be redundant. We have multiple different ways to wire that. But components as such, it's really something which is very similar to the discrete industry for what we propose. So we have sample architectures, but different way of programming the equipments in the process control of the equipment. And out of that, because we talked about cost this morning, we think at the very early stage of the design and build, if you select the right partners, you will get a single architecture of products to serve the discrete and the process industry. And natively, the cost of production of your units will come from the early decision you make in the design and build phase. It's probably too late. If you buy equipment from a supplier ABC without knowing exactly how you will plug in this equipment in the future plant, you might be surprised. Or you might be some challenges that European battery makers have seen themselves. We talked about that since a few days. It might create a big mess at the end if you don't know how to connect the equipment. So the simplification comes from the templates, the libraries of not starting a programming from zero, but we have in our duties to provide templates and libraries. Then cost reduction and optimization for the maintenance. It's about less diversity of components and processors, minimize the warehousing, the stock, and get the maintenance to be more efficient by less diversity of equipment in the plant. Optimization, it's about cybersecurity and many other services that we can provide on the long run, as I said, 15, 20 years. So with that, we secure the milestone of the plant launch, and it starts very early in the design phase. There are milestones here. I know sometimes in the past years, the time to market was so pushy, people just forgot a little bit about some of the duties in the planning and design phase. And again, they paid very high price for the failures in this design phase. So we start to work with our customers in a digital engineering, simulation, and emulation of all the equipment. The later you decide where the plant will be located, the better it is. There are so many geopolitical constraints now that if you can save even 1 year by testing and simulating your equipment in a very advanced way, you save a decision to say where will be located the plant, how I will run it, and I can even train my operators in the digital environment. So this is, I think, the takeaway from this slide. Earlier, you start with the selection of partner, the more chance you have to be efficient and cost-effective at the later stage. So what do we do for that? How do we proceed? I mean, I've been 30 years plus in the automotive and 20 years with Rockwell. I've been always using this template project book that we develop with our customers to not just give a list of equipments. We come, as I said, with templates and architectures to really save time and mitigate the risk for the automation, networks, MES, everything around the new plants. And just to go a little bit even in details, sometimes the part numbers matters. Selecting a PLC A or a PLC B might be a bit surprise. Yeah, it's a safety Rockwell processor, but is it the old version? Is it the new version? All the equipment coming might be not having the same versioning. Then 2 spare parts, one will be obsolete in 5 years, one will be maybe much more longer in life cycle. So there are level of detail to how do we develop these architectures. Same with the Ethernet IP infrastructure. We can go down to the cabinet level. How do we wire the cabinets? Now we have the Ethernet IP in cabinets. So the Internet of Things go very deep to the contactor level. So you can really monitor your equipment to the lowest possible level without too much expensive connectivity cost. So this is just 2 examples to just highlight that the more things are prepared upfront, the more the sourcing purchasing team will be empowered to buy equipment with a certain direction, a certain consistency in the equipment that will come to the plant. Otherwise, it might be very challenging. Or another state of the art, it's about the labeling on the wires. If you hear the story on Northvolt, maybe you have been like me reading that they were not having labeling on the cables. How can you maintain the equipment? How can you operate the line if you do not have the screens in the right language, or the definition of the data is not structured properly? So we go very far in that. As the title of the conference about partnership, we have made acquisitions on the top, but we have also partnerships that we believe are really foundational for our success with our customers. PTC, Microsoft, you see big names here, but you see also Clarity working with us in cybersecurity in Germany, or Circular, and I will come to that in the next slide. Much smaller companies, but very, very specific to the industry that we want to serve. So that's why we announced these global partnerships. But others, as you can see, are making us much broader than what we were a few years ago. So let's talk a bit about Circular. I don't know, maybe some of you know this company already by name, maybe not. They have been in many battery events in the last 5 years, and we just announced the partnership end of last year. And they have developed, and they are active in the European groups for developing of the battery passport. But all the idea is to be, of course, cloud-based and to have a clone of every battery cells that will be set up for the entire life cycle of the batteries till the end of life. So from the mine to the crave, there is really the digital clone of the batteries that will be alive, and that will be maintained over time on the repair and everything happening. But their concept of DPP is one of the different requirement that is coming today. And yesterday we talked about battery, but there are many others that are in force now around automotive. And they have been working on a different use case. Next week will be tire tech. Circular will be with us about the tire industry, which is also EUDR, European Deforestation Regulations, or in the leather with JLR, they have done also DPP projects. So it's not just battery. The demand, and I said that this morning also, is applying to different industries and in the automotive, much broader than the battery itself. So they are really expert on that. They are based in the UK, and we have these partnerships. And you have seen this wheel many times since yesterday. I don't want to spend too much time, but it's not just automotive OEM, it's also BESS. It's all the application of the battery cell that will be entering into this wheel. And I'm convinced that there will be, for sure, value for the recyclers themselves to know better what comes from the collectors or the hubs, the spoke, because in the past project where I talked to the battery recyclers, they were even not informed of what will be the compound of the black mass when I see, without naming the French companies working together, but they were not really having in mind the value to get a bit more specifically what will be the compounds in the black mass that they receive from their partners. So this dynamic of sharing the data end-to-end will be really key in the future. And for that, with their platform Prove, how do we work together? Number one, it's not for our customer that we have, it's Rockwell Automation to take the control on the contract, and we use their platform. So it makes the life easier for our customers. We work with them, and they buy the platform from us, from Circular Platform. We are the connectors. We are able to serve globally the different countries where we implement this platform with connectors to the MES or to the different software on the shop floor. No need to replace the MES or the equipments that are here in terms of software. We will connect the equipment, structure the data, and empower the platform Prove to be delivering this DPP battery passport at cell level, or item level, or batch level, or even at the car level. They showcase the Volvo EX90 now with the battery passport. Of course, they populate the QR code that you have on the car, where you can see as a driver where is the provenance of the battery. So a connection of software, a partnership where the best technology comes from our partner, but we implement that at the multiple level, from the mine, the refining, and the entire stage of the production, not just the recycling. Detailed composition, dismantling, I go a bit faster on that, but definitely there will be, and they are already proving that. And we see some project that we are approaching today on company that were developing their battery passport for a few years, and they just realized that it's not that easy. It's not so easy to implement or to execute globally. So dismantling and safety is one aspect of the battery passport. But as was said in yesterday, safety measures, date in place on the market, all these informations are not available today. And if it's by regulation, it will be implemented for the very first time in this industry. I'm part of a Recharge Association. Maybe some of you know this association in Brussels, which is quite active in the development of these battery regulations. Yeah, definitely, I think, as was said yesterday, this will be replicated in different countries, not just Europe over time. We are one of the first continents to implement that. But this, I'd like to put the perspective of broader than the battery passport. What does mean this digital thread, and how can this bring value for our customers that are developing innovations and new products? Because when we see today where we are in the battery recycling, I mean, we are mainly number one in very manual operations. So there is no data if it's manual. But if there are some automation, it's really silos of automation. The data are not well structured, are not well ready in application that are easy to replicate or to productize. Because if you develop in a lab, of course, you want the developments to be reused in the pilot line or in the mass scale production. So for that, you need, again, to anticipate the way you structure your data and to be ready to scale up from the day one. And that's what we try to deliver to battery recyclers. It's a planning of the applications to be future-proof, if we can say like that. So they are scalable enough, and we can grow up the business, and the structure of data is already well prepared from the development phase. And the idea is to go from any industry, not just battery recycling, from data silos and descriptive analytics to go more and more to a certain level of connectivity. Connectivity, as I said, Ethernet IP, networks, but with that, we can have a first level of diagnostic analytics, and we go up and up to the predictive modeling when you reach a certain level of connectivity to the different machines. From predictive, where you advise the operators on where should be attention for the maintenance, you can really more be prescriptive to the operators on what they should go and do, to the next level, which is autonomous control. Autonomous, I've seen that in a FANUC plant in Japan. You know, you switch off the light in the evening, and in the morning you get all the parts or all produced. So it's not just a dream. It's more and more with the support of AI and with support of very advanced connectivity, something that we will see coming very fast. But for that, you need to access a certain level of automation for sure. And let's see from the discovery and the creation phase to the make and sell. If you consider that this is a battery pack, an OEM developing a new battery pack, is discovering new materials, he create, and you agree with me that all the creation is with CAD and a digital environment for development before they make anything and they sell this battery pack to the market. And you agree with me that the cost performance and the viability of the recycling business will start in this discovery phase. If the eco-design of the battery pack is well from the day one create in a way to be recycled, the performance of operators to dismantle this pack will be much easier, as was discussed already. So there is an entire chain here from end to end to go very far in the simulation. A couple of more slides. Some of the technology stack, I will not go line by line. Some PLM, MES, ERP are very well established and mature in companies, but all the others are in emerging stage or in just emerging implementation at scale, mass scale. Great references. Sungil High-Tech out of Korea. I've been working with us for the discrete and the process side. They were really having a support of system integrators, and being a global company, of course, design can be made in Korea, but the support in US or in Europe will be the same experience for our customers. So we work always, as I said, system integrators, the end user, and the technology provider that we are. So final success depend on the connection that we create here. References and circular. And my last slide here. I mean, if we want really to create these new insights, we need really to anticipate that far before the equipments come to the plants. That's the number one takeaway. Make an impact. It's mainly for it's not that we want to eliminate any humans on the plants. That's not the idea, but we want to empower the humans, make sure they work in a safe environment, and really make an impact also for the operators. And innovation, everything I'm reading about battery recycling is that innovation is a game changer, and many things will come even more in the next years. So we are here to facilitate that. Thank you for your attention.
You, Dominic? Do we have any questions from the audience?
Thank you. Ümit Batmaz from Dacia. You know, in automotive, we have two kinds, in fact, generally in the industry, we have two kinds of deployment. First, standardization. Second, you know, everyone makes whatever they want, and then we try to catch up. Standardization for the batteries that we use in toys and everything, small batteries. So it's a standard Varta and I don't know Duracell. Everybody makes the same thing. But if we go to automotive, here for even for the diagnostic tools, each constructor has different diagnostic tools. But also we have Bosch, who is able to connect to every car and make the diagnostic of every car. And I think that in the future, I don't know what will happen. Maybe the automotive industry will go towards the standardization of the batteries like Varta and Duracell, or maybe we'll do like diagnostic side and everybody make its battery separately. So coming back to the dismantling, it will be a mess, So for the recyclers, there will be one battery for BMW, one battery for BYD, one battery for Renault, etc., etc. So what we can imagine is to have one box you presented at the beginning, in which we will put the battery, and with the help of machine learning, AI, etc., all your skills, you are able to give us dismantled battery components. So you think that will be possible in your area?
That's a good question, and indeed, this is the holy grail to do an automatic dismantling of any type of battery pack. I saw from Fraunhofer or in Germany engineers that are developing super smart robotic cells, or we saw Liebert also earlier today from Tessa video, where you have very advanced robotics with different toolings, different guns going screw by screw and so on. And I mean, this is probably not the case that in the future, this type of very advanced tooling, I think KUKA is doing a different story. They have much more brutal way to open the battery pack and no need maybe to unscrew, because we will never rebuild the battery. If it's for repair, okay, but if it's for recycling and dismantling for destroy, you can go totally different practice. And for that, yes, I think we can rethink to be a bit less precise and accurate, but to have a rational way to approach a new battery with vision and AI, again, to program the robot to be able to open the cover and find different patterns. I'm very convinced that we will be surprised on how smart robot will be. Not just, we have seen vision system with robotics, but vision system plus robots plus AI, we will be very surprised. Look at, again, the Gen AI, how you have the conversational way to interact. We will be quite surprised to see how robotics application will be transformed by AI. Yeah. I don't know if it's right response for you.
All right, we have time for one more question, if it's a brief one. All right, let's thank our speaker again.
Thank you very much.
And have our wonderful moderator back on stage and can lead the next panel.
Thanks for this ruling. Before we start with the discussion in the panel, there's a small change in the setup. If you count, it's 5 people, not 4. So Vincent is joining, different to the agenda. And would you please introduce yourself, as you didn't have the chance to speak yesterday or to be part of any other?
Yeah, thanks a lot, and thanks for having me last minute on this panel. So quick presentation just to explain the perspective or the point of view I can give, I can provide hopefully during this panel session. So my name is Vincent Rofast in French. I'm the head of advisory for OCO Global. OCO Global is a company which is really specializing in international location strategies. So it means that we help our clients find the best, especially manufacturing clients, find the best industrial sites in the best local ecosystem. And we operate on 4 main markets. So Europe, because we are European by DNA, North America, the Middle East, and also China. So yeah, that's it in a nutshell, I guess, for me.
Okay, thanks, Vincent. So what can you hopefully expect in the next 40 minutes? Yesterday, we had the focus on LFP chemistry. Before lunch, we had the focus on profitability, even if most of the panelists didn't want to invest. I don't know why. So now having in focus sustainable business. So not just stepping in and being bankrupt after a short time, sustainable business with the focus on Europe. So no Asia, no US, maybe due to some concerns, focus Europe. As you have experienced, first round, short statement by everyone, please, what he wants to give the audience to remember. Who wants to start?
I can start. So actually, when it comes to local sustainable business, this is really where we at 2Zero actually at the moment focus at, because what we have seen here, as I already mentioned in my speech, everybody just focuses on the EVs and the batteries and so. But what we see actually in the European market as well is that there are also a lot of other local industries which are really suffering due to their, I would say, prioritization of all their current recycling focus into the battery sector. And therefore, we actually want also to represent the industries, as I said, like building materials, also ceramics, lubricants in Europe, and also want to target them. So therefore, I would say before we take a look at the US, China, or global markets or so, we should also first probably analyze our markets a bit more in depth. So yeah.
Thanks, Hendrik. From the other side of the supply chain, Julianne.
I think everybody knows who I am now. I think that local describes Europe.
I'm not sure whether the micro is on.
I think it works. Does it work? You can hear me? But I think the word local actually does describe Europe very well, because it's a very global market and you can buy cars anywhere in the world now. I've been in one of those Google driverless cars. We were talking about AI and robots. Scariest thing I think I've ever done. So I think we need to be mindful of that. But I think that in terms of Europe, we need to re-establish the manufacturing base and the use base and the knowledge that actually Europeans could do a lot for themselves very well without having to rely on countries outside. And I think that's where the gap really needs to be addressed.
Okay, thank you. Next, Vincent, as you said in the introduction, you have a European DNA before we have the outside view.
Yes, so and following up on following on what you just said, I think establishing the right practical conditions for businesses to establish and thrive in Europe in their local ecosystem is really the key here, because it's very easy to find sometimes great demand on some markets, great industrial sites, but you're far from being done when you have that. Actually, when you want to be really succeeding on the market in a sustainable way, you need to make sure that you find the right long-term trade-off between a whole number of quite complex location parameters, approximately 200, with a mix of cost, operations, and risk, and it's a fine balance to strike. So it's not easy. So building the right operating conditions is probably one of the keys for success for sustainable business in Europe.
Thank you. So Yeva, you're from Sri Lanka. What is your statement if you hear that focusing on Europe from an outside view?
Yeah, it's actually Europe can set up a great example to the whole world whilst having all this regulation and also getting initiated and formulated here itself in most of the cases, and from the convention to the regulations. But I think when it comes to the business of recycling, we always think of the scale. Even Europe can think without the word scale, and to find out ways to build the smaller as much as possible, because we are talking of localization here, regional here, the smaller countries, even Europe has smaller countries. So smaller recycling facilities where we minimize the battery transportation costs and the risks all over. And then again, we are transporting only the black mass. I mean, the black mass is not the end of the recycling, but then there itself, it's more complex. So small scale, you may not be able to do that. So I think we further fragment it and make the business bringing it to the micro level would help Europe in moving forth.
Okay, thank you. And Jared?
Yeah, I come from China. So in China, we have word called urban mining. So instead of like having like mineral resource, but we actually can find our resource in our cell phones, in our EVs. So that's something we can control and it's just nearby. So instead of like having resource which highly depend like cobalt in DRC, nickel in Indonesia, lithium in Australia or South America, we can actually like localize the resource and secure the supply chain by the very concept called urban mining. And by having this, I think is my understanding to the very essence of sustainability.
Okay. Other way around now, if you would be an European-based company, what would be your advice, or what would you do based on your experience now, and starting with Jared?
So there's a saying like in China, like if I go into the business, doing business in Europe, and from the Chinese perspective, like you can never like, you should like prepare as much as capex or budget as possible, because there are so many like called hidden costs. So for someone who is the outsiders and who are not very familiar with this market, so my understanding is to prepare as much as possible from the capital perspective, from the environment protection perspective, from the very important regulation perspective, to be well prepared. So that's the first thing to do. And also, I think partnership and the whole value chain development is very important. So, well, I will probably to find partners to do things together instead of doing it alone. Take CATL as example. They used to have like 100% like self-owned, like in the Germany, in the Hungary factory. But the recent movements is they are partnering with Stellantis to have some local partners to be aware of the local conditions and to plus what they are really good at, and to create such kind of value chain ecosystem, and to finally to have some win-win situation. Yeah.
Same question to you, Sujeva. What would be your advice?
Well, I would invent the smallest possible and most highly automated plant to recycle batteries for Europe, and it will be all over Europe.
Okay. You've heard now what the advice is from outside. So what's your answer from inside as a partner, starting with Julianne?
I think it's from
I'm not sure whether this microphone is working.
Yeah, possibly. That's I hate these things. Sorry. I think that from a European looking at other countries, that I think that they find it very difficult to understand the mindset, and I would say, you know, we all agree with you. We don't understand how the European Commission works. We don't understand how they come to some of the conclusions that they do. And certainly they don't necessarily have the evidence and data to support it. So from an outsider point of view, I would say you need to be part of the process. You need to be sitting at the table and working with the Commission to say, you know, have you thought of this consequence and that consequence? And the same with the UN as well. You know, I mean, their working groups take forever, but actually they're very global. So you need to be part of the story.
Okay, thanks. Vincent, potentially, if possible, with the focus on the manufacturing equipment suppliers? What could they learn? Because most of the experience and knowledge is currently, as we heard, especially on LFP, not in Europe, it's in China. And we see it on the chip production with Taiwan. Do you have a statement on that?
Well, that's a very tricky one. I think what's happening right now in Europe with manufacturers from Europe, in the battery industry. So there is a need definitely for Europe to be, to develop its industrial base and sovereignty around that. But there is also awareness that it's almost impossible because, because of the technology gap that we have now with China. So I think it's the way forward is, in between developing the industrial base and working collectively, especially with Chinese players. And this is what's already happening. For the rest, I would say that I think electrification in general is, there is no way back, right? So we can see, the market might be slowing down and such, but there won't be any way back, to the former world. Secondly, I think Europe, seeing the, foreign direct investment flows across global regions, Europe has always been and will remain a must market for all of the players. So it's just about creating the right business and investment conditions in Europe. We know it's a very complex market, highly regulated and so on, but I think we're making progress, step by step. And also, let's not forget that Europe is actually a huge variety of different locations, and so there is for sure, some options that fit with all, investors' requirement depending on their project requirements.
Thanks, Vincent. Being sustainable is one key aspect potentially for a startup. So how do you see it, Hendrik?
Yeah, that's definitely a major thing for us. And I would say, as we see it, or actually also as we experienced in the past and will also do in the next couple of years, that this whole ecosystem will not work without the partnering or so. And I think what for sure we can do it from our industrial side on, that we really reach out for partners, make win-win contracts and so working. But I think what's also a big thing to really accelerate these partnerships, to really close this whole recycling ecosystem, the whole recycling loop, is, at least for Europe, super important, that we also require or actually build up a base to really collaborate across borders, at least in Europe. I mean, we hear so many times that we as Europe must stand shoulder to shoulder to really kind of compete with all these huge other industrial nations in the world. But what we actually already experience is, just if you want to partner with, I don't know, a company which is just across the board in France or so not that far away from a geological perspective, but it's a different nation. It already means for us a lot of more hurdles when it comes to bureaucracy and so. And therefore, I would say what's really important for Europe as well is that we also allow these companies, allow the industry to collaborate on a more subnational level, I would say, here in the EU.
Okay, thanks for your statements. Before we have a look now, because you mentioned it and it was mentioned yesterday and today quite often, partnerships, but we also have heard that there won't be any investment. So potentially the government, the state, federal will be one part. Julian, one question: why is it essential or mandatory for Europe to have an in-house recycling from your perspective?
Number one, to do with carbon footprint, so you want to try and treat it as locally as possible. But number two being that there is an enormous amount of employment in Europe headed up with recycling and waste management. And they have lots of skills, lots of knowledge, very technical knowledge on how to disassemble different types of products, e-waste and batteries. So if we just say, right, okay, there's going to be no recycling in Europe, it can all be exported, then Europe loses that goal to be to have environmental sound management. And that's very important. But one of the big problems that Europe has, and actually this might help you to know this, but yesterday in the Green Industrial Deal that was published, there is now a strategic fund for European companies to tap into for critical materials. And that was announced yesterday. So there is this new thing building. So the European Commission recognized that we can't necessarily compete for secondary raw material values on a global market. So they need to fill that gap. But the other thing that certainly IBRA and ERA both call for is we should stop using the word waste. You know, waste is what you put in your garbage can, you know, where it has no use. You can't do anything else and you just have to incinerate it or put it to landfill. All of these products, batteries, electronic waste, cars, and everything else are secondary raw materials. And that's really where the focus should be, because we have the skill knowledge, the availability, and the potential to actually lead the world.
Okay, thank you. Funds, investment money is one key. And usually we in Europe discuss that very critical. And when IRA was published, oh, that's impossible. When we see that most of the companies or some of the companies in China are in public ownership, the question is, if we have that fund, in which role, and that is a question to all of you, in which role should the government or EU act? Should they just provide money without criteria? Should they be partner? Should they be shareholder? So what's your thought on an opinion on that, the role of the government and the money? Please feel free. Who wants to start?
So maybe I kind of doubt that they could be really a shareholder. It wouldn't be, you know, the business, the European business culture. I think it definitely helps, especially in a world where you have China, the US. It started really with the IRA, which was a big bang for Europe, honestly, in terms of attracting foreign investment. It was really hitting hard at the time it was put in place. So and that's where the European Commission brought real flexibility to the public funding on investment project. I think it really helps. It's an enabler for investment, let's say, but it's not a game changer. It should be seen as cherry on the cake. Because let me give you an example. For instance, just at noon, I was on a call with a client. So there are JV between, so it's a French, English, and Swedish JV in the end-of-life tire industry. They have a strong intention to invest somewhere in France. There is money on the table, public funding on the table for that. But the thing is, there is no site available. So no site, no project. So I think, public funding is great, but we should never forget about all the rest, which is so critical, because what's the point of, having public funding if you can't recruit? What's the point of having public funding if you can't find a site, if you have no supply base and so on? And also now some investors are quite aware, at least in Europe, that usually where you get the most, financial support from public authorities is for a reason. There is no free lunch. The reason why you're getting so much, support is because by not getting it, you would not invest there. So and they are aware of that. So that's why it's really you have to check all the different boxes, even though there is no perfect location, of course, but it's very important never to forget that public funding is great. It's very important, especially when it's cash grants, but it's far from bringing all the response that investors will require.
Thank you, Vincent. Ladies first, Julianne.
Thank you. I think that certainly partnerships are very possible in Europe. but there is this enormous, and it's probably a traditional historical thing. Everyone is very suspicious of everybody else. You know, what's their intention? What are they going to do with that information? And for some actually, they've got very good reason to be suspicious, because if you take recent developments in Hungary, where they had all of the e-waste recyclers, and the government decided, oh, we're going to take them all back. And so now that's all run by the municipalities. So, you know, you have to be very careful where you invest and look at the history. And Europe, the European Commission and the European Parliament and so on, you know, they're not there for 20 years. They're there on a short-term voted in basis, and they change from flip to flop, a bit like the Americans with Trump and Biden. And Trump doesn't obviously think very much of the European Union at the moment. And, you know, and so you need that outside support as well. So there are reasons why people are suspicious about partnerships. And I think, you know, we just need, actually, we should probably just have a big room full of women. We'd all be, you know, sorted out much quicker.
Thank you. Who else wants to continue?
In my experience, wherever the government put their fingers in, I mean, they either the corruption or collapse was there in my context, but I'm not too sure about the European context, whether the government has succeeded in taking a role beyond the regulator. Yes, government need to be the regulator for sure, but I don't think it is a major concern the government to take part in these operations. Anyways, of course, the funding has to come in, but even in the case of regulations, I think I see the European governments are too adamant on certain things, because they should not impose any regulation on a European company where the other parts of the world is not doing. So then the companies are losing competitiveness here. So the European government also, or even in that case EU also, I think seriously think of not to implement or not to impose any regulation if they cannot do it for the whole world.
Thank you. Sure.
Actually, I think, like, let me relate the experience in China. Like, it's a little bit tricky, but I think it's more than just funding. Like, in China, like every city government is just like a venture capital, and they will choose and to foster different promising industries. Like, we all know DeepSeek, a very famous, usually China AI, and this is actually a vivid result, like from Hangzhou government, and the AI is a very strategic industry locally. And likewise, we have other cities which are very focused on the lithium battery or the solar panel manufacturing. So actually, the local government doing is not just giving fundings or this financial support, but very comprehensive. Like, they will introduce them to the industrial park and give some electricity subsidy or very low industrial electricity price. And when the manufacturers, they have met some obstacles, they will have some specialists to serve them. So more like a playing a serving role in this condition. So I think they are doing very comprehensively, so that we see a very integrated and comprehensive value chain nowadays in China. And yeah, that's my feeling of like what government's role and they are doing along this journey. Yeah.
Thanks. Henrik?
Yeah, I actually found this very interesting to see the government as VC or so, because this is probably also something what could, at least to some extent, work maybe here. I mean, one thing for sure, especially if you're a young startup, you really need these fundings or so to really scale and scale fast. But I would also say it would be quite a good option to see the government, or at least if they support you with some, yeah, I would say, not strategy things, but more like on the execution in the end. So if you, I don't know, want to move to a new site or so, that they advise you for the bureaucracy or so, stuff like this, or probably introduce you also to when we take a larger zoom out, I would say it on the European level, also maybe support you in regards to, okay, collaborating with other European countries or so. So therefore, I would say like could also act in this regard as an accelerator, and it's not just about the money, but also probably helping with things out, which also kind of then build up like the regulatory, the bureaucracy, and also like inner European partnerships.
Okay, thanks. Another question to all of you. Most of your statements now were on initial funding, supporting in the initial phase. This focus is here sustainable business. So how should government react in a crisis, for example, as we had some years ago with the financial crisis, where government bought shares in banks? Now with the energy sector, sometimes in China, it's from our perspective, state should help real estate currently. So is there anything to add, to change to your statement before now based on sustainable? And if there's a crisis, if we return back to global economy rather than local economy?
I think when we talk about the startup, usually we do a business plan at least for the first 5 years. I mean, in this sort of a case, we do it for focusing on 10 years where we factor the not only the capex, where the opex as well. So I think the question is, I mean, from day one, from the even before we spend a cent on a business, we have all this on paper, including the opex. So
okay,
that's how it goes. Yeah.
No statement. Okay, then we have some time left for questions by the audience, giving you the possibility, if anyone. No? Is it too late in the afternoon? Okay.
Maybe
okay.
On Dominique from Automation. So regarding the clean industrial plan that was disclosed yesterday, do you think there will be a quick change in the European investments for that aspect, or do you think it will be more long term, and will it be enough?
I don't think it will ever be enough, but nothing is ever enough. But I think it is definitely a long-term plan. We've not got any of the details yet. We've just got the highlights. And if you've actually downloaded it and read it, it's a big document. So now I've been busy here chatting to everybody, so I've not had the time to review it yet. But colleagues in the industry have looked at it briefly, and it kind of supports industry, but on the other hand, it doesn't. So it's here's my hand, but I'm going to bite it back afterwards. So, which is fairly typical. And I think yesterday I highlighted all the challenges and issues, but the other thing is twist it around the other way. They are all 100% opportunities, and the opportunities are there for companies who want to consider where their future is. But you'd need a crystal ball, but if I had a crystal ball, I'd have picked last week's lottery tickets. But I think you do need a crystal ball, because we're talking about new legislation in Europe that isn't actually going to have an impact for 15 or 20 years. So because we've talked about how long batteries last, and then they come back to the recyclers or the reuse, and so they get a further use. So by the time it comes to our sector, the recycling sector, we're talking about 2040. And who knows what we'll do then? How many AI will be around? How many recycling plants will have 10 people working in them, and the rest are all robots? We just don't know. And that's a really difficult position if you're looking at funding, not only from a financial institution looking at putting funds into a company, but a company who's looking for private investment shareholders. It's about this prediction. It's such a hard time to be in, I think, but it's an opportunity, and so there are opportunities for linking up with partnerships, logistics companies, plant companies, AI companies, but we need to be communicating. And as I said yesterday, opportunities.
Okay, thank you. Any comment from?
Yeah, maybe I will add that. So I'm not really sure about what's in the plan, which was announced yesterday, but I would say that we can have all the plans in the world, you know, to create demand, sometimes a bit artificial demand and so on. But at the end of the day, I mean, the bottom line is that until we solve the competitiveness issues that we have in Europe, you know, I mean, this is really where success lies for Europe, right? So we have to make a real progress in solving those structural competitiveness issues if we want to be successful in the global market. I think again, you know, there is progress being made. It's always too slow, but there's, you know, there is some nice progress. And for the rest, you know, those plans at the EU level or even at national levels, supporting with funding or you know, tax credits, some industries and so on, are always nice, but it's not going to be. I mean, if competitiveness, sorry, isn't there, it's not gonna work.
Sorry, just one other thing about the Green Deal, industrial deal that was yesterday. So you remember in my presentation yesterday, I said one of the challenges was the lack of skilled workforce and the lack of the knowledge and that. Actually, they must have been listening, or you might think that I was part of the group that actually contributed, but there's going to be a European skill base opportunity. So Erasmus, you know, famous university system, Erasmus are setting up a skill base for the recycling industry, and that was announced yesterday. So that's, you know, fairly good news.
Okay, so to end up this panel, the panel before was personal question on the investment. So do it a similar setup, and I will answer it from my perspective that gives you some time to think about. So imagine you are heading the EU government, don't have to align any of your decision with anyone. So similar to Donald Trump in the US. What would you do? Okay, question understood? My answer would be, I would invest and start up with recycling on my behalf, run state-owned or EU-owned, and if it's running, I will look for investors taking over, just to make sure we have a start. Start first, and then see what happens. That would be my decision as Ursula. Okay, doesn't look like Ursula. So who wants to answer that role?
Yeah, I think that for me, if I was in charge of the EU, I would immediately ban the word waste. If you look at the American company that was here, that's it. They use the word scrap. And now scrap is a very American word, and it is right, because that material is going to be reused. And so we need to ban the word waste, would be my call. And that would solve so many issues.
Okay, thanks.
Yeah, I can just agree in terms of the term waste, actually, because we already experienced a lot of this, especially if you want to ship waste across borders or so. So that's also the thing why IRCU would actually first take a look, okay, what is really critical right now, what we definitely need in the recycling sector in the future, look to the market, find innovative startups, but also probably some OEM projects or so, and really try to support them first on a financial base, but also in EU guidance, I would say. So also connect them with other important players in the EU landscape, and really try to accelerate these solutions in the end.
Thank you.
Yeah.
All right.
Just imagination. So in my nationality can never be.
Say never, never.
Yeah, never. But let's just start it. So I will firstly have an overview of the look of like the status quo, like what kind of along this value chain, what we have and what we are lacking. So that's the step one. And step two, accordingly, if we lack something, we just add it or just do it. And by doing so, maybe I will choose some potential suppliers already in, or I just fostering a new one, and who are technical capable and also have relatively good supply chain or sales layout, and then to fostering this kind of 1 to 2 representative companies and to supplement the supply chain. So hopefully it will work.
Thank you. 2 more to come.
I would take all ownerships of the companies other than the land supplied or infrastructure given to the companies who work on recycling, because the context is based on recycling, right? If I get all the powers, yeah, nothing else. So then the government will have some percentage based on the value of the land and any other utility infrastructure given, but government will not have any control, and all the subsidies, whatever, will be based on the business plan only after justifying whether they are making a right business case.
Okay, thanks.
Well, the short answer to your question, I was trying to think, it just came into my mind. I would try to probably just implement the Draghi report recommendations to really try to improve competitiveness. Let's not forget also that the EU doesn't control everything. So many things are, in hands of national governments as well. But I would, definitely try to improve the competitiveness of Europe, for example, by trying to or take measures to bring down the cost of energy, which is very a huge burden for European manufacturers right now compared to their competitors, for example, in the US. So things like that, and probably subsidize as well internal, or the recycling of European scrap by European manufacturers as well. So things like that.
I'm saying one thing. If I have all the powers, the Europe has actually the best regulations in the whole world. When I read, but that these regulation makes the European companies heavily uncompetitive. So I will make the whole world either follow these regulations or EU will not have a fair. I will ensure that the EU companies will have a fair playing ground.
Okay, thank you very much. Thank you for your spontaneous thoughts and statements. We made it nearly on the spot. I think there is a break, and Cameron, will you take over the remaining 2 minutes? Please give a thank to the panelists. Thanks for listening.
And I want to just second Julianne said, like in the academic world, science world, we don't use waste. As soon as you label anything as waste, the clock starts, you got to process it, handle it, get rid of it. So it's scrap, it's spent solvent, used reagents, right? Pre-treatment of something. So definitely agree there. Yes, we have a networking break now. Let's reconvene here at 4:15. So a little more extended break, and hopefully start a little ahead of schedule. I know it's been a long 2 days, and maybe kind of wrap up a little early so we have more time to relax tonight and get on with our travels.
Shall I give you a hand? Yes.
There we go. And we're gonna finish up. We have one last speaker and then a workshop, and then that will conclude the conference. So up next, we have Mehmet Selek from Ford Otosan, where he comes with a unique technical background, but also around sustainability. And we need more of that in the sustainability world. We need leaders who have a technical background and less leaders who are PR, marketing, finance, business. So he's the product sustainability engineer at Ford Otosan, and he's really leading the development of new collaborations and funded sustainability projects and coordinating sort of ongoing initiatives. Really, his expertise is focused around battery circularity. And today he's going to be talking around different strategies for the circularity in the battery industry.
Hello, everyone. So today I'm gonna again approach the situation around the OEM's side of view against battery circularity. So before starting, I'm gonna give a short overview of Ford Otosan. You may know Ford Motor Company from the US, but we are actually a joint venture located in Turkey, which is shares are equally distributed between Ford Motor Company and Koç Group, which is a holdings company in Turkey. We mainly produce commercial vehicles. We are specialized in that field. But recently, we purchased the Romania Craiova factory, and in there, we're also started to produce passenger vehicles as well, Puma and Courier side. And in total, we currently have around 750,000 vehicles production per year capacity. And it will be projected to up to be 1 million in upcoming years. And if you go on the number side, you can see our revenues, and we employ more than 25,000 people. We are also deeply oriented in research. So we have more than 2,000 engineers on our R&D centers focusing on research on that part. So if we go on Ford Otosan's sustainable targets, I just want to shortly mention, here's the pointer, right? Can I just want to shortly mention about some of our product transition targets. So on passenger vehicles and commercial vehicle side, we are going to be zero emission by 2035. And on the heavy commercial vehicle side, we will be targeting 2040 with on the short haul with battery electric trucks, and in the long haul, we are also interested in using hydrogen combustion engines and also fuel cell. And on the product side of, our circularity, right here, we're also increase our use in sustainable materials, mainly in plastics and steel. So if we go into what do we do in product sustainability, our main motto is designing it for sustainability. So we can look at product sustainability in 3 pillars, let's say. One of them is sustainable material applications. In here, we try to increase our sustainable plastic usage in our vehicles. We have a target of 20% of sustainable plastic usage by 2025. And we try to also increase our sustainable steel and aluminum usage as well. But our main focus will be today of our circularity of products. So it's started as battery circularity at first, but nowadays we are also increasing our circularity application of our product lines, such as on EV motors or auto catalysts in our vehicles as well. So we mainly do both internal studies, internal projects, and some EU-funded Horizon projects as well to supply our research here. And one other pillar is our life cycle assessment studies to connect and assess the whole applications that we do here. we also have a target of becoming carbon neutral by 2050. So in all, it all encompasses the solutions together under product sustainability. So this is a huge text field slide, so bear with me. I'm gonna guide you through it. So our main, again, topic is product circularity. This slide just summarizes our applications and challenges we face with doing those studies. So I want to mainly focus on the product circularity challenges here, because other parts, again, mostly mentioned here. Main point on the OEM side is cost beneficiality of these end-of-life applications regarding second life usage or recyclability of the EV battery, whether it's cost beneficial. Also, we are doing some eco-design studies, and on there we see that eco-design of components, mainly batteries, are a huge, actually, a problem, because there are some solutions around that, but are they cost effective or easily applicable is a challenge to us. Again, on the traceability side, we closely follow EU battery regulation and digital product passport studies there with digital battery passport. But again, the topic I want to mention on that is there's huge uncertainty on the upcoming battery regulation on the battery product side, and how will be implemented. And again, fast and reliable state of X tests and using basically less and less critical materials and more recycled critical materials in our products is currently the challenge we faced with. So again, I'm gonna quickly mention about Horizon here. Since 2015, we are actually closely following Horizon studies. As a company, as I said, we are a research-oriented company. So we've been active in Horizon studies since 2015 with more than 43 projects. And currently, Ford Otosan is the most funded industrial company in Turkey with 43 projects. Yeah. And if I want to go delve into the product circularity side of these projects, 8 of them especially focuses on different kind of product circularity. Some of them focuses on autocatalyst circularity, like Peacock here, or as I said, we're looking into EV motor circularity as well. Around permanent, we're trying to recover more rare earth elements around from EV motors, especially neodymium magnets. There's also a huge question topic on there, and PGMs from autocatalysts. But other than that, most of our project focuses on EV battery circularity. They all actually focus on different aspect and part of the circularity side, from start of the end of life to end of recycling and to recovering new materials or batteries from those recovered materials. So I'm going to go especially into 2 of these projects today. One of them is Recirculate. As I said, they focus on different parts of the circularity. Recirculate is actually started in 2023 and will end in 2026. It's a 5 million euro Horizon Europe consortium around battery circularity that starts from the end of life of the battery phase up until the recycling part. So recycling is out of scope in this project, but everything before that, how we handle or how we actually reuse up until that point is in the scope. So there's a great illustration here, actually. You can see the circles going from outside to inside. So the main idea of Recirculate here, if you were to valorize the EV battery packs, first we start from, if you can valorize them from the pack level, then go level by level into module or cell level. And when they're finally done with their application, or if they are not applicable for reuse, they will be sent to recycling. So main objectives of Recirculate project, if I shortly mention, safe storage and transportation. Firstly, because when the batteries reach their end of life, they'll be more critical to safely store and transport. We are also one of our partners here also is DHL working on here, DHL Turkey. So they are developing their Digitruck solution under this site and storing batteries safely for transporting into different locations. One other important topics and fast and accurate state of X characterization for prior to any reuse or dismantling applications. Another important topic we're focusing on here is automated dismantling. So in this project, there is automatic dismantling is studied from one of our partners, Sentry and Probot. So they're actually developing a fully robotic automized solution with AI-assisted robotic dismantling for not just Ford spec, but different OEM spec as well. So the system will recognize the pack and dismantle it without human interaction. Again, whole of this is connected and traced with a blockchain-based battery passport here. And those you can see one of its applications is here. And this project, by the way, started before the digital passport regulation is in place. So it's kind of in its infancy state in this case, but it will be further developed. But you can see the one of the first applications of blockchain-based battery passport there. And all in all, it will again connect in a marketplace. So idea of the marketplace is where all these use case applicants can share and basically sell or sell their services in a marketplace, such as like end-of-life batteries or end-of-life components or scraps. And as I said, it's with 11 partners around 7 countries. So you can see the partners here. I'm not going to go into each one of them, but what we mainly do in this consortium is we supply the consortium with our end-of-life or production scrap batteries, not waste, production scrap, but also we advise on some circular applications, and we also lead the life cycle assessment studies in here. Another project is Betro. This is again another Horizon Europe project. This is more focuses on EV battery recycling. So it is more on the topic of this meeting as well. It started around 2022 and it will end in 2026. It's a 12 million euro project, again funded by EU. So main objectives, again, I'm not going to go into each one of them because like there is some overlap between, again, the recirculate side, but Betrov also focuses on the recycling side and trying to improve on the post recycling side of the studies as well, such as in the technologies developed in the project, there is high recovery rates of critical raw materials are being targeted. Also, again, with everything learned from those studies, we are also partnering with Renault France here, another OEM. With Ford and Renault, we are trying to produce new eco-design guidelines here for better manufacturers. So those guidelines will entail strategies for battery pack producers to produce their packs in a way that it will be more reuse or recycle friendly, let's say. And you can see the general structure of the consortium here. Again, some of other post recycling studies entails with partners like SEPS here. So they are mostly focusing on the EU policy side of things. So what we learn in this project, they are giving feedbacks to European Commission policymakers. So we are also giving legislation in a feedback in that way as well. So finally, final project I want to mention is an internal project actually that we do in Ford Otosan. This started as an MVP project in 2022. It's a battery reuse project. So we had some production scrap batteries laying around. So we wanted to actually create a energy storage system around that. This was its first application actually around for global plants or in Turkey. But there are some actually other OEMs have been doing this. But the main idea around creating a energy storage system business model came from like this. Its main business model came around the arbitrage model. As you know, you can charge these batteries at night when the electricity price is low, and you can discharge at peak points while for example, all of the factories open up their lights or manufacturing lines, the electricity prices rises, and you sell your electricity at that time. And all around there's a saving, there's a money saving potential. But we also see that there are different potentials around with higher kilowatt hour ranges of energy storage systems. There are different potentials in grid support or peak balancing strategies as well. We are also trying to improve our solution around that part. And main financial benefits of this we saw as since the batteries are production scrap and normally unusable, we are actually using those batteries, and we saw that this is more like on the residential base, but as I said, it will be increased to higher capacities with industrial bases as well. So that will also increase the capacity there. But on the residential scale, we saw that around same capacity of ESS systems, we actually save around 45,000 euros per system. So it's actually a huge potential, I guess, on the OEM side for doing this kind of applications with reuse before sending batteries maybe directly to recycling. And as you can see, even current production rates with around 450,000 transits in our facilities, there will be like 4.5 million battery modules will be coming back at their end of life eventually. And there's again a huge potential there with the end of life battery modules there will be. And we also seen in our research that second life ESS market is targeted to be around $30 billion around 2030. So we see a potential again here. Again, I wanted to quickly mention on the upcoming battery regulation side. But again, since everybody here also talked about it, I'm just going to go brief here. We are closely following the EU battery regulation, what it entails and what it will bring. We see that there are open points and some points that will be addressed later. We are closely following that, but we are also seeing the main question around those uncertainty points here and how they will be addressed. We are also closely following the European Automotive Association's points here, and we are actually in line with their idea of those open points needs to be addressed, and some of the actually responsibility around the OEMs actually should be addressed again. So finally, in my final slide, I just want to again mention possible partnerships around upcoming Horizon Europe project that we are actually want to be involved in. It involves different topics around, again, circularity or product side. These upcoming calls will be actually released in, I guess, April, but this is a press study we made before those actually released. So we will be closely following them and starting new discussion and collaborations around these. So yeah, please you can be in contact with me or our team here. And yep, this is the, I guess, final slide. And I want to finish it with the Henry Ford saying of picking up and reclaiming the scrap leftover after production is a public service, but planning so there will be no scrap at all is actually a higher public service. Thank you. So I can take questions. Sorry.
Thank you, Mehmet. Do we have any questions from the audience?
So you mentioned Ümit Batmaz, Dacia. You mentioned about 450,000 transits to be a battery electric car in the future. You have a planning on that?
Yeah, eventually we plan all our, in our target slide, I also shared by 2035, we plan to have all of our commercial vehicles to be zero emission. So in line with that, they will be battery electric, and that's just with the current rates. If even the rates, production rates could be increased, so that number is on the lower end side, possibly. So yeah, in the future we expect it to be around at least that. And when those batteries reach at their end of life eventually, as the battery regulation mandates currently, the economic operator will be responsible of their after services. Yeah.
But you don't take you don't manufacture only for European market. You manufacture for also Middle East market and around the world you are selling. So how you will manage that?
That's true. That's true. But even though we also active in those markets as well, around 90% of our sales actually go to Europe. So in that sense, that number is sensible. But you're right. There's even though it's small, we also have representation in Middle Eastern or those countries, also in Africa or other countries as well. Yeah.
Last question. I take advantage of having the microphone. You also mentioned about the scrap from manufacturing. These are scrap of batteries coming from assembly lines, correct? My understanding, or something else?
Yeah, that's right.
That's right. Okay. Today you are able to recycle these, or as far as I know, in Turkey we don't have any.
Yeah, actually on that
facilities on that. Yeah.
There's a recycling company. Maybe you heard of them, Exitcom. They're not actually very, in a sense, their recycling outcome is not battery grade, let's say, but we are currently working with them as well for our production scrap batteries. So if any batteries lay in our facilities as production scrap, after some time, we send them to recycling to them currently. That's again in a local partner in Turkey, but we're also in Horizon projects, as I mentioned, closely following other recycling methodologies and companies as well. But that's the current situation in Turkey, yeah, as you are correct.
I got one quick question, maybe not quick. We've heard a lot about data, automation, AI, and questions on the efficiency and energy consumption of doing this. Now, for adding AI to traceability, the passport, and if you even implement something like blockchain, at what point does all the background computation start to make it less efficient in terms of energy efficiency, greenhouse gas efficiencies, or is that never the case?
Oh, that's a good question, actually. In one of these projects I mentioned, Recirculate, we are also, as I said, leading the life cycle assessment studies there. So regarding the life cycle assessment of big data there around batteries and blockchain, it's not as big as, let's say, the recycling of the whole battery or the production of whole battery, but on the small scale, it's actually a big part of the carbon emissions regarding battery, regarding the whole circularity of the battery. That's correct. But it's again on the larger scale. When you look at it, it's around 1 or 2% of the whole scale of the emissions. So in that regard, it's not a huge deal around that currently, as it seems. Maybe it can change, but yeah, you're right. On the small scale, though, it's one of the big topics that uses carbon emissions and uses energy. Yeah.
Any last questions? All right, then let's thank our speaker again. All right, made it to the last session. We're gonna have a little bit of a different process, or a little workshop. So if I can invite Rosa Wells, Paul Whitesides, and Vint Janik to the stage. I'm not exactly sure what they're gonna do here, but I think it's a little more of an interactive presentation, and they might give you some homework. So let's find out.
Yeah, you can take it.
I think so. Okay. We go back to the start of the. Oh, we got. There we go. That was the whole presentation backwards at great speed. So, well done, everybody, for making it to the end of the day. It's very informative, but I'm sure everybody's getting a little bit tired by now. We're here to talk to you about skills projects and skills in battery manufacturers, a slightly different theme to many of those today. So we're representing two skills projects, one the Electrification Skills Network, where Vit and I are from, and the Debut Battery Project from the University College Birmingham, which Rose will be talking about shortly. We're both funded by something in the UK called the Faraday Battery Challenge, which, as you may have guessed, is all about batteries. So if I press that button, and the whole idea is trying to meet the UK's predicted battery demand by 2035, which, as you see from the infographic there, progress is being made, but the whole idea of Faraday Battery Challenge is trying to get us there that little bit faster. And one of the major challenges, and the reason we're looking at skills, is actually to produce batteries at scale, you need lots of people. So again, our focus has been the people element. In terms of our driving forces and the reason for battery, obviously, ICE ban, zero emissions mandate, and many of the things we've talked about today with many of the other projects. And the innovation is obviously key to one of Faraday's main intents. In terms of Faraday Battery Challenge itself, it's a £610 million investment to grow, hopefully grow a UK world-class battery industry. And there's lots of research, which is via the Faraday Institution. And I believe you had somebody from the Faraday Institution here yesterday. We couldn't make it yesterday. They are the research arm of Faraday Battery Challenge. So funded, looking at research into battery technology. The Faraday Innovation Programme, which sponsors lots of businesses in terms of battery manufacture, BMS systems, everything battery essentially. And to the right there, we've got the UK Battery Industrialisation Centre, which is a £200 million scale-up facility in Coventry. So if you ever want to come and see that, speak to one of us and we can hopefully get you a visit there. And essentially that is to try and bring us up to speed with the world of batteries. And in terms of support, it goes from mineral extraction all the way to battery recycling. But the bit we're most interested in, and the pointer there somewhere, is well, that's not easy to use. Skills, particularly skills, is our main concern today. And again, the three projects on the right-hand side there, we're at the bottom, Electrification Skills Network and Debut above us. We're hoping to support the 270,000 jobs by 2040. So a big element, if we can't have the people with the right skills, we can't deliver what we need to deliver. So it's all about reskilling, new skilling and upskilling of individuals. And as you can see from the battery ecosystem, it's quite a size, even in the relatively small island like the UK. And you'll see in the middle of that infographic, there are those three battery skills initiative around to support all those things. And you want to find out more about the Faraday Battery Challenge? If you scan that QR code now, it should send you to their website. I'll give you a moment to do that, just in case you want to learn more, as they say. Give me a chance to catch your breath. There we go. Almost got it? Nope.
We'll find it for you later. We'll pass it on. So the Electrification Skills Network is a collaborative joining up entity, basically. We're here to help skills providers particularly understand the skills market. So what should they be delivering to individuals wanting to work in the battery sector, helping industry understand what skills may be needed and how to work with people they're bringing into their gigafactory to do that, or recycling, or whatever it might be. So we do that by trying to align collaboratively skills providers, industry, and accredited bodies. So in the UK, we have an awarding body system where we issue qualifications. So getting all those people to work together is really critical. And it helps narrow the gap between technology and skills delivery and skills training. So making that as short as possible. So the skills training being offered matches the demand and the pace of technology. And to do that, our project major objectives is working with skills providers. So making sure they're aware of what they should be training people, upskilling them, reskilling them in some cases to give them that extra bit of information, expertise, working with them to give them subject matter expertise and developing a framework for electrification that's really clear and simple that people can look at and go, actually, that's what I would need to get me from A to B. We also deliver a national forum, which helps spread the word and give people more information on the world of batteries, essentially. And we work with awarding bodies, as I mentioned. Critically, we have those supported communities. Again, it's about working with these different colleges, different training providers, helping them support, collaborate, and share best practice, share training materials where necessary. Why create things multiple times when you don't need to? And then again, our National Forum for Electrification, we deliver that on a quarterly basis. Again, you're welcome to join. It's not limited to the UK. And again, we bring stakeholders into that talk about, as we have done today, key elements and key activities. And that's about it almost. So to date, we've established a framework for electrification, which Vit's going to talk us through in a few moments. We've worked with skills providers to support them so they can bring their progress forward. We've delivered masterclasses, so upskilling lecturers in colleges to be able to deliver more up-to-date training. We have what we call common sets of skills in electrification. We'll share the website details later this month, where we've pocketed skill sets for battery production into small packages, so people can either choose to make them into a long, lengthy course, or they can use them to fill the gaps with individuals. We now have a quarterly forum I mentioned, and we support events such as this, spreading the word around that. And then we work with other skills projects such as Rosa's on a regular basis. And perfect timing, I'll hand over.
Oh, thank you. Based on what we've been learning from the Electrification Skills Network, we were then funded to put that into practice to actually create something that's going to work for industry. So we've been working in the West Midlands, in the centre of the UK, and there's also a project in the North East. So we've been building on their work to look at what that means in practice in terms of training. And so we've brought together some key stakeholders. So I'm from University College Birmingham, and we deliver university level courses, but we also deliver what we call college level, so TVET. So we deliver on both sides. A small company called Ravmac, who made up of specialists that have worked in predominantly the automotive sector, Cranfield University, and WMG University of Warwick. So we've come together to make sure that the training we provide works for the region and then can be scaled up nationally as well, bringing together the educators with the technologists and those from industry to make sure that the training we develop works for industry. And we're collaborating on that, so working closely with other stakeholders. But also we've been given the task from Innovate and the Faraday Battery Challenge to look at outreach, so working with young people, working with parents to try and promote the battery industry, so people can understand what careers might be available in the future if they're not sure about what that looks like, and to improve some of that equality, diversity and inclusion within the sector. So it's been a really interesting project. We've been working on it for 18 months. We're ready to launch the courses in the next couple of months, and to have people start studying with us. So as well as our partners, we've been supported by industry. So JLR was one of our first supporters, but also others in the space, those in the sector that are supporting manufacturing with the equipment that they need. And at the moment, there is a big focus from our course on manufacturing, but we will move into the recycling space as we establish the course, and working with our regional advisory group as well. So we've created 2 courses, one aimed at operators and one aimed at technicians, but these are suitable for everybody. So when we're talking to Jaguar Land Rover, they're talking to us about how all engineers need to be upskilled or reskilled in the chemistry, the high voltage skills that are needed. So there's a lot of work to develop the whole sector to be able to be ready to work with batteries at whatever phase of manufacturing or recycling that they are engaging with the process. And it's a short course, so it can be done in a week. It's quite intensive. We have pre-learning that can be done beforehand, so it's a couple of days beforehand. We've got online learning, we've got a physical space for them to work in, and we've developed immersive training. So whether that's working with the chemistry of the batteries or the high voltage space, we recognise that you need that immersive training so that you've got a safe space to try things out and to really understand how those batteries are put together. And so we build in some gamification and get people to try things out before they have a go in our simulated physical learning factory as well. And this is where it's going to be. So we're in Birmingham, which is nice and central in the UK, easy to get to for anyone else that wants to train. So as well as training engineers and working with industry, we'll be training trainers to go out and do this around the UK as well, working closely with the Northeast and building more capacity within the training based on what's coming out of the Electrification Skills Network findings to help look at what we need to do next once we've got some students through this course. So that's how the Electrification Skills Network has supported us to then develop the courses. And now we're going to have a look at a bit more of the work that the ESN project have been doing. Here you go.
That's how it works.
Yes.
So it's only forward, no
yes,
backward.
Well, I think the one below.
Okay. No, I want to go back. Good. So now a little bit more of the technical things. So it's supposed to be a workshop, so you need to learn something. And I'm not sure how much you are familiar with the taxonomy of skills, which is a big subject, and it's a big point of contention between industry, skills providers, and awarding organizations, because everybody's using a different language. And when you want to establish connections, the common language is the most important thing. So there are several ongoing projects and ideas floating, and one of them is through the World Economic Forum, and they just released the Reskilling Revolution package, which is trying to put some, let's say, some competent language into the practice and unifying these different languages together. So we'll be talking about knowledge, skills, abilities, and behaviors as a defining element of any workforce in any sector. If it's from food industry, going all the way to entertainment or going to manufacturing, doesn't matter. Everybody should be using this kind of language. So we will be practicing now in the workshop, and we will try to understand what is needed for knowledge, skills, abilities, and behaviors, how they will then build competencies for the manufacturing sector, for battery manufacturing specifically, and then how this is translated into job roles. So if you are OEM, you don't care about any of these. You care only about job roles and how these duties and competencies are then performed by the workforce that you are employing. If you are a university or a college, you don't care much about the job roles. What you want is a course material and subject expertise to actually train people in your specific subject. So where the point is of the connection between these, that's why we as an ESN, we try to help both the skills providers and the OEMs to actually work together and develop a framework that can then be translated into electrification. So if I move forward, as you can see, there are multiple initiatives going on, and it all started in the States. In the United States, in the 90s, they had a research project, and actually they defined very strictly 35 distinct skills and fit for 52 distinct abilities that are covering every single job everywhere in the world. So that's the main and the beginning of the skills taxonomy in the States. And then it was every country tried to approach it from a different angle. If you look at UK, for example, at the moment, that's the fifth point is we don't have any specific knowledge, skills, and behaviors defined. This is an ongoing project. In EU, for example, if you look at the European standards, there are 14,000 skills defined. So every single skill is basically defined very, very granularly into the most specific subject. So if you compare the European and the American approach, it's completely different. And if you have an American company trying to establish some work in EU, you will see that they will be thinking in a completely different way how to train their people. In Singapore, for example, as one example from multiple Asian places, they have 2,000 technical skills, so it's somewhere in between. If you look at India, if you look at China, again, completely different environment. So what is the second point is the World Economic Forum, and they are trying to adopt the American approach, and they are trying to define 93 distinct skills. And with them, every single country should be working on this basis to develop the framework for any kind of occupancy. So if we move closely to the electrification, we obviously want to train people for now, but also for future. So the big part of our exercise is the workforce foresighting, and the cycle is ongoing, and we just released the first part of that, which is on manufacturing of lithium batteries. Second part is already completed, that's assembling, so that's more on assembling into cells and packs for the OEMs. And then will be a third one starting in spring this time, which will be on battery recycling, and that's probably the most interesting for you here, which I will invite anybody if he's interested to be part of that exercise to let us know, because we need experts, because these experts will then define what is needed, what they think is needed for the future, and that then can be translated into what provision the government will then fund and what then will be the priority for the education. So this is something that we are very actively looking at and working on, and these data are published. You can access for cycling cycles in every aspect, in every sector, but in battery manufacturing is really critical because it's a new sector and there's a lot of new things happening. So if I look at details, this is a bit shifted. The foresighting outcome for the battery manufacturing, as defined by the knowledge, skills, and behaviors, the main point is actually there is a massive gap in skills between what the industry thinks they need and what is currently being offered by the skills providers. So 70% of all job roles that are defined in battery manufacturing production are actually not matching the current skills provision. So there are massive skill gaps across all sorts of job roles, especially in the logistics, quality control, sustainability, recycling. All of these people are trained currently without any knowledge of battery chemistries, battery recycling, circular economy, and so on. So the problem is that the employer then will have to retrain these people and basically create short courses to actually close these skill gaps on their own. So that's the outcome of the foresighting, and that's when now we can start looking at the workshop and start to close these gaps and try to think what needs to be done in terms of improving this problem. So now the ESN, we as a ESN, we developed a framework for electrification. So we are trying to identify the electrification skills and showcase where is the provision, and also showcase where the gaps are. So working with employers and working with industry, look at the gaps and try to bring those gaps to the skills providers to create courses and create provision for that. So how we are doing it, we defined common set of skills, and this is we are becoming very technical. I understand it's quite late, so I'm not going to go to very big details, but we need to consider why we are talking about skills, because we talk about in the beginning the difference between what the industry thinks they want and how they define their needs, and then what the education is offering. So they are looking at job roles, they are looking at skills, and we have common set of skills that are set of skills that can be delivered whatever aspect of electrification we are looking at on a very small package. So any person with expertise in electrification can deliver this set of skills without engaging multiple people from different areas. So if you're looking at battery chemistry, you don't have to involve somebody from logistics to deliver a course. You just talk to the battery guy, he will teach people, and that's one common set of skills defined. So we are looking at this kind of way, and we look at the battery unit maps, which is very complicated, and it's coming from multiple projects, but basically you need to know all of these things if you want to be at a certain level as a technician, or manufacturing technician, battery material engineer, or production line manager. All of these things needs to be gradually acquired. So if you look at the actual framework model, there is a lot of things going on and it will be all published by end of this month, next month. It will be on our webpage, and it's universal skills that are applicable not just in the UK, but it could be beneficial for anybody because it's universal subject. And it will be obviously tweaked towards the UK provision based on the standards and so on. But the common set of skills are universal for anybody. And it could be quite useful for any educator or any industry to actually look at the framework and to work on a common basis, like almost like being conducted on the same rhythm in the same way. So now we have all these common set of skills, and this is the part of the exercise we'll be doing. You have battery fundamentals, you got battery supply chain systems, you got BMS, you got manufacturing aspects of the battery manufacturing, you got health and safety, quality control. All of that needs to be broken down to small packages, to very small pieces that then can be delivered. And then this can be used for reskilling, upskilling, or completely new skilling of new people from the school. So consider, for example, we got a big OEM that has no battery production, and they are conventional ICE car maker. They do a lot of conventional powertrain, they do a lot of dry line, they do a lot of casting, they do a lot of forging, welding, and so on. They don't have any other production. Then regulations force them to stop producing conventional cars and start doing electric. What they are going to do, they need to reskill their people. So there is reskilling from conventional mechanical engineering to mechanical engineering design and battery production or battery assembly, hazardous voltage, health and safety with chemicals. So all of that needs to be somehow approached by both the company and whoever is going to deliver the training. So we are using this common set of skills idea to create this framework and to let everybody to actually shorten their time to market basically in training. And it's not only, if you are looking at this side, this will be the battery manufacturing, but we are also looking into PMD, so power electronics, machines and drive, magnetics, all sorts of other things, thermal management that are necessary for all electrification. So not just battery manufacturing, but the integration into systems and looking at battery design and battery implementation into any kind of mobility. So common set of skill examples. So this will be the one type of package or module that will be looking at battery fundamentals. And obviously you need to define in which level this is delivered, if it's hands-on or just introduction, or is it a top management, or is it some expert in the field that's going to drive the R&D. So in this case, it's the introduction operator level. And then it's purely theoretical, and you can define some objectives. You will get some additional notes, and we will contain also some course material or some learning materials into that. And that then can be applied to any skills provider who can do the skills training for the OEM or for any part of the supply chain. So this way we actually design this framework, and this way it's going to be applicable, and it will be available for anybody online to use it and to have a play with it next month, hopefully. So this is where it starts to be interesting. Because at the moment, and this is every country has a completely different landscape. So this is valid for UK. At the moment, we got the battery manufacturing technician defined as a standard, which is basically a very prescriptive way. If you want to be a battery manufacturing technician, you have to do this, 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 and it has to be delivered in this amount of time. We have this, but we have none of these other things that I'm showing at oh my God, this is difficult. None of that exists. There is no standard in the UK for that. And this is actually taken from the European project called OLBATS. And I will be sharing some of these skills cards as a part of the workshop. These things are basically in the public domain, published as a part of a research project, Erasmus Plus project. And they developed these descriptions. which I'm very much almost pontificating people to use that kind of approach, because this is everybody can access that and everybody can then standardize the language. So if you bring the job card to a skills provider, you look at it, and the skills provider will say, okay, yes, we can do this or we cannot. If this is not there prescripted very much, it will be a mess. So this is very good. Problem is that there is no standard around that, so it's still not completely integrated in the framework of UK and obviously in the EU. You will see that examples during the workshop. So now, as I said, everywhere is different. So you got activities going on in France, for example. You have Vercor, you got Allbats, you got CA-BAT project. There is a lot of stuff going on in Germany. There is Electromob in France, all sorts of beautiful things. They are trying to integrate that together somehow. But if you are one OEM that has cooperation in Spain, Italy, Finland, Hungary, and UK, every single country has a different system. So the idea is that if they are using the same framework and if it's part of the EU, then it will simplify things for the OEM a lot. So these are our contacts. This is, if you want to keep in touch, look at the framework and use that, please contact us. And now I will try to make the workshop somehow. So some engagement will be needed from you. So I will hand over some help in terms of the EU Allbats skills cards for specific job roles. And also we have some glossary of the taxonomical terms. So there is a definition what actually the knowledge means in this taxonomical system, what skills means, what abilities are, what is defined as an attitude or behavior, what is competency, and how that then links to the job role. So please, if one of each for everybody. And I will also, this will be given. You can bring it home and you can memorize everything. It will significantly easier if you are working with HR learning developers. This is the language they will be using. Here is a Menti board. So if you can scan the QR code, it will bring you to a web page where you can use your phone and answer some of the questions. So this is the interactive part of the exercise. So if everybody please can scan my Menti. And this is coming from my COVID time when I was teaching during COVID. And this is the way actually you can engage with students remotely. So everybody's on the Menti. Scan the link and there will be some questions. There will be some questions you can try to answer based on the skill cards and based on your understanding. I think what is more important is your understanding of the area, your understanding of what you think is appropriate, what is needed in that particular job role. So these are the job cards. Again, I need to reference the Allbats project, which is Erasmus Plus project that was funded by the framework from 2019 until 2024. 3 million project taking into account a lot of OEMs, skills providers, accreditation organizations across all EU, and they publish these job cards, and they are very useful. There are about manufacturing, there are also recycling, and if you click on that link, that will give you access to that full resource. This is just 3 out of many. So now hopefully we'll look specifically at one job role, which is the battery manufacturing technician. So he's a technician. It's a lower level job. It's not somebody who would be expecting to have a university degree. In UK, it is actually level 3, which means college, somehow, below university. What is very interesting is, and as you can see, this is the problem of EU, there is no existing standard. So there is no occupational standard published yet. Even though everybody is talking about gigafactories, there are 6 gigafactories being built in Dunkirk area only, just mentioning one. But there is no existing standard anywhere, and there is basically a completely open minefield how you can train these people if you want to make a battery manufacturing technician in EU. In UK, on the other hand, we actually have a standard, and that standard is broken into 4 different options. So you would not expect the technician to know everything. You will be focusing either as an electromechanical technician or as a cell assembly, or the aging formation testing and QA. And the fourth option is the module and pack technician. So that will be different implications in terms of manufacturing with hazardous materials or chemicals, or then in the later stages, you have much more focus on high voltage and hazardous voltage integration. Everywhere will be some sort of manufacturing aspect to that. So this is the description. If you can now, I hope it's going to work. If you can now type your thinking into what you think is the core knowledge that is needed for this battery manufacturing technician. So you can use your phone and type it there. I will then show you the answers, what is actually required by the OEMs in that particular job role. So you can see this is a lower level job and there is no existing standard. So how the companies are doing it is basically started by bringing people from China. And my equipment is from China. The people are from China. They will come and actually do the initial manufacturing, whatever where it is. They will go back, and now it's up to the company to do that. So do I see anything happening here? It doesn't work. No, it's not working. That's sad. So the interactive part, you can just write it on a piece of paper.
You bring the technicians from China, and they leave, and once they leave, so you are done, it does not.
I know. And then you ask the manufacturers, so why you don't buy the equipment for manufacturing in Europe? And they say there is no equipment. So you have to buy it in China or Korea and Japan because we are 15 years behind in that part. So I don't know if I see any answers. I need to click it again. So we talk about behavior. There was a previous skills, so skills and behavior. So we have three aspects, as is written in the glossary. You need knowledge, which is the technical thinking in your brain. You need skills, you need the abilities, you need the way to handle things, handle yourself, handle the materials. Then you need behavior, and this is very important. You are coming from, let's say, food industry. You are trained as a technician in mixing chocolate, and you are reskilled into battery manufacturing. So you need to change your behavior from being very flamboyant with stuff to being very technical and very focused and environmentally cautious. So if I skip now, the time is, I don't want to drag this until 7 o'clock. So let's move on. Let's give you the answers. So what is needed? And this is very big point is there are some cross-sectoral specific competencies like a quality control and assurance, testing, product improvement, automated production, maintenance and production of equipment, health and safety. This is all actually recognized across various industries. So if you are bringing people from aerospace, and if it's aerospace mechanical engineering technician, assembler, welder or something, they will have the specific competencies already. What you need and what is that's why we actually exist as an ESN, is the second half, the sector-specific competencies, which are in this case battery-centric competencies. So battery assembly methods, battery components, chemical processes, battery degradation mechanisms, all of that needs to be basically trained. If that person is not working before, never worked before in battery manufacturing, this is completely missing and it's not transferable. So that's where our CPD activities needs to be focusing on. And this is the type of knowledge and skills that will build then the capability that can be used. Behavior and attitudes, this is something that kind of sits behind, but is also very important. Environmental consciousness, adaptable, driven, and communicating skills are important, or behaviors, very important in this. Yes? Very good. Also.
And be able to collaborate with engineers.
Exactly. So the engineers, that will be the next subject. So if we move for the next slide, the battery engineer. So the battery engineer is a level above, is a battery material engineer. So it's somebody who actually got a degree in chemical engineering or in battery manufacturing, not necessarily, but battery chemicals. So they're responsible for research and development, optimization of the new chemistry, so introducing sodium, introducing solid electrolytes, and introducing completely different chemistries, looking at different stuff. So these are people are R&D researchers with degrees. They are coming from universities, fresh. They could be coming from industry. but they should be coming from battery manufacturing, because the battery materials engineer, if they have this knowledge, they will be on a smaller scale. They will be working on with Dyson for some small consumables or consumer electronics. So they need to assist in implementation battery design. So that's where the OEM needs somebody to actually know everything about the chemistry and the system engineering. Knowledge of battery manufacturing processes, characterization of testing, and compliance with regulations. So these are the requirements. And now I clicked again, wrong place. So here I am. So here we have actually an existing standard, because this is a long established role. We got a material engineer, which is, I don't know, 200 years we have materials engineers doing things like that. So we actually have, even in EU now, established standard for that. And it is very helpful because there is a very clear pathway towards what the battery material engineer needs. So now we can try again.
So we've got some responses on the knowledge, so material science.
Yes.
Being able to test materials.
Yes.
Mastering compliance.
Absolutely.
Performance measurement.
Yes.
Ability to work and exchange with operators, take ideas from operators, and then implement those ideas and solve complex problems.
If we go to the skills, the next slide.
Not yet.
Not yet.
Right there, yeah. On the
we
skills.
have skills and knowledge is very difficult to distinguish, but that's what the taxonomy is kind of trying us to do, because the skills are something that can be practiced on the job floor with employers. Knowledge is something more theoretical. Ideally, you'll be doing that half of the day you are learning something in the classroom using VR, for example. Second day, you go to the OEM, put the hands on, and train with the experienced technician there. So these are kind of very closely related things, but still, for the convenience of the educator, they are separated. So then we have behavior or attitudes.
So just one more interesting knowledge point that's been added that might be, so being humble, but also fluent in terms of collaboration with the Chinese culture.
Oh yes, that's a very good point.
Because it's obviously going to be, and then cost calculations in there as well.
Yeah. So that's the question, how you distinguish basically what the materials engineer and what are the boundaries of the requirement, because then you cannot ask them to do everything, not the supply chain, not the logistics. That's not their job. So talking with Chinese, nice, but it's more like a logistics problem, or the problem of the implementation of the machinery actually at some point. This is more like research focus, let's say developing new solutions.
So we've got a few skills coming through. So being able to do the testing with the right tools, being able to manage test plans, being able to do analysis, and analyze tool usage.
Yes. So now we can look at the actual requirements. Again, two very different specific or non-specific sectors. So cross-sectional specific competencies, and that's what's coming if you're a materials engineer in chemical, specifically handling with powder or slurry or black mass, talking about that, you can come from any industry, it's transferable. So analytical and performance testing of materials, design of experiment, evaluation of processes, project management, reporting and communication. Now, sector-specific competencies, you can see, it's all about the manufacturing process. It's all about dealing with high quantity of material. You're coming from lab, you are like a master degree in chemistry, and you are recruited to be a materials engineer for CATL in Hungary, for example, let's say. What they need to train you is exactly the manufacturing side of that, the characterization of testing on the industrial scale, and obviously the battery system and effect of that on manufacturing. So all related to manufacturing, not just the chemistry, not just the materials, but the manufacturing side of that, the quantity, the volume, the safety. So the behavior.
Yeah, we've got some, so to be able to be accountable, honest, precise, and to be able to work in a fact-based environment.
Yeah, so the innovation, curiosity, and also very importantly is always the environmental aspect of that. So don't try to play with some dangerous chemicals, or if they are necessary, try to reduce that. That should be the starting point of your thinking. If you are an R&D person, try to decrease the critical elements. So environmental consciousness is always very important. Safety, that's always especially when you move to the high voltage, when you start assembling the batteries together, there is no way, and that's what is completely missing at this point. High voltage, hazardous voltage training, very limited. It's obviously very prevalent in aerospace and in battery, where you have power generation, but automotive engineering, they don't even think about that. So finally, last part would be the production and manufacturing engineer. So that's really the guy who actually looks after the manufacturing process itself. So design, development, and execution of manufacturing processes, cost-efficient method, specific applications, product supervision, compliance with internal targets, regulations, all sorts of stuff. So the manufacturing and production engineer, again, a long history of this job role that is reflected actually by two standards: manufacturing engineer, production engineer. Both of them well defined by EU occupational standards. So that should be probably the least challenging, and then I think that isn't the most transferable between various types of manufacturing. If you want to adopt somebody from outside, it's much easier to recruit manufacturing engineer into a gigafactory than a battery manufacturing technician, because these people are much more trained across various universities and they have much more experiences by doing manufacturing in various industrial sectors. Any answers?
Got some knowledge, yeah. So that they need to be able to understand manufacturing techniques, problem-solving techniques, production planning, product compliance, risk, safety, and their interdependencies of processes, analysis. So yeah, lots coming through on that one.
There is a lot of knowledge that is actually there already. So it's much easier to train people in that, because that is an ongoing process since Henry Ford started his lines in 20s. So and before that, it was probably also to some extent in England during Victorian times, child labor were doing this. Anyway, so now we have skills and behaviors for the last job role.
Not coming
too
through
fast.
yet. Yeah.
It's late.
We've
don't lecture at 17:30. No way.
We have got a couple more coming in for knowledge. So being able to work both on site, so being there.
Yes, exactly. This is probably the most critical part of the manufacturing, which everybody is like kind of jealous about. People that can work from home, and that's what talking with industry and talking with stakeholders in the last year as a part of ESN. Everybody is jealous about the soft skills that you can get in banking, or you can sit and operate everything. Here you need to be physically on the plant. There is no other way. So you need to reflect that when you are recruiting. Actually, you need to recruit people that are willing to be in the plant and have dirty hands all the time. Otherwise, no matter how smart that guy is or that girl is, it's not going to work. So there's a critical element of the behavior is to be on site, is to be present, and is to be willing and driven.
Yeah, and some interesting ones coming through about understanding the existing knowledge and experience within the team. So I guess that comes back to your point about if they don't understand. So it's easy to get these engineers, but then they need to be able to develop the workforce to the knowledge.
Be adapted to the specific requirements of the
and then to be able to manage multicultural teams, be able to measure performance, and be able to organize that workforce in terms of what the organization needs.
Yeah. So
we've got a couple of skills. So being able to use modification tools, need to be IT and OT skilled. So data management at all levels.
Absolutely. Big data, this is where it's coming. And that's another annoying set of skills that these guys need to learn, not just batteries, but also the big data and all of the things that we were hearing in the afternoon about sustainable practices, to manufacturing, digital twins, and all of that stuff. Absolutely critical. So, final behavior.
Not yet.
Not yet. Give some time. It's all basically quite obvious in this case, because this is a well-established job role, which most of the guys actually know personally, people that are doing this production engineering job, I guess.
Got one come through, collaborative.
Yes. So this is a critical aspect of the job, because you are basically coordinating everything. You're coordinating the manufacturing with the R&D, with the customer needs, and all of that needs to be there.
And then communication and instructive. So I guess using that in communication in the right way. and curious.
Yes.
Oh, yeah.
If you look at what the actual standard requires and what is perceived as a need, all of that is transferable. Most of the skills are transferable. Most of the knowledge is transferable. The only sector-specific piece is the knowledge of battery technology and manufacturing steps. So if you train people from any industry on this specific tiny part of that, not tiny, it's critical, you can scale your factory much faster than if you are looking at the battery manufacturing at the moment, in terms on the technical level. So detail-driven, determined, adaptable, and collaborative is what the EU standard requires. So I think that's the last. I'm going backwards. I should be going forwards. It should be the last slide. It should be the last kind of interaction. It was very interesting to hear your ideas and experiences. I hope that you liked the approach that I'm kind of pontificating using the common language. That's the most important part. Everybody should be using something that is universally understandable. So that's my message. Thank you for your attention. Any kind of chairman's remarks or comments or anything for us? Yes, please.
Thank you. So I'm from the battery recycling sector, and there is a huge gap in all of those. As in, when you're looking at design, battery manufacturers need to be talking to recyclers to understand the end of life, because that has to be the priority. Okay, we've got a great battery design and all these chemicals, but can it be reused and recycled?
Yeah.
And that should be the priority at the beginning.
It should be also embedded, like we talk about design for manufacture, and that's a big subject, but we should design for recycling, design for end of life, or design, even the design or selection of materials could be actually, and that's why I'm teaching when I'm teaching master students or PhD undergrads. I'm talking about selection of materials. You select the material that is recyclable. Don't select carbon fiber if you can select aluminum. That's the first message that everybody should kind of get to get this kind of green skill agenda in their head. So definitely.
Yeah, I'm going to push back a little on that because it's just not that simple. If we design for recycling, what are the unintended consequences? Is it less safe? Is it going to have more fires? Does it mess up other parts of the supply chain that destroys other industries? It's very complex. So I think step one is
it has to be considered.
Yeah,
in the beginning, obviously in the contention of other aspects.
The first principles should always work, but it's not going to be a quick change. You think making new battery chemistry takes a long time?
Yeah. It's 15 years.
Yeah.
I haven't seen anything new.
Yeah.
Any other questions, remarks? Yes, please.
Thank you for highlighting that point, because it's a very crucial point for the industry. And as I mentioned, I don't know if you were in the audience when I mentioned about the lack of the automotive industry for the skilled people, especially engineers for the development of the batteries. But one of the, from the society point of view, one of the difficulties that we have is the elderly people reskilling of, it's not upskilling, but it's new skilling from the beginning for the elderly people, because we have some jobs that are disappearing. Mentioned by Dominic, for instance, maybe in the future we will have, very near future, we will have some robots making some jobs. This means like these guys will stay without any job. So we are very, enthusiastic when we say that we are developing autonomous cars. And I don't think that the truck driver passing over there is sharing our enthusiasm. And this is
that's something that we cannot solve.
Yeah.
But what we are also trying to do is to do the public engagement and talk with policymakers about these requirements. So we should all talk to our politicians to actually do something about that in a joint basis or collaboratively or in some kind of a forward-looking way, which is challenging.
I can just share what we do in Romania. Within the Chamber of Commerce, French Chamber of Commerce of Romania, and local authorities, and also the member of the Chamber of Commerce. So we, as you mentioned, we make a circle to define first the areas in which the jobs will be canceled. Secondly, as you do what will be the skills that the member companies will need, not only for the battery industry, but also the battery industry, and also having the local authorities support, not only for the training funding, but also for the recruitment of these guys for the further steps. Because one of the difficulties that these guys, the elderly guys, is that the companies are not having the willingness to recruit these guys having more than 50 years old. So it's a social barrier on which we have to talk. I think the project, in fact, is a very appreciable one. Thank you for sharing that.
Thank you.
Any other questions or comments? All right, so I think we can go ahead and just wrap that up. Thank you to the workshop speakers. So many just complicated challenges across the wide breadth of the industry, right? It's not just technology, regulations, it's a whole slew of things. And that's why events like this, we have different people in the same room talking about these challenges is absolutely critical to solving the challenges. If you don't know about it, you can't fix it. If you stay in your little bubble, which especially a lot of us tech people do, we don't know what's going on. If the recyclers don't talk to the manufacturers, they can't even begin that discussion of designing and changing for design for recycling, et cetera. So with that, I'd like to thank all of our speakers again. Thank you so much for just sticking to time and respecting everybody else's time. Big thanks to the engagement everyone's having here. We had questions asked here, lots of engagement out in networking receptions. So hopefully everyone found it worthwhile. And with that, if there's any final comments from the LeadVent group, thank you as well for putting this on together and organizing it. And it's not an easy feat.
Thank you. Yes, I also, okay, I will do it fast to not interrupt. Scanning the QR code. Yes, ladies and gentlemen, thank you very much for this incredible 2 days. I want to thank everyone for joining us and speakers for your presentations, attendees for listening and all the engagement. And also I would love to thank our chairman, incredible chairman. Thank you for leading us through this day. I know it's very tough and very responsible task to do. Yes, and of course we are looking forward to your feedback. You can email it to us, you can call us, you can talk to me directly. Best way would be to fill out the forms. I know not everyone likes it. If you filled it up, please bring it to my table or to any colleagues that you can catch. And yes, with that, thank you very much for joining us and have a great rest of your day.